simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, living it till it broke up and it rained down. It rained down like rain. Let the waters fall, let them rain.
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
A simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, living it till it broke up and it rained down. It rained down like rain. Let the waters fall, let them rain.
A simple beauty that will catch one's breath.
But they never did, ebbing and flowing and never did, live it till it broke up and it rained down. It rained down like
It is a great pleasure for me to welcome each and everyone to this year's Institute of Integrated Electrical Engineers of the Philippines 3E Expo exhibit opening. I am very glad to acknowledge our high-level participants, exhibitors, and technical professionals being able to join us physically again for the first time in 2 years.
Gentlemen, it is my honor to present to you our guest of honor, the President of the Institution of Engineers Malaysia, Professor Dr. Norlida Buniamin.
My sincere gratitude to the organizing committee of the annual National Convention and Tree Expo 2022 for inviting me as a guest of honor for this very prestigious event. My sincere congratulations to the Institute of Integrated Electrical Engineers, IEE of the Philippines, for their success in organizing this annual convention and expo. It gives me a great pleasure to extend an invitation to all of you present here today. Thank you very, very much.
Today, as IEE's 3E Expo 2022 makes its big comeback in the new normal world, it is with great honor and pride to congratulate the 3E Expo 2022.
Kailangan ko ano? Kailangan ko ditong gawin yan. Boss? Pero wala yun.
Hindi, yung sa ano mo ito.
Boss?
Naka-virtual.
Boss? Hello?
Re-restart niya lang. Sige sa iyo.
Ito.
Ano kami ang setting?
Boss, nagte-testing ba kayo, boss?
Audio.
Jay?
Output. Tama itong virtual.
Yes, Jay.
Re-restart niya lang.
Ayun, narinig ko na. Kaya na, tumatawag na. Pre. Pre.
Hello.
Naka-unmute kayo. Nagugulat ako, nagsasalita kayo eh. Kala ko may testing. Sige na. Sige, pre. Ay, bigyan mo sa natin, pre.
Situated in a small hotel and now boosting it to what is today. I am eternally grateful that we finally make this happen the last 2 years. Now, I can proudly say that IIE is finishing this year strong.
I'm honored to be here to introduce our guests from the Energy Regulatory Commission as we move forward with our continued partnership this year and the next.
Hello po, good morning po. Nandito na po ba si MC? Hello po.
And I am elated and honored with this invitation, and I sincerely thank the organizers for inviting me and everyone for listening. I hope I have imparted some knowledge. Mabuhay ang IIEE, ang akademya, at ang mga individual na ating magiging kabalikat sa pagtugon sa mga hamon.
This is it. By the power vested upon me by the leadership and organization of the Institute of Integrated Electrical Engineers of the Philippines Incorporated, I now declare the IIEE 3E Expo 2022 open.
A simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, live it till it broke up and it rained down. It rained down like
The IIE mission to enhance the competencies of electrical practitioners to make positive contribution towards new trends and technologies. To be an authority of electrical engineering services that results to safe, reliable, and efficient systems. To consistently deliver high-quality products and services duly recognized by international organizations and institutions. To promote awareness on the use of environmentally friendly electrical products, services, and resources, as well as active participation on disaster preparedness and recovery programs. IIE Vision: to be the leading electrical professional organization globally. With 3 Moapo trophies tucked under our belts, it's an ambitious vision, but guys, let's do it. Thank you.
Thank you everyone for gracing IIEE's momentous event as we cross the annals of history. Mabuhay ang IIEE! Mabuhay!
I'm truly delighted and beaming with so much pride and joy seeing everyone physically present today at SMX, as well as those virtually present via Zoom, as we make this big comeback of this much-awaited event. The best is yet to come. Mabuhay ang IIEE.
By the power vested on me by the Constitution and bylaws of the Institute of Integrated Electrical Engineers of the Philippines Incorporated, I now declare this 47th Annual National Convention officially open. Chapter officers, my beloved members, guests, good morning, ladies and gentlemen. So, I take immense pleasure in welcoming you all in this momentous opening ceremonies of IIEE 47th Annual National Convention in the new normal. My heartfelt gratitude goes to everyone for making history unfold as it takes IIEE its comeback. Yes, the best is yet to come. Mabuhay po tayong lahat. Maraming salamat po. Ladies and gentlemen, a pleasant morning to all of us. I am very honored to be a part of your 47th Annual National Convention and 3E Expo 2022. The DOE is more than ready to collaborate and forge strategic partnership with our stakeholders to improve the quality of life of the Filipinos, especially in ensuring sustainable, stable, secure, sufficient, accessible, and reasonably priced energy. On behalf of the Department of Energy and Secretary Popo Retilla, as he is fondly known, I hope for the success of this productive and fruitful convention. Thank you very much. Congratulations, IIEE, and stay safe po tayong lahat.
A simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, live it, till it broke up and it rained down. It rained down like
A simple beauty that will catch one's breath.
but they never did, ever did, ebbing and flowing and never did, live it, till it broke up and it rained down. It rained down like
By the power vested upon me by the leadership and organization of the Institute of Integrated Electrical Engineers of the Philippines Incorporated, I now declare the IIEE 3E Expo 2022 open.
The Institute of Integrated Electrical Engineers of the Philippines Incorporated, IIEE, is the only accredited professional organization, or APO, of electrical practitioners in the country. Created to inspire young minds to develop professionals to be future leaders towards nation building, in line with our mission to excel and our vision to lead. "3E Expo is IIEE's biggest product exhibition in the country, converging the electrical, electronics, and energy sectors in one grand venue. Participated by more than 300 leading companies in the electrical, electronics, and energy industries and allied fields. IIEE 3E Expo is the biggest gathering of electrical practitioners in one extraordinary exhibition. "3E Expo 2023 is the exposition that will showcase the latest trends, products, and services of the participating companies, including organizations engaged in the 3E sector. Expecting more than 10,000 trade visitors, the 3E Expo is anticipated to be the networking event of the year. It is expected to be a venue of endless possibilities, new ideas, and valuable market trend insights on energy-efficient products and services. Join us this year to set another milestone for the 3E Expo 2023, which will showcase technological solutions and the revolutionary designs of innovative products to be showcased by the participating exhibitors.
A simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, live it till it broke up and it rained down. It rained down like
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
A simple beauty that will catch one's breath.
but they never did, ever did, ebbing and flowing and never did, live it till it broke up and it rained down. It rained down like
Gob, good morning, Gob. Hello, Gob, good morning po.
A simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, living it till it broke up when it rained down. It rained down like
By the power vested upon me by the leadership and organization of the Institute of Integrated Electrical Engineers of the Philippines Incorporated, I now declare the IIEE 3E Expo 2022 open.
The Institute of Integrated Electrical Engineers of the Philippines Incorporated, IIEE, is the only accredited professional organization, or APO, of electrical practitioners in the country. Created to inspire young minds to develop professionals to be future leaders towards nation building, in line with our mission to excel and our vision to lead. "3E Expo is IIEE's biggest product exhibition in the country, converging the electrical, electronics, and energy sectors in one grand venue. Participated by more than 300 leading companies in the electrical, electronics, and energy industries and allied fields. IIEE 3E Expo is the biggest gathering of electrical practitioners in one extraordinary exhibition. "3E Expo 2023 is the exposition that will showcase the latest trends, products, and services of the participating companies, including organizations engaged in the 3E sectors. Expecting more than 10,000 trade visitors, the 3E Expo is anticipated to be the networking event of the year. It is expected to be a venue of endless possibilities, new ideas, and valuable market trend insights on energy-efficient products and services. Join us this year to set another milestone for the 3E Expo 2023, which will showcase technological solutions and the revolutionary designs of innovative products to be showcased by the participating exhibitors.
A simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, live it, till it broke up and it rained down. It rained down like
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
A simple beauty that will catch one's breath.
but they never did, ever did, ebbing and flowing and never did, live it, till it broke up and it rained down. It rained down like
A simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, limited till it broke up and it rained down. It rained down like
It is a great pleasure for me to welcome each and everyone to this year's Institute of Integrated Electrical Engineers of the Philippines 3E Expo exhibit opening. I am very glad to acknowledge our high-level participants, exhibitors, and technical professionals being able to join us physically again for the first time in 2 years.
Ladies and gentlemen, it is my honor to present to you our guest of honor, the President of the Institution of Engineers Malaysia, Professor Dr. Norlida Buniamin.
My sincere gratitude to the organizing committee of the annual National Convention and Tree Expo 2022 for inviting me as a guest of honor for this very prestigious event. My sincere congratulations to the Institute of Integrated Electrical Engineers, IEE of the Philippines, for their success in organizing this annual convention and expo. It gives me a great pleasure to extend an invitation to all of you present here today. Thank you very, very much.
Today, as IIEE's 3E Expo 2022 makes its big comeback in the new normal world, it is with great honor and pride to congratulate the 3E Expo 2022 situated in a small hotel and I'm boosting it to what is today. I am eternally grateful that we finally made this happen the last 2 years. Now, I can proudly say that IIE is finishing this year strong.
I'm honored to be here to introduce our guests from the Energy Regulatory Commission as we move forward with our continued partnership this year and the next.
Elated and honored with this invitation, and I sincerely thank the organizers for inviting me and everyone for listening. I hope I have imparted some knowledge. Mabuhay ang IIEE, ang akademya, at ang mga individual na ating magiging kabalikat sa pagtugon sa mga hamon.
This is it. By the power vested upon me by the leadership
and organization of the Institute of Integrated Electrical Engineers of the Philippines Incorporated, I now declare the IIEE 3E Expo 2022 open.
A simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, live it till it broke up and it rained down. It rained down like rain. Let the waters fall, let it rain.
The IIE mission to enhance the competencies of electrical practitioners to make positive contribution towards new trends and technologies. To be an authority of electrical engineering services that results to safe, reliable, and efficient systems. To consistently deliver high-quality products and services duly recognized by international organizations and institutions. To promote awareness on the use of environmentally friendly electrical products, services, and resources, as well as active participation on disaster preparedness and recovery programs. IIE Vision: to be the leading electrical professional organization globally. With 3 MOAPO trophies tucked under our belts, it's an ambitious vision, but guys, let's do it. Thank you.
Thank you everyone for gracing IIEE's momentous event as we cross the annals of history. Mabuhay ang IIEE! Mabuhay!
I'm truly delighted and beaming with so much pride and joy seeing everyone physically present today at SMX, as well as those virtually present via Zoom as we make this big comeback of this much-awaited event. The best is yet to come. Mabuhay ang IIEE.
By the power vested on me by the Constitution and bylaws of the Institute of Integrated Electrical Engineers of the Philippines Incorporated, I now declare this 47th Annual National Convention officially open. officers, my beloved members, guests, good morning, ladies and gentlemen. So, I take immense pleasure in welcoming you all in this momentous opening ceremonies of IIEE 47th Annual National Convention in the new normal. My heartfelt gratitude goes to everyone for making history unfold as it takes IIEE its comeback. Yes, the best is yet to come. Mabuhay po tayong lahat. Maraming salamat po.
Ladies and gentlemen, a pleasant morning to all of us. I am very honored to be a part of your 47th Annual National Convention and 3E Expo 2022. The DOE is more than ready to collaborate and forge strategic partnership with our stakeholders to improve the quality of life of the Filipinos, especially in ensuring sustainable, stable, secure, sufficient, accessible, and reasonably priced energy. On behalf of the Department of Energy and Secretary Popo Retilla, as he is fondly known, I hope for the success of this productive and fruitful convention. Thank you very much. Congratulations, IIEE, and stay safe po tayong lahat.
A simple beauty that will catch one's breath.
But they never did, ever did, ebbing and flowing and never did, live it till it broke up and it rained down. It rained down like
A simple beauty that will catch one's breath.
but they never did, ever did, ebbing and flowing and never did, live it till it broke up and it rained down. It rained down like
by the power vested upon me by the leadership and organization of the Institute of Integrated Electrical Engineers of the Philippines Incorporated, I now declare the IIEE 3E Expo 2022 open.
Sir, pwede ba take off muna yung tayo sa technical? Sa break-up na muna tayo dyan, kung bumuhay ka na muna kami sa break-up ng 7:22. Di ba, Ben, mo yung okay, okay. So, hello, good morning. Good morning. Good morning, SJ.
Hello,
Sir
sir.
Brian, are you here?
Yes, sir. I can loud and clear po.
Si Sir Brian, nakapasok ba?
Parang wala pa po, sir, dito sa loob.
Sige, kasi nagkakaproblema yung sa kanyang hotel pero on the way na siya sa EBS. So, Sir Attorney Barbet, yung MC natin is, I think nandito na siya sa Attorney Barbet.
Hi, hello sir. Andito na po
Hello,
ako.
good
Good
morning.
morning.
So,
Sir, just
yes
wanna
po.
check kasi yung preliminaries natin if andito na po. Andito ka na po for the welcome address. Si Engineer Joseph D. Maghanoy po, andito na po ba for the acknowledgement of delegates, guests and dignitaries?
Yung acknowledgement of delegates will be now be coming from the national because yung we don't have the list dito sa local, nasa national po
So
muna
sino
yun.
po yung acknowledgement? Sino po yung gagawa nun? Kung hindi na po si Engineer Joseph Maghanoy.
Na SJ, may officers, may numbers ka ba ngayon dyan sa as far as participants is concerned? Kasi yung mostly of the officers ay nasa tour kasi sila ngayon nandito ngayon sa Tacloban. They're having their local tour. So, ano yan, Sir Brian? Hello?
Yes, press.
Okay. So, SJ, can you help me please? Sinong officers dito from the national na nandito ngayon? Wala siguro. Meron ba?
Si Gobray pa lang po, sir.
Si Engineer Brian po kasi din yung address of the regional governor. That is after the acknowledgement of delegates and
Okay.
guests and dignitaries. So paano po yun? Siya na lang yung both? Parang ang ano naman.
Sige.
Parang,
Sige. So, I will just ask permission from Governor Brian to proceed. Okay? Give me 5 minutes, 2
alright,
minutes.
sige po. Sige
Sige,
po. No
sige.
problem.
Sige.
Okay po.
Okay.
Sige po.
For HD, are we ready for these slides naman siguro po?
Ay!
Everything.
Sir Diggs,
Yes.
si National President, andito po. Wala. Nasa tour din.
Nasa tour din.
Okay, so
Anyway, this is only
tanggalin,
virtual.
so
This is
tanggalin na lang po
virtual.
natin yung message of the National President sa ano.
Meron
Okay po.
video.
Hello, ma'am.
Meron
may-
video.
May
Meron-
video. Okay, sige po. So video ito. Sige po. Alright, noted po. Sige po.
Sige. Gob. Gob.
Yes, press.
Moving ka?
Press.
Moving po kayo.
Ari lang ko sa hotel na lang press, di na madala kung mo kuan. Ari lang ko magkuan niya mapas.
Okay. So, pwede sir, nasettle na kayo sa ano sa I mean sa link.
Yes, okay na.
Nakasulad na kayo. Sige sir. Sir, with your permission, shall we start?
Wait lang po. Gob Oliver po.
Yes, Oli.
Gob, nasaan yung video presentation po ni Pres?
Hello.
Kay SJ po, Oli.
SJ.
Tinend ko sa iyo yung kahapon, sir. Pa-double check na lang. I-resend ko ulit.
Mga sir, pati po yung IIEE HIM at saka mission and mission, video presentation din po ito.
Yung mission, parang wala na lang muna na turning.
Tatanggalin na lang natin.
Wala pa naman.
Okay po. Sige po. Yung HIM na lang po.
Sige sir.
Okay na yan. Uli na yan lahat. Yung
Okay po. Engineer Brian, yung acknowledgement of delegates, guests, and dignitaries po, hindi pa po namin na-settle kanina. Ikaw na lang po ba ito?
sa chapter yan, ma'am, yung kuan.
Kasi
Chapter secretary sana yan, yung mag-acknowledge.
yung sabi po kasi since this is virtual, wala sa chapter po yung mga names ng attendees.
Yeah,
So,
hindi naman kailangan ikuan lang just to welcome them, then mention yung mga chapters within the region. Yan lang siguro.
Sige sir, I do honor. Wala pa dito yung hindi nakapag-answer.
Usually, kuan yan press, yung sa mga kuan kasi yan, post chapters yung mag-acknowledgement ng kuan ng mga guests natin. So among officers sa inyo dyan, kahit sino na lang sa officers.
So Sir Dig, sino to? Ikaw na lang si acknowledgement?
Sige,
Isasabay mo na lang.
May problema kasi kami dito sa access sa laptop, kaya we don't have choice but to use one laptop muna. And
So,
sige sir, I do the honor.
Sige Sir Dig, so after your welcome address, acknowledgement of delegates na po. Itutuloy-tuloy na lang po natin. Okay, sige po.
Amot na orang nga wifi permit. One EBSO or EBSO? Sir, i-change ko ang wifi, sir.
Ano yun? Makuha na liwat ako.
Re-disconnect.
I-disconnect. Magtitikan na kasi.
Wala pa, magsasandahan mo ni...
Lugar ko rin pa ka mo makakonect with RME?
Nakakunik ka kami, nag-play kami video. Supposedly, sir, Silver, SJ, masandi para YouTube live.
Ayun ako pag pinagyan. Iyan ka muna pag-istorya. Paano kini mga opening pa ako? Kita man. Sir Bry?
Sir, good morning po. Sir, ano na ba natin? Start webinar na po ba natin? Then 5 minutes po para mag-ipon ng attendee.
Sir Brian? Sir Brian?
Pero
Sir
Oli,
Brian?
medyo mahina yung dating.
Sir Brian?
Hello, good morning po. Sir Oliver po.
Proceed.
Yes, sir.
Mag-ano na po tayo? Mag-start webinar po na po para hindi na po naka-practice session.
Nasa kay Sir Brian ang go signal po to start po.
Sige po.
Hintay pa natin ma-stabilize yung si RME, hindi sila makasabay, Oli. Press, anong sitwasyon dyan sa sa venue?
Nasa kabilang room ako, sir. I will try to punta ako kung
Press, kasi na-transfer ko na yung hosting doon sa EBSO account, pero hindi pa sila hindi pa sila nagbo-broadcast eh.
Okay, sir.
Gob, bali, pwede naman po tayo mag-start dito and then share na lang naman nila yung YouTube live, Gob eh.
Sige, video rolling lang siguro muna.
Yes po, puro rolling lang po tayo, puro looping lang po.
Sige, okay.
Okay
Sige.
po, start po tayo.
Okay.
A simple beauty that will catch one's breath.
But they never did, ebbing and flowing and never did, living it till it broke up and it rained down. It rained down like
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
A simple beauty that will catch one's breath.
But they never did, ebbing and flowing, and never did, live it till it broke up and it rained down. It rained down like
Good morning, everyone. Good morning, everyone. Welcome. Good morning, everyone. Ayan, natapos na po yung natin ng ating mga merch. Good morning. Welcome to the 22nd Eastern and Central Visayas Regional Conference. Hello! Ayan, I can hear the palakpakan. This is the regional conference of the Institute of Integrated Electrical Engineers of the Philippines Incorporated, hosted by the latest summer chapter. By the way, magpapakilala po muna ako. I am Attorney Barbette Joanne Magalona Badokdok Reposar, and I will be your host for today para po sa ating virtual at hybrid conference. I believe yung iba po sa inyo ay came from different parts of Eastern and Central Visayas who will be joining us for today's session. So maraming salamat po sa inyong pagpunta. And for us to officially start, I'm quite sure that everyone is already ready at handang-handa na po tayong makinig at mas may malaman pa po tungkol sa ating pag-uusapan ngayong araw na ito. We would like to officially start our opening program. May we request everyone to please bow down your head for the doxology, and it will be followed by the singing of the Philippine National Anthem and the IIEE hymn.
Our ever-loving Father, the core of every reason, the source of truth. You who made the earth and the heavens are the ultimate goal of every knowledge seekers, the infinite wisdom, the cause of all that is good. We are truly grateful for this opportunity to gather together as a community despite the challenges we face each day. Yet you remained and gave us strength to carry on the responsibilities of bearing intelligence and using them for better purposes. We now humbly ask you to join us in our endeavor to explore the wonders of life in the world for knowledge's sake, that in whatever we learn today, we become more grounded to you, who is truth, who is love. We pray that you bless our speakers, the fount of your infinite knowledge, that they can share something worthwhile despite the limited time we have. They can channel all they know and share to us the beauty and truth of living as your child. We pray that you guide our participants, the seekers of your boundless knowledge, that they may continue to persevere in the search and be deemed worthy to share what they learn from today's session. Sanctify us, O Lord, not because we are worthy of it, but because we believe in your love and mercy, that at the end of the day, we can take home something that's amazing and meaningful. This we ask and pray through Christ our Lord. Amen.
Ang pambansang awit ng Pilipinas.
Kayang mag-ibig, pero sa sinananan, alam ng puso, sa dikit mo'y buhay. Upang hinirang, kuya ka ng magiting, sa mandulupin, di ka pasisigil, sa nagatak tutok sa simoy at sa langit ang pangaw, ay hinatang tulakaw, Pursuing excellence in electrical profession, having a dynamic professional association, making innovative contribution to our nation. Rising to any challenge, involving what's comes and goes, B-E-A-R-E-E and R-M-E, connecting industries by the electric circuits. Bind us together, forever, with power cords cannot be broken. Bind us together, bind us together, bind us forever, synchronize our hearts to reach greater heights and brighter lives. We serve humanity with the power of electricity, making rigid transmission great for reliability, ensuring little power loss and high efficiency, from shifting from one place the use of all energy. Bind us together, bind us forever, with power cords cannot be broken. Bind us together, bind us together, bind us forever, synchronize our hearts to reach greater heights and brighter lives. There's only one institute, no one else can substitute. There's only one
And to officially welcome us for our today's session, of course, I would like to recognize the latest Samwar chapter president. A round of applause to Engineer Rodrigo A. Almaden, REE. Sir Diggs, nakamute ka po. Wala pong audio, Sir Diggs. Wait lang it happens. Technical problem happens. Hindi lang po in live shows, but also dito. Sige nga po, Sir Diggs. Wala pa din po, Sir Diggs. Ayan, wait lang na. Ayan, meron na. Ayun, tanggalin na lang yung headset. Ladies and gentlemen, Engineer Rodrigo A. Almaden, RAE. Ayan.
Thank you very much. Of course, let me start my welcoming by, sorry, we have interruptions. Let me have a good greeting with our 2023 Board of Governors, led by our own President, Engineer Lidon R. Bagi, and of course the chapter officers around, and with your respective members, the other guests that who avail for this virtual session. In behalf of the IIA Liti Samar chapter, we welcome you all for today's free conference session for in line with our 22nd IIE Eastern and Central Visayas Conference. So again, this conference will serve as a platform for us in the electrical engineering field, for us to exchange knowledge, explore new ideas, and discuss the latest advancement in our field. So with the remarkable lineup of speakers that we have, they are experts. We are confident that these sessions will be insightful and inspiring, leaving with us with a fresh perspective and ideas to enhance our work. In addition to the enriching sessions, this event will provide an excellent opportunity for the networking and collaborations. So by tomorrow, we'll have our face-to-face session in Summit Hotel. So see you there, gentlemen and ladies. So again, we would like to extend our heartfelt gratitude to the organizers, my fellow officers in the IIEE, of course, to our sponsors and volunteers who have dedicated their effort to ensure that the success of this conference. So their commitment is truly commendable. So once again, welcome for today's virtual sessions for the 22nd IIA Regional Conference. Salamat po.
Thank you so much, Engineer Rodrigo A. Almaden. But Sir Diggs, we will also have to proceed with the acknowledgement of delegates, guests, and dignitaries. I stand corrected kanina kasi I see on the chat box, meron nag-acknowledge they came from Makati, nasa Parañaque. So I believe this is not only actually an Eastern Visayas and Central Visayas event. So Sir Diggs, let us acknowledge our delegates, guests, and dignitaries. Our chapter president for Leyte Samar, Engineer Rodrigo Almaden.
So once again, that's why I already welcomed them all because I was thinking it's one shot. Anyway, the participants that we have, as I mentioned by our MC, this conference is not limited only for the Region 7 and Region 8, but we allowed other IIE members from the different regions all over the Philippines. So thank you for coming. We would like to recognize you all, especially with those IIE members coming from the different regions in our chapters, namely I think in Region 6, Region 8, the Region 4 in the National Capital Regions, and of course the nearby island in Leyte, we have in Bohol. Thank you for joining us. And of course, we have a special place for the registered master electricians that we have. Thank you for joining, sir, ma'am. And overall, we have a count of 109 participants via Zoom. So we would like to I would like to thank you all for joining for today's virtual sessions. Thank you.
Thank you, Sir Diggs. Ayan, 109 via Zoom because actually, this is my first time actually to host ng ganitong activity na may hybrid because mayroon tayong participants doon sa EBSU tapos may virtual pa and then tomorrow we will have our face-to-face. So sa ating lahat po, sa lahat po ng mga andito ngayon, maraming salamat po. To proceed with, of course, hindi po natin palalagpasin ang activity na ito without hearing from our Regional Governor for Eastern and Central Visayas. So ladies and gentlemen, a round of applause to Engineer Brian A. Pasilan, PEE.
Yes, good evening. Hello, Attorney. Thank you for that kind introduction. And again, as first and foremost, I would like to welcome everyone attending this Eastern Central Visayas, 22nd Eastern Central Visayas Regional Conference. And with the leadership of our National President, Lindon Bagi, and yours truly here in Eastern Central Visayas, and with the host chapter officers led by Lete Samar, led by Pres Dix Almaden, and ably assisted by former Gov. Teofic Aidek, and the rest of the chapter officers for this annual event here in our region, Eastern Central Visayas. And this is the opportunity, that we'll be gathering together again, the electrical practitioners in this part of the region. And because of the technology that we have, so not only here in Eastern Central Visayas, but also in the whole country as well. So we'd like to thank everyone that who are attending now via Zoom and via hybrid. And we are very sure that with the topics prepared, with the lectures prepared, the activities that we have, this is going to be a very, very vibrant and dynamic conference that we have for the 3 days, starting today in July 20 and ending in July 22. So again, we'd like to encourage everyone, to actively participate, not just because of the CPD points, but because of the benefits that it will be offering to each one of us, the learnings, the improvement, the network of professionals, and the exchange of ideas and innovations. So let's take this opportunity, this once a year opportunity, to participate in those events. So we have also the sports activities, the regional plenary, which is going to be happening tomorrow. This is the first ever regional plenary open forum ever since in the existence of IIE. So tayo yung nauuna na makon. So we take that also the opportunity to voice our concerns, to raise our issues during our plenary tomorrow. And then again, in the whole of the activity, I hope everyone will be enjoying this one, all the learnings, all the fun, and all the collaboration, with each and every one of us. So again, welcome, and sit tight and have fun, relax, and continue learning and keep on serving. Thank you very much, everyone, and good morning.
Thank you so much, Engineer Brian A. Pasilan. Tama naman po, hindi lang po yung CPD points ha. Of course, this is also an opportunity for us to learn, because you see, learning is a process. Alam natin that in our profession, we do not end with only passing the board exam. But every day, we have to learn and accumulate learnings na magagamit po natin sa ating profession. Kung kaya't, before we proceed actually to the formal lectures, of course, hindi din po natin patatapusin or hindi natin ipapapass by ang ating preliminaries without hearing a message from our national president via AVP. So ladies and gentlemen, through an AVP or a video presentation, let us all hear the message from our national president, Engineer Lindon R. Bagi.
Warm greetings to the Eastern and Central Visayas region. I'm honored to extend my heartfelt congratulations to this dynamic region. It gives me great pleasure to witness the gathering of electrical practitioners for the 22nd Eastern and Central Regional Conference hosted by the vibrant Leyte Samar chapter. Regional conferences such as this play a vital role in fostering collaboration, promoting the exchange of ideas, and driving innovation in the field of electrical profession. They provide a platform for practitioners to engage in meaningful discussion, share best practices, and address emerging challenges faced by the industry. The electrical profession is at the forefront of our nation's development, ensuring the efficient and reliable operation of our electrical system, infrastructure, and technology. Your commitment to continuously learn and professional growth demonstrate your dedication to safe, providing safe,
sustainable, and cutting-edge electrical solution. I commend your infallible efforts in organizing this virtual technical session, which serves as a platform for sharing knowledge, networking, and professional development. I am confident that this conference will inspire and empower our IAEA members to explore new frontier, challenge conventional norms, and seize opportunity for growth and innovation. Guided this year's theme, IIE at 48, moving forward collectively as we pave the way to the world of opportunities and digital innovation, resonates the valuable opportunity to broaden professional perspective, deepen your expertise, and forge meaningful connection with fellow practitioners. By doing so, you contribute not only to your professional growth but also to the advancement of the electrical profession in your respective region. By this regional conference, particularly your virtual technical session, be a catalyst for new ideas, collaboration, and advancement that will drive your region's progress. I have no doubt that the knowledge shared, experience gained, and connection made during this event will have a lasting impact in this ever vibrant and promising region. Mabuhay ang Leyte Samar Chapter, mabuhay ang IIEE, Eastern and Central Visayas Region.
Thank you so much. That is our president, our national president, Engineer Lyndon R. Baggy. Ayan. Andito na po siya ngayon sa Leyte. So para po sa lahat ng mag-a-attend tomorrow ng ating session sa Summit, see you all tomorrow. Makakasama po natin siya tomorrow, of course, with our session. So, tapos na po tayo sa ating preliminaries. I believe meron tayong RMA forum para po yan sa hybrid na nasa EVSU. And of course, may auxiliary activities and dito po sa ating virtual technical session. So, are you ready, guys? Ready na po ba tayong lahat para sa ating virtual technical session? Hello? Ayan, parang yung iba nakamute po kasi. Anyway, just a reminder lang po, when we already start with our technical session po, please use the chat box din po. So if you have question, pwede nyo pong isend sa ating chat box. And I will be reminding, of course, the lecturer, na pag malapit na pong matapos ang kanyang time, 10 minutes before the time, I will remind them that to wrap up in 5 minutes so that we could actually entertain questions na isa-send po sa ating chat box. So, sa mga we are already 114. Ang dami na natin. Opo. Sa mga kajojoy lang po, if you wish to turn on your cameras, that would be very good para alam natin at makita naman po natin ang inyong mga magaganda at gwapong mga mukha. And for questions, please send it po via chat box. So ayan, I think we are all set and I think maraming nagta-thumbs up sa ating chat box. Maraming nagsasabing, let's go. Yes po, ready. Let's accumulate learnings today. And of course, to start off, ang ating first topic po dito sa ating pre-conference technical session is the importance of voltage drop calculation in solar PV system. Just a synopsis po, in solar PV systems, may systematic way to design the size of conductors in order to reduce the voltage drop in various sections in the system. Voltage drops cause a power loss in the system, resulting in inefficient and unsustainable installation. This presentation will explain the parameters to consider and the techniques to learn on how to minimize the voltage drop within the solar PV system. Ladies and gentlemen, we are privileged and we are proud to present to you our resource person for today, all the way from Cebu City, with specialization on design and installation of solar PV system, solar PV training, energy management consulting, and subspecialization on design and installation of industrial motor controls. He is recently or presently connected with Sun Invest Solar Technology as technical director since September of 2017 up to present. He was the IIEE Cebu chapter president in the year 2022. Ladies and gentlemen, engineers, let us all welcome our first resource person on the topic importance of voltage drop calculation in solar PV system. A round of applause to Engineer Magdaleno M. Baclay Jr. Hello, sir. Good morning.
Hi, good morning, attorney. By the way, I'd just like to ask if how many minutes is allotted for this presentation because it's already late.
Yes, opo. Based po kasi sa ating schedule, it's still 1 hour po,
Yes,
engineer. Opo. 1 hour pa din po tayo. So,
1 hour pa rin. Sige.
yes, opo. We will adjust na lang po later on siguro. But as for then, wala naman pong changes because we believe that the presenters have already prepared their presentation. So we'll just cross the bridge when we get there, engineer. I will just remind you later po, engineer, if 10 minutes before the time na po so that you'll be given a 5 minutes to wrap up po. Sige po.
Okay, thank you. I'll share now my slide. Okay. Hello, good morning, everyone. Welcome to our presentation on voltage drop calculation for solar PV systems. Just a backgrounder about this issue of solar PV voltage drops. So I once encountered an installation wherein the system there was using about 10 batteries, and the batteries were all connected in parallel. And so it happens that the voltage is so low and the current is so high that the voltage drop issue is very prominent. No, that's why for us electrical practitioners, we have to be guided and we have to properly understand this issue of voltage drop, especially in low voltage solar installations. So the scope and limitation of this presentation is just a discussion of a small off-grid solar PV, and a discussion of voltage drop in a DC system, because practically small off-grid systems are using DC or direct current. But of course, if they're using AC appliances, you can also have inverter, so you can have also an AC system. In our Philippine Electrical Code, you can see on page 670 a diagram, and this diagram is representation of an off-grid or standalone system. In this diagram, the power source is the solar panel or PV, and there's a PV disconnect, which can be a switch or a disconnect switch or a circuit breaker. And then you have also energy storage, which is the most important and most vulnerable component in an off-grid power system. A lot of issues have arisen in many years because of the issue of poorly designed or poorly installed systems. So in just 1 year, many systems are already malfunctioning or non-operational because of lack of technical skills of the people who prepared the systems. So for us, electrical practitioners, we have to really get familiar with the various components of the PV system, especially energy storage. So if you are using direct current loads, you can actually do away with inverters. So there are systems where they're using DC lights or DC appliances like DC television, for example. So you don't need inverters. In fact, a DC system is more efficient than an AC system because you don't have an inverter which consumes its own power. An inverter has its own self-consumption. So some designers forget to consider the self-consumption of the inverter such that their capacity of their solar panels becomes less, no? So limited ang sizing ng solar panel, not considering the self-consumption of the inverter. So ito po, no? You can check this in our PEC, no? Page 670. Now, just to brief you, no, for those who are not yet into the solar technology, we need to discuss some very basic concepts. For example, if you have a solar panel, let's say, for example, a 100-watt solar panel, it's made up of solar cells. And if you connect, for example, a 100-watt panel with another 100-watt panels, or let's say 4 panels in series, we call that series connection of solar panels as a solar string. A solar string is a series of solar panels. Now, if you connect the solar strings into the other solar strings, you will get what we call a subarray. So in this example here, you will see 2 subarrays. Now, each subarray is rated at how much? You just add all the solar panel capacities. For example, how many panels we have? So 1, 2, 3, 4, 12 solar panels times 100. So that's about 1,200 watts of subarray. Then there's another subarray, which is 1,200 watts. So you get a total of 2,400 watts capacity of solar panels. Now, please be informed that solar panels rated capacity does not cannot be harnessed when they are installed at the site. No? For example, if you have a 2,400 watt solar capacity, you cannot expect that it will be 100% 2,400. There will be losses. No, there will be losses on the solar panels. So these are just the rated capacity, but in actual use, this will not be 2,400. It will be lower. For example, maybe about 80% of 2,400, because of effects of temperature. No, if the temperature is increased, the solar power output is decreased. With increase in temperature, there's a decrease in power output. And then also there's factors like dirt on the surface of the solar panel and many other losses like the wiring and the voltage drop. No? Voltage drop is a power loss in the system. One time when I inspected this installation that I mentioned with the 10 batteries, there's a big power loss on the wires because that system use only a small wire. No, instead of using a bigger wire, we use a small wire because probably the designers or installers didn't have proper training or no background sa electrical design. So they just put everything, connect everything, and then not considering all the factors like voltage drop. Okay. So this is the explanation of solar string and solar subarray. Next, when we design the system, when we prepare our design, we need to understand two things. No, we need to get two data of the solar panel: the short circuit current and the open circuit voltage. These are important parameters when we will be preparing our design of the wire, of the sizing of the wire. For example, there is a 55-watt solar panel here, and the short circuit current, which you can find at the back of the solar panel, at the nameplate of the solar panel, the IEC or short circuit current is 3.45 ampere, and the open circuit voltage is 21.7 volts. By the way, these two terms, IEC and DOC, are taken from the IV curve of the solar panel. For us engineers and master electricians, we need to study the IV curve when we will be dealing with solar PV systems. The IV curve is some sort of the beginning and end of solar PV. So we have to really understand this concept, no, of IV curve or current voltage curve, which is given in the data sheets of the solar panels. For example, 55 watts is connected in parallel. So what happens if you connect the two panels in parallel? What happens to your IEC? Your short circuit current will be increased times 2, no? So because, you know, when you are connecting in parallel, the current will be added. So 3.45 times 2, that will be 6.9. But your VOC or open circuit voltage is still the same because they are in parallel. So the total watts or rated capacity of the system of the total, no, is 110, 55 times 2, so 55 watts. So 110 watts. Then if you connect it in series, what happens is you will increase the voltage. No? The VOC is added. The VOC1 and VOC2 is added because they are connected in series. So the VOC is 21.7. Then there are two solar panels in series. Therefore, your total VOC is 43.4 volts. But still, your capacity is 110 watts. Now, what if you will increase the number to 4 panels and then they're connected in series parallel? So the same analysis, if they are in parallel, you add the currents. But if they are in series, you add the voltage. So your new IEC in this case is 6.9 ampere and your VOC is 43.4 volts. Then the total capacity is 220 watts. So I hope this is clear because when you will be designing even on-grid systems or hybrid systems, the same concepts will apply when you will be preparing, no, your numbers. For example, what is your total current from that array? Or what is your total voltage from that solar array? So the same steps or procedure will be applicable. Again, going back to this on-grid or off-grid system, basically the off-grid system is also called a standalone system, meaning the system does not have any other power source. Your only power source in this case is a solar panel or a solar array. Now, if you're using AC system or AC loads, you will need a standalone inverter. Now, take note that these types of inverters are different from the on-grid inverters that are available in the market. For example, after the Typhoon Odette here in the Visayas and Mindanao, after a lot of on-grid inverters were installed, no, on the roof. I mean, on the houses, and they have solar panels on the roof. But because of the blackout, those systems, on-grid systems, were useless. They did not function because they are not designed for off-grid. No? Those inverters will need the utility, no, power in order for them to function. However, for standalone inverters, they can operate without the utility power. So this is applicable for, let's say, islands or remote barangays, for example, in mountains. And of course, the main device, no, that will make these things happen or operational is the battery. Without the battery, you cannot have a standalone system. The reason is the battery is energy storage and it's also the stabilizer in the system. Stabilizer meaning if there is a sudden decrease in irradiance because solar panels are dependent on solar radiation. With sudden decrease, like there is a cloud or sudden shadowing, no, of the solar panel, your current output from the solar panel will drastically reduce. So who will compensate, or what component will compensate for that reduction of solar output? It's the battery. So that's why it's called a stabilizer in the system. Okay, these are the main components of an off-grid solar power system. Number one, you need the storage battery, which is the key device and also the most vulnerable device, especially lead acid batteries, which are still used, no, in many off-grid power systems. And then, of course, you have a charge controller for battery protection. Then you have the solar panel as your power source. And then you can have DC appliances or AC appliances, which will require you to have an inverter. Okay, so you take note of the direction of these arrows. For example, from the solar panel is a current source. No? It's a current source of current. So whether you like it or not, if there is a sunshine, no, there is a sunlight, there will always be current that is coming out from the solar panel. And then the solar panel is connected to the charge controller. Now take note of the battery. The battery direction. One arrow is going down and the other arrow is going up. This means you can charge the battery or you can discharge the battery. This is the meaning of the arrow. So sometimes, one time I have an experience, in one visit to a power plant somewhere in Mactan, I have visitors who are not engineers. No, they were asking me, when you have a solar panel and then you have a load, no, what is the flow of energy or what is the flow of current? So they were thinking that before the current from the solar panel will reach the load, it will still have to pass through the battery. That was their understanding. No? Dapat daw na dadaan muna ang kuryente doon sa battery before makalabas yung kuryente patungo sa mga load. And that is wrong. No? Because if you have a system like this, you have a battery, then you have load. If you have sufficient solar radiation, you can simultaneously charge the battery as well as supply current to your load simultaneously. Now, the characteristic of such a system is that whatever is needed by the load, no, for example, let's say you have lights, no, that is the priority that will be supplied by the solar panel automatically, no. And then what is the excess current from the solar panel will go to the battery. Now, if there is insufficient supply from the solar panel, then your battery will add current to your load. No, in parallel with the solar panel, sometimes the solar panel and the battery will work together to supply the required current to your load. That is the behavior, no, of the system. So system behavior is a very important skill. Assessing the system behavior is a very important skill for an electrical practitioner. Many people who are installing, no, a lot of people who install solar systems do not know how to assess or evaluate their system. Right now, I am visiting, no, Leyte, Masset, Southern Leyte, and I noticed that there is a really lacking in capability of people to check whether systems are working correctly or not operating correctly or properly. So there is really a general lack of technical capability in assessing systems, whether they are working properly or not working properly. This is a challenge. This is a challenge for us electrical practitioners to get the proper skills. Because without understanding the parameters that are happening in an installation, without understanding, we cannot say that we are really, let's say, a so-called expert in the technology if we didn't understand the parameters. No? A lot of people are capable, of course, no, in installing. But what about assessing whether what they installed is properly operating? That is a skill, no? Another skill set that needs to be, acquired by us practitioners or installers. Okay, so this is the example of the standalone system that I mentioned. Now, just for illustration, let's say we have a 50-watt solar panel or a solar home system, and let's calculate the size of wire from the solar panel to the charge controller. Actually, the sizes of wires from the different sections of your PV system. No, if you notice in this diagram, there are different sections of the PV system. There's a section between the solar panel and the charge controller. There's another section between the battery and the controller. And there's another section between the controller and the load. So these are circuits. No? These are electric circuits. No? Connected. No? Connecting. These are electric circuits connecting the different components. So we need to properly size the wires that are connecting the different components in the system. Okay. Now, before we answer this illustration, let's define first voltage drop. What is voltage drop? Voltage drop is basically calculated using Ohm's law. You know that Ohm's law is current times resistance. So since voltage drop is a concern for conductors, for wires, take note that copper, for example, copper wires, let's say the 3.5 inch squared or 5.5 inch squared HSN that we're using, those wires have internal resistance, or those have resistance. You have resistance. And therefore, if there is a current flowing into this wire or through these wires, there will always be a voltage drop, because you multiply the current that is flowing there and the resistance in that wire, you get a voltage. Now, a lot of practitioners, by the way, are a little bit confused about this voltage drop. I have been into the solar training since 2005. No, since 2005, I have always observed that many electrical practitioners, although they are good in mathematics, no, but many of them forget the basic one. That's why let's review this basic about voltage drop. Okay, voltage drop is a power loss. Why? For example, if you have a wire, no, and then there's current, let's say 10 amperes, and there's a voltage drop on that wire, let's say 1 volt. No, we know that power is voltage times amperes. No, so 1 times 1 volt times 10 amperes, that's 10 watts. So that's a power loss. What is the manifestation of that loss on a wire? The manifestation is the heating, no? Muinit mo. Iinit yung wire. That is energy, no? Energy loss. The heat. No? That is energy loss. For example, your current is 20 amperes and your voltage drop on that wire is 2 volts. Then your power loss is 40 watts. That power equals amperes times volts. Or it could be calculated by the other formula, I squared R. So if you have current, let's say 20 amperes, the resistance, I squared, you get the power, the same result, if you know the resistance. So I hope this explanation of voltage drop is clear to us. Okay, cable resistance is determined by size and length. For example, if you have let's say 4 mm squared solar wire. Right now, many installers are using either the 4 mm squared or the 6 mm squared solar wire. So the resistance, no, of the total resistance of the wire is determined by the diameter, let's say 4 mm squared, or the length, let's say from the solar array to your inverter or to your disconnect circuit breaker, let's say 10 meters, for example. So the longer your wire, you will have higher resistance in all. So to reduce the voltage drop, you need to use a thicker cable or minimize the length of the cable or use a higher system voltage to reduce the current. No? Itong number 3, use of higher system voltage to reduce current. Many installers are misunderstood this. No? A lot of installers misunderstand what is this system voltage. For off-grid, because this is our topic, off-grid systems, you have 3 choices actually. Either you can use 12-volt system, you can use 24-volt system, or you can use 48-volt system. A lot of installers who are DIY, they just buy, from any supplier, and then they don't consider the effect of the components that they buy. For example, I just visited a friend here. He bought two pieces of 420 watts, 450 watts solar panels, 2 pieces. But the inverter that he bought is rated at 12 volts input. It's 2000 watts, but the system input voltage is 12 volts DC. So with that decision to buy that inverter, off-grid inverter, that's gonna require big current, big wires, because a low system voltage will result to higher currents. That's why when you are preparing your project, make sure that your components are properly rated. For example, as a rule of thumb, no? If your solar panels are already 200 watts above, then your system voltage should be 24 volts or above, not 12 volts. That's the rule of thumb. No? In order to minimize the current or reduce the current, and also to save on the cabling, no? Because if you have a higher system voltage, then you have lower currents, and lower currents means you don't need bigger conductors, so you can save on your installation cost. You can save on the wires. So that's the meaning of that, the use of higher system voltage. Now, voltage drop is critical in low voltage systems like 12 volt systems. No? So I will explain further by this illustration. Let's say you have a light bulb, no? And then this is connected to your power source. This could be a battery or a terminal from the charge controller. Now the distance from your power source to your bulb is 20 meters. Now the wire that is used in this case has a resistance of 0.02 ohms per meter. By the way, this example, no, a lot of our fellow colleagues in the profession, sometimes they really misunderstand this example. I will elaborate further. So the distance is 20 meters, and the resistance of the wire that is being used here is 0.02 ohms per meter. Ang tanong po dito, or the question is, what will be the voltage at the terminal of this light bulb? Huh? That means the source voltage is 12 volts, and there's a distance of 20 meters, and there's a resistance of the wire. So as we mentioned, there is voltage drop because we have current, let's say 5.5 amperes. This is the required current of the bulb. If you have current, if you have resistance, then you will have voltage drop. Now, remember, the electric circuit in this case has 2 wires. That means each wire has a voltage drop, and let's say this is positive. The positive wire has a voltage drop, and the negative wire also has a voltage drop. Many practitioners who solve this type of problem, they forget that there are 2 wires. Nakalimutan nilang mag-isip na dalawang wire yan. No? So dalawang voltage drops for each, one voltage drop for each wire. So the solution is here. No? So to get the total resistance of the wire, okay, let's consider one wire. The total resistance will be the 0.02 ohms per meter of the wire times the length of the wire. Ito, no? 20 meters times 0.02 divided by the current. Because, of course, Ohm's law, di ba? Voltage, current times voltage, current times resistance. No? Current times resistance. So the result is 0.2 volts or volt, 0.2 volt per wire. Per wire. Isang wire lang. Since there are two wires, so yung 0.2 volts sa isang wire, i-multiply mo ng 2 to get the total voltage drop of the circuit. So yes, this is a circuit. So the total voltage drop is 0.4. Therefore, the voltage drop is 0.4, and then therefore the voltage at the terminal, no? The voltage at the terminal of the bulb will be 12 minus 0.4, which is 11.6 volts. Okay? So, for example, if this bulb will not light, let's say, at below 12, no? So, if this, for example, if this bulb will not light at 12 volts, so because of voltage drop, this will not light up, no? Because the terminal voltage is only 11.6. But of course, right now, the DC bulbs in the market, they can light up from the range of 10 volts to, I think, 36 volts. Meron ng mga DC bulbs na capable of lighting up from 10 volts to 36 sa mga DC bulbs na available. Okay, so this is for one load. Now, there's another example. There are two bulbs here. Again, each bulb will require 0.5 ampere as their input current. Now, because of Kirchhoff's law, if there's a junction here, so 0.5 plus 0.5, then therefore your total current from the current source from your source is 1 ampere. No, it's this 0.5 plus 0.5. And then take note that there are different distances. Let's say, for example, from the source to the junction box, this is 10 meters. From the junction box to the first light bulb, it's 10 meters. But from the junction box to the second light bulb, it's 20 meters. So in order to get the terminal voltages on the light bulbs, we need to calculate for the voltage drop, as we have already done in the previous example. For example, sa first voltage drop, itong pinaka main source, no? So you have 1 ampere here, and then let's say we still have the same wire, which is 0.02 ohm per meter a wire. So 10 meters times 0.02, you get the resistance of that one wire. But there are two wires, so multiply natin ng dalawa, ng 2. Then the total resistance, you multiply by the current, which is 1 ampere. So the voltage drop on this section of the circuit is 0.4. On the second section, the voltage drop 2, this is the calculation. So you have current, which is 0.5 ampere. And then you have total resistance calculated by 10 meters times 0.02 times 2. 2 wires. Ito yung sinabi kong mga problema, no, ng ating mga kasama. Makalimutan ay multiply ng 2. I have checked a lot of papers before, no, sa mga exam ba natin sa solar training. Itong number 2, nakalimutan. Not knowing dalawang wire yan. No? Isang circuito, dalawang wire. So the voltage drop of this section is 0.2 volts, and the same for the last one. No? So the voltage drop is 0.4. Okay. So notice that the voltage at the terminals of each bulb is different. So sa light bulb 1, the voltage at the terminal is 11.4, and the other bulb has a terminal voltage of 11.2. No? Paano nakuha yan? Of course, you start from your source. Okay, let's say for the first one, for this light bulb here, to get the voltage at the terminal, you get the source voltage less the voltage drop of the first section here, which is 0.4, minus the voltage drop of this section 2 here, which is 0.2. So 12 minus 0.4, 12 minus 0.4 minus 0.2, so you get 11.4. And then for the second one, again 12 minus 0.4 minus 0.4, because this is a bigger. Why is it that the section 3 has a bigger voltage drop? Because it has a longer wire. A longer wire means you have a higher voltage drop. So your terminal voltage of your load 2 is 11.2 volts. So again, this illustrates the effect, the effect of voltage drops on the voltages of the terminals of the components in the system. I hope this is understood. Now, in our design of solar PV systems, especially the low voltage systems, voltage drop is critical between the charge controller and the battery. Why is it critical? Because the purpose of a charge controller is to protect the battery from overcharge or over discharge. So what it senses is the voltage. The charge controller senses the voltage. So dapat ang mas-sense niya na voltahe hindi malayo sa voltahe ng battery. No? Sa terminal voltage ng battery, dapat sana pareho, no? Kung ano yung voltahe ng battery, dapat yun ang mabasa ng mas-sense ng charge controller. Although imposible yan dahil mayroong resistance ang wire. Dapat mayroon kang wire na i-connect, no? From your controller to your battery. So, dapat meron talagang yan, no? Voltage drop because of the resistance in the wire. Now, in this example, the limitation value should be stated by voltage instead of percent. Diba sa tayong mga electrical engineer, we are used to thinking that the voltage drop should be not more than 3% or not more than 5%, no? Between certain sections of our system, no? But for low voltage systems, it does not apply because if you apply 5%, let's say kung 11.1 volt yung yung voltahe, no? Let's say at the controller, no? For example, kung 11.1 volts yan, ang 5% is 0.56. So meaning that voltage drop, no, na 0.56, mas mataas yan, no? Mataas yan, for example, sa between the controller and the battery ba, no? It's 0.56, which is allowed yan. Ano ba yung ano po ang allowed na voltage drop between the battery and the controller? It's 0.1, no? Or 0.1 volt ang allowed na voltage drop between the battery and the controller. So 0.56 does not sobra na sa 0.1. Now kasi yung battery kasi hindi yan hindi yan constant 12 volts. Meron siyang operating range, no? Ang battery has an operating range typically from 11.5 to 14 point something. So may operating range. So at 12 volts, for example, ang voltage drop dyan, kung 5% ang allowed, is 0.6 volts, which is more than 0.1. Kung let's say, halimbawa, tataas yung voltage, no? Voltage drop is 0.72. No? Sobra, no? So, hindi siya po applicable yung percentage. Ang applicable po for low voltage systems like 12 volts is in each section, let's say from solar panel or PV to CC. CC stands for charge controller. The maximum voltage drop allowed on that section is 0.5 volt. Because larger voltage drop may cause not enough PV output voltage to charge the battery. Actually po, malalim po ang analysis dito sa voltage drop of the PV to CC. One time when I visited nga yung isang site, no? He has 200 watt solar panels times 4. Lahat ng solar panels connected in parallel, so malaki yung kurente, no? IEC or output current, malaki, tataas times 4. Kasi 4 na parallel. Now kung yung maliit yung wire mo dyan, from your panel to your controller or inverter, maliit yung wire. So, mataas yung resistance. Alam naman natin kung maliit yung wire, yung diameter yung wire maliit, the resistance is high. But if the wire has a big diameter, no, the resistance is lesser, no? Yan ang ano po, characteristic ng copper wires or aluminum wires. The bigger the wire diameter, the lesser the resistance. The smaller the wire diameter, the bigger the resistance. Yun po ang dapat makakuha natin, no? Maalala. And then, notice po, no? Na between the battery and the charge controller, it has the highest, no? It has the highest allowable maximum voltage drop. It's only 0.1. Why? Because again, as I mentioned, the charge controller controls the battery voltage precisely. So, kung halimbawa, for example, malapit na mag-LVD yung battery, dapat i-ano niya, no? I-turn off niya yung ano, load para hindi na mag-discharge yung battery. Or kung malapit na mapuno yung battery, dapat i-turn off niya yung panel, no? So again, ang role ng controller is to protect the battery from overcharging and over-discharging. That's why the control, no, has to be very precise. That's why we have a 0.1 volt na voltage drop, allowable or maximum voltage drop between that section. Between the load and the charge controller, the allowed or maximum voltage drop is 0.5 to 1, which ensures that the appliances will work, no, till the low voltage disconnect or LVD. Okay. The source is Dr. Akayushota. He was our professor from he's a JICA international expert in solar PV. He was sent here in the Philippines way back in 2005, and he was the one who introduced this, no, to the Department of Energy engineers before. Now let's go back to our example na 50 watt solar panel. So when we will be designing the wiring, no, we'll be designing the wire. We have to get the data sheet of the solar panel, no. So take note, mga designers sa mga solar, we need to collect, no, the data sheets of solar panel, data sheet of inverter, data sheets of controllers, etc. No? Data sheets of batteries. We need to have data sheets when we'll be designing. No? We have to have a basis of our design. So in this case, our basis is the data sheet of a solar panel. So the rating is 50 watts. Ang dalawang useful po na information is short circuit current and the open circuit voltage. In this case, the short circuit current is 3 amperes. 3 amperes ang short circuit current. So we'll be using this number in our wiring design. So paano po? Now, in this illustration, this is a 50 watt solar panel, and we want to size up the circuit between the PV and the charge controller, CC or charge controller. The length of this cable is 6 meters, or the distance is 6 meters. Huh? So, according to our Philippine Electrical Code, according to our Philippine Electrical Code, the sum of the parallel connected PV modules rated short circuit current. Now, walang parallel to, isa lang siya. So, isang panel lang, no, ang consider. I-multiply daw ito, it should be multiplied by 125%. The short circuit current should be multiplied by 125%. So we need to have a number naman in order to size up the wire. So we multiply the IEC, which is 3 times 1.25. You get 3.75. So this is maximum current. But for capacity calculation, pang recommendation ng code, multiply ulit siya ng 1.25 or 1.5%. So yung resulta, 3.25, will multiply by 1.5 again. So we get the 4.69 as our basis for sizing. No? You can even increase this number by applying also the rating. No? Let's say, for example, you want to derate this based on the temperature or the ambient temperature. For example, yung mga wire kasi nasa taas yan, di ba? So ambient temperature will be higher. But let's just forgo that. Let's just consider this lang muna for illustration purposes. So right now we have a 4.69 ampere as our basis for sizing this wire. Now, immediately we will think that let's go to the PEC table. Kasi meron naman tayong table doon, di ba? Ang ampacities. Surely, pasok to sa sa 2 mm squared. No? Kaya to. Kasi 2 mm squared, kaya yung 15 amperes. But in our case now, we don't apply that yet, no? Because we need to consider the voltage drop. Again, there's an allowed voltage drop between this section, between the PV panel and the charge controller. No? Ito, no? For example, itong ano to ba? Itong provision ba na ang voltage drop na maximum is only 0.5 between the PV and the charge controller. So, the voltage drop limit is used for sizing the cable in low voltage DC systems. So, ito yung illustration. So, the same diagram kanina, at ano lang natin, parang kina-carve out natin just to highlight this section from the solar panel to the controller. Now, the distance is 6 meters. Now, we don't know yet what is the wire size here, but we know and we know that the allowed voltage drop is 0.5. Now, kung 0.5 ang voltage drop na allowed, this 0.5 refers to the total voltage drop of the two conductors. That means if we consider one conductor, what would be the voltage drop per conductor? It will be 0.25, correct? Because you divide 0.5 by 2. Kasi 0.5 here in this table is the total voltage drop. So if you divide by 2, get voltage drop allowed for one conductor. We know the current, which is 4.67. Therefore, using Ohm's law, resistance was voltage drop over current. No? V over I, Ohm's law. So 0.25 divided by 4.69, you get 0.0533 ohms. Okay? So this is your resistance of one wire. Now, we know for a fact that a 1 mm squared copper wire has a resistance of 0.02 ohms per meter. Okay? Now, by ratio and proportion, we can actually calculate the size of the wire. No? So in this case, the size of the wire will be x over 1 mm squared equals 0.02 over 0.008. Bakit ganito po ang arrangement ng ratio and proportion? Because the indirectly proportional po ang diameter sa resistance. No? Sa sinabi ko kanina, the bigger the diameter, the lower the resistance. The smaller the diameter, the bigger the resistance. Kaya inversely siya, no? Makita natin inverse. So ang resulta nito is 2.25 mm squared. Wala namang so tayo as in solar, wala namang 2.5 available sa market. So you have the option to use either the 2.5 mm squared or the 5.5 mm squared. Okay? Or the 4 mm squared, which is available in the market. Attorney, are we still on time?
Yes, engineer. Actually, I was about to inform you that you have last 10 minutes, so 5 minutes to wrap up so that we can have
Okay,
5 minutes of the open forum. Just in time. Thank you, engineer.
Sige po,
Proceed
okay.
po.
Thank you, attorney. Okay. So again, I hope this is clear. So we got the size of the wire by ratio and proportion. Now, if you wonder why is it 1 mm squared 0.02 ohms per meter, actually you can check this out doon sa PEC natin, no? Doon sa table of resistances. I-derive nyo yung 8 mm squared, for example. By deriving it to 1 mm squared, you will get that number 0.02 ohms per meter. Okay. So in conclusion, for low voltage systems, specific voltage is specified for voltage drop calculation, not percentage. And now this one, no? The most critical part is the section between the controller and the battery, which is what is the allowed voltage drop between the controller and the battery? For 12 volts, it's 0.1 volt. Ito, 0.1 volt. So 0.1 volt for sizing the wire, no? This is a total voltage drop. So for sizing one wire, you divide by 0.1 by 2. So that's why you get 0.05. Using the same procedure, you'll get the size of wire is 1.87 inch squared. Of course, there's no 1 inch squared wire. So it's up to you, no, to choose a minimum 2, but you can increase to higher, to bigger wire. Let's say 5.5 inch squared, no, to really reduce the voltage drop. So again, in conclusion, no, when we are sizing wires for low voltage systems, it's very important na i-apply natin ang ito mga parameters ito. For example, kung 24 volts, ano po yung voltage drop dapat between the controller and the solar panel? It's 1 volt. I-times 2 lang. Yung galing sa 12 volts, i-times 2 lang. So, you have 1. So on, no? Sa 48 volts times 2, ang 24, i-times 2. So, yun ang 48 volt system. So, these are very useful for us when we will be designing our circuits for off-grid, standalone systems. So, this is a summary, and if you need copy of this, I will share this to our organizer so that you can disseminate this information. That's it. Thank you very much for your attention.
Thank you so
Sige,
much,
Tony. Okay.
Engineer Magdaleno M. Baclay Jr. Palakpakan naman po natin. Ayan. Sir Engineer, meron po tayong question
Yes, sir.
here. So we are now
Yeah.
on our open forum part. So for those of our participants who have questions, please send it po sa ating GC. So, good morning, Engineer. Is there a different calculation for submersible cable that are used for deep well pump? Yun po yung question niya. May different
Okay.
calculation po ba for submersible cable that are used for deep well pump?
Okay. Submersible pump. Again, ang natin, basis for sizing the wire, still, same procedure. You need to have the length, the distance from the, let's say, kung submersible pump yan, meron kang inverter dyan sa taas. Then you have a very long wire going downward, no, to your source of water. So dapat you have to have a very accurate estimate of the length of your wire. Okay, and then you also have to have the data of the pump of the motor. Ano yung voltahe na dapat na kailangan doon? Is it 220 volt pump, or is it for 400 volt and so on? No? So you need to really know what is the required voltage doon sa terminal ng pump. Kung malaki naman yung voltahe doon, hindi masyado issue yung voltage drop. Kung malaki yung voltahe, ha? Kasi yung voltage drop kasi is very critical sa mga low voltage systems. Yan lang po.
Okay. Thank you so much, Engineer. That is from Engineer, sino yun? Engineer Algie. Mayroon another question po from Sir Jeffrey Pahayahay. Sabi niya, thank you, Engineer, for the very informative presentation. Business perspective po, ilang years po ba ang return of investment for with and without battery system? Ilang years daw po ba
battery,
yung...
no?
Opo, ilang years po ba daw yung return of investment for with or without battery
With or
system?
without battery. Okay. Systems with battery, for example, unfortunately, mahal kasi yung battery. In fact, I'm doing a study of a big system here in Leyte. Initial calculation ko po is parang 10 years yung ROI basta may battery, no? Mga 10 years ba? Ang simple payback, dahil sa talaga, no, napakamahal yung battery. That's why kaya nga sa mga off-grid na mga island sa ating Pilipinas, wala na dito ang solar power system. Wala na negosyo. Bakit? You need to change the battery, let's say every 5 years or 10 years. And the battery is the most expensive component in the system. mas mahal pa ang battery kaysa solar panels. Kaya mataas yung ROI. Kung walang battery, let's say on-grid system, yung let's say for example, yung mga roof-mounted on-grid, mga ROI dyan is mga 3 years na ngayon, no? Dahil pag mag-increase yung if the price of electricity increases, lalong ano po, the more is solar more viable. If the price of electricity from the utilities will be increasing. Solar panel is very ano po, very good option to reduce your ano po, power cost, especially for systems without batteries. 3 years, 4 years, ganun.
Thank you so much, Engineer. And last question po, because we will have to proceed with the next presentation. Engineer, ito po yung last question. Is it the same voltage drop between off-grid and on-grid setup? This is from Engineer Ray Floreto.
Actually, it's different because in on-grid setups, usually po, let's say you have a 5 kilowatt on-grid grid tie system, no? Your system voltage on the DC side from the PV array to your ano po, your solar panel or your inverter, mataas po yung voltahe. Mga ano po yan, mga siguro 400 o mga 250 to 400 volts or even higher, no? So hindi masyado po problema ang voltage drop doon sa on-grid setup. Kasi mataas yung voltage system voltage sa section na yan, no? Sa solar panels to your inverter, mataas. From 250 to, let's say, 400 volts. Yan. So, hindi siya critical po. Lalo na kung hindi masyado mataas yung wire. But if mataas yung wire, mahaba. Let's say, from your solar array to your inverter, let's say, more than 50 meters, yan. Critical na yan ang voltage drop. So, you have to calculate. You have to calculate the voltage drop. Pag mahaba yung wiring mo. No? Lalo na yung mga mag-design ng mga solar farms na mahaba yung takbo ng wire from the solar array to your inverters.
Thank you so much, Engineer Magdaleno and Baclay Jr. Sir, actually, marami pa po yung question, Engineer. However, medyo kinukulang na po tayo ng time. That is why we will be entertaining 1 to 3 question per speaker lang po. So, before we end, and before we proceed to our next speaker, of course, it is just and proper, of course, to present our plaque of recognition virtually to our speaker. So the plaque of recognition reads, Institute of Integrated Electrical Engineers of the Philippines Incorporated, Eastern and Central Visayas Region, latest summer chapter. Plaque of recognition is hereby presented to Engineer Magdaleno M. Baclay Jr. in grateful acknowledgement of his invaluable service rendered as technical resource speaker during the 22nd Eastern and Central Visayas Regional Conference. Given this 20th day of July year 2023 at Summit Hotel, Tacloban City, signed by the President of Leyte Summer Chapter, Engineer Rodrigo A. Almadin Jr., REE, and the Governor for Eastern and Central Visayas Region, Engineer Brian A. Pasilan, PEE. Maraming salamat po sa very interesting topic po, Engineer. Thank you for sharing us your knowledge, and I'm quite sure that all of our participants were able to grasp knowledge po in advancement po sa inyong profession. So maraming salamat po, Engineer. Thank you. So ladies and gentlemen, we will proceed with our next presentation. We will be having our sponsored technical presentation from the Commons Sales and Service Philippines Incorporated. So from Common Sales and Service Philippines Incorporated, we have here their Senior Application Engineer to present their products. Ladies and gentlemen, to present Commons products and its differences, a round of applause to Engineer Joshua Valle. Hello, Engineer. Good morning po.
Hello, good morning. Thank you, Attorney, for that introduction. Good morning, everyone. Let me just quickly share my screen. Right, I hope that's okay. Yeah. Thank you, Attorney, for the introduction. Good morning, everyone. Once again, my name is Joshua Valle. a senior application engineer of Cummins Sales and Service Philippines Incorporated. On behalf of my company, we would like to express our gratitude to the leadership of IIEE, both for national and regional, for giving us this opportunity to present our products and our services to all of you. This morning, I would like to share to everyone about Cummins products and its differences. But before that, a very short introduction about our company so that you know who Cummins Sales and Service Philippines is. So Cummins Sales and Service Philippines Incorporated, or Cummins Philippines, is the sole distributor of Cummins genuine products in the Philippines. We are 100% owned by Cummins Incorporated USA. So we are not just a partner, we are not just a sub-dealer, but we are Cummins Incorporated's presence in the Philippines. So Cummins Philippines po is the sole distributor of Cummins products in the Philippines. We are a member of, and it is under the Directorate of Cummins Asia Pacific, regional office located in Australia. We have, Cummins has recently regionalized, so we are reporting to the Southeast Asia Pacific region, but we are, again, fully owned by Cummins International. We are the only Philippine entity that can legitimately represent Cummins, its brand, and its manufacturing facilities, among others. And we are also the sole channel that connects you to our source factories in the UK, China, India, and USA. We are the only authority that can accredit whole goods and services, service dealers of Cummins products. That means that we are the only ones that will accredit Cummins branded engines, alternators, controls, all of those genuine Cummins products. We have the authority to accredit certain sub-dealers who would like to partner with us, especially in say for Visayas and Mindanao regions. If there are some companies or some dealers or distributors who would like to partner with us, so that you can also be a accredited sub-dealer of Cummins Philippines, please do reach out to us. You can find us, of course, at Laguna International Industrial Park in Binyan, Laguna. Now, moving forward to our topic, we have three major points to share with you. The first one is it covers Cummins power system products. The second is the manufacturing plants overview, and the highlight of our presentation, the differentiations versus the GOEM generator sets. So on to our power systems products overview. So Cummins International, Cummins Incorporated, has a very broad engine portfolio. You will find in our portfolio 23 high-speed, high-horsepower engines, plus, of course, their variants, ranging we design, manufacture, we sell, we support diesel and natural gas high horsepower engines of up to 5,500 bhp for a wide variety of equipment. So that range is those engines are used anywhere between mining. You will see in the list mining. You will see rail or for trains, especially in other countries, for defense. For oil and gas, we have engines for used for that. Of course, commercial marine applications, and of course the generator set industry. So across these markets we have major customers across the globe. We have customers in North America, Europe, Middle East, Africa, China, Korea, Japan, Latin America, India, Southeast Asia, South Pacific, and Mexico. So we have a very global footprint when it comes to our to marketing and selling and supporting our engines. But of course, as electrical engineers, as electrical practitioners, our focus is the power generation. So in our power generation portfolio, we design, we manufacture, we sell and support backup and prime power generators ranging from 2 kilowatts to 3.5 megawatts. Of course, kasama na din po diyan yung sa ibang industries natin. We also support, of course, base load and the recently emerging data center industry in the Philippines. We fully support that, as well as yung controls, yung paralleling systems, and transfer switches for applications of our customers, for commercial, industrial, again, data centers, healthcare, telecommunications, and wastewater treatment plants. We also provide turnkey solutions po for your distributed generation and energy management applications using natural gas or biogas as a fuel. We serve global rental accounts as well for diesel and gas generator sets. We design, manufacture, sell, and support AC generator and alternative products for internal consumption and, of course, for external genset assemblers po. Our products are sold under the AVK brand for specialized applications of alternators, and they range from 3 kVA up to 12,000 kVA. It is our pleasure po to inform for those who may not know na ang Stamford brand po na alternator is owned, it's fully owned by Cummins. So when you see the Stamford brand, that is our marketing brand, of course. Internally, we know Stamford as Cummins Generator Technologies. So when you see generator sets po that have the Cummins brand or the Stamford brand, of course, if those are genuine, you know that they were manufactured, they were designed, they were sold, or hopefully sold by accredited sub-dealers, but they were by Cummins Incorporated. And you can be assured po of the quality of those equipment. On my next slide, we also provide po full solutions for your facility na nagiging prevalent na po in our market that we have the gensets are tied closely with the switchgear, with the transfer switch, and then we also have the digital solutions. Digital solutions meaning ito po nagiging uso na sa panahon natin ngayon with all the digitalization, the technological advancement. So with certain upgrades, you can monitor now yung status po ng generator sets ninyo online. You can look at that on your cell phone, on your computer, and in certain cases even po yung master controller, even yung switchgear, the status of those things you can also get. So Cummins also has solutions for that. Meron po we also market transfer switches, switchgear, digital master controllers for control of your electrical facility. So we also have that available po in our portfolio. So now moving forward to our manufacturing plants overview. So of course, there are several factories po, a lot of genset factories actually in our industry. There are, Cummins has highlighted in this presentation po, we highlight four manufacturing plants that Cummins Philippines typically gets their gensets from. So kapag po mayroon kaming order to our factories, it will be from either of these four factories, depende po sa rating, depende sa size ng generator set, sometimes also depending on the quantity. Kung medyo madami po ang order, so possible po na sa iba i-order rin so that maybe they have a better time frame for your gensets or something like that. So first off po, we are pleased to share to you that we have CPG India manufacturing plant. It was inaugurated in May 2013. It is located in Faltan, India, and it has about 335 employees, and annual capacity po is more than 15,000 units. So you will notice that the product range is from 17 kVA up to 330 kVA because this manufacturing plant in India, a wholly owned Cummins manufacturing plant. So this is owned by Cummins International. It manufactures mostly for the smaller gensets. That is why it can produce more than 15,000 units rather, in its facility annually. Because they're small units, of course, they are easier to build, faster to build. Cummins established CPG India so that it can support the growing market po in the Middle East and Asia Pacific. Our footprint in India, it's not just the manufacturing plant. We have an office campus. We have the Faltan HHP plant. We have CPS SEZ plant, which caters to export markets. We have the Chennai plant. We have Pirangut plant, Kothurud engine plant, and of course the India office campus. But Faltan po is, the Faltan plant is our focus when it comes to our generator sets that we order po from them. Our next plant po is the CPG UK. It is located in Daventry in the United Kingdom, inaugurated in 1972. 927 plant employees and has produced more than 1,000 generator sets in 2021. So this manufacturing plant po will cater to the bigger range of generator sets namin from 600 kilowatts to 2250 kilowatts. So this one in Daventry po is where we order the bigger gensets usually, if not from the USA. The next is, of course, our CPG USA manufacturing plant. In 1969, it was inaugurated and located in Fridley, USA. The product range is from 10 kilowatts to 3,550 kilowatts or 3.55 megawatts of power ng isang single generator set. Ang CPG USA po, again, is of course same with India and same with the Daventry plant. It is fully owned by Cummins Incorporated. This last one po is we are particular with this one because we have experienced po in our market that there are some consulting engineers that are avoiding China-made generator sets. Inaintindihan po namin, we understand why that could be something of an issue for some consulting engineers or maybe some of our customers. But we are here, Cummins Incorporated, so Cummins Philippines is here to and we are glad to inform you po that we also have a manufacturing plant in China. We have CPG China manufacturing plant inaugurated in 2009. Once again, it is fully owned by Cummins Incorporated. It is located in Wuhan, but do not fret po, it is a safe facility kahit po siya ay nasa Wuhan. It has at least 130 plant employees and has an annual capacity of 4,000 units. Ang product range po niya ranges from our 55 kVA up to the 550 kVA. However, when it comes to the international market, only 275 kVA up to 550 kVA are international spec. So what we would like to highlight po when it comes to our CPG China is the fact na ito po ay wholly owned by Cummins Incorporated. And the generator sets that we order from China, if it is a 60 Hertz requirement, we will order that po as a 60 Hertz machine. Hindi po siya yung kukuha ng 50 Hertz na model and then lalagyan ng gearbox or i-increase yung speed up to 1800 RPM to get the 60 Hertz. No. What Cummins does po is it designs the engine itself and the alternator itself to operate at 60 Hertz. It is designed for 60 Hertz, not 450. So that when it comes out of our factories, it is tested at 60 Hertz. It is for a 60 Hertz application and it bears the same quality as the UK, India, and USA sourced generator sets. So our reassurance to you po is even if our generator set were to come from China, at least for that 275 kVA to 550 kVA, be assured po that it is a genuine Cummins product. It is not a product na inassemble lang po sa China. So it is manufactured, assembled, tested, and quality tested po to be at the same standards, if not better than the generator sets coming from the other factories of Cummins. Cummins po has other factories in the world, but Cummins Philippines po, we source our generator sets from these four different factories. Depende po sa size, again, of course, na ating requirement. Okay? So moving on to the highlight of this presentation, the differentiations versus the GOEM gensets. We created this informative presentation for our customers so that you are better informed po of what you are purchasing. We are well aware po that the generator set is a big investment in your building. Much like the presentation shared earlier the PV system, this is also an important and very expensive part of your facility. Whether it is a commercial facility, a residential facility, an industrial facility, the generator set is critical, especially for those places where yung utility natin is not as stable. Here in Metro Manila, the electricity is much more stable, but still, in those times that there are power outages, we want to be able to rely on our generator sets to deliver for us. We do not want po na pag nawata ang utility mo, wala ka ring backup power. So we are here to clarify some misconceptions when it comes to the Cummins brand, because we know po that Cummins is a well-recognized brand in our industry, in the genset industry and in the power industry. Cummins is a familiar name, but we want to be able to differentiate what really is from Cummins, from us, from Cummins Philippines, and what is those that have a Cummins brand pero hindi po talaga siya fully Cummins built product. So our differentiation po on Cummins gensets, sometimes there are some dealers out in our market that market po yung kanilang generator set as a Cummins genset. But what really is a Cummins genset? When you say it is a Cummins generator set, a true, genuine genset is the Cummins power generation product built for international market. So kami po, we call our generator sets a CPG product. So Cummins power generation. Yun po yung sourced from us mismo sa Cummins Philippines or through our accredited sub-dealers. There are other Cummins powered GOEM gensets, that's what we call them. They are low-cost products but with Cummins engines. Kaya po nasabi namin na very familiar ang Cummins name because it is not just our products that Cummins that bears the Cummins name and logo. Nakikita nyo po minsan yung aming engine sa ibang generator sets. You will see our alternator, the Stamford brand, in some other generator sets. And also you will see the Cummins brand used in non-generator set applications such as engines. Makakita po kayo minsan ng engine ng mga malalaking vehicles, mga tow truck siguro, or mga siguro parang similar sa ELF that use the Cummins brand. So we have partners po in the industry that they use the Cummins engines for their vehicles. But of course, our focus is on the generator set. Again, the true genuine genset is the Cummins power generation or CPG built for international markets. So what are these GOEMs? So we call GOEMs po what we consider GOMs or OEMs, original equipment, generator original equipment manufacturer, meaning po ng GOEM. So or OEM if you would like to use a shorter term. So yung mga Chinese-built OEM gensets po na yan are, to be more accurate, Cummins powered. They are Cummins powered because they are equipped with a Cummins engine. So here in the photo, you will see that this indeed has the familiar Cummins green color. So that is a Cummins engine. However, you will find that the brand po is different. It's a PowerLink, I think. PowerLink or PowerBink. So you will see that the entire generator set is not a Cummins product. It is only the engine and maybe the alternator. But there are other components that are not Cummins. Or this, more accurately speaking, this generator set in the photo is assembled by OEMs in China and then it is exported for sale. So it is not a Cummins branded genset in the sense na hindi po kasi siya genset na binuo ng Cummins. The Cummins is just a part. The Cummins engine is just a part of the whole. Similar to a car na maaari po may car na merong kunyari mayroong kang belt na gawa, fan belt na gawa ng Mitsubishi, merong kang alternator na gawa ng ganito, meron kang ilaw na gawa ng ganiyang manufacturer. But when you put them together into a car, the car is a Toyota or a Honda or whatever car. So this is the similar case po with these generator sets. They are only Cummins powered. So it is not a Cummins branded generator set. It's only the engine. So we are not liable for, Cummins is not liable for the performance of such gensets. And it covers the international warranty for the engine only. Pero syempre po, since that is a package in itself, kapag ipinawarranty yan ng aming customers, dapat po kung sino yung nagbenta sa kanila, they will carry the warranty. But in certain cases, of course, if it is really a problem with the engine, Cummins can, if covered by the warranty, Cummins will support that sub-dealer, of course. Similarly, there are none, of course, yung una po is made from China because there are a lot of generator sets that are now made in China. Even us, we do have, again, as I mentioned earlier, we do have a facility in China, a fully owned Cummins facility in China. But the difference is that the other ones are made in an assembly plant that is not China, that is not Cummins owned. We do not know who is the owner, but they assemble generator sets there. So ito pong next is Cummins powered GOEM genset. So these are similarly, they are gensets manufactured or rather assembled po in other countries, other places that have a Cummins G drive. When we say G drive, it is the engine specifically made engine and radiator package specifically for the genset market. And then it will have various non-Cummins components like the radiator, like its controller, or maybe the alternator. And then they will package that together similar with China-sourced GOEM products. And then they will sell that as a different, under a different brand name. So the genset, that manufacturer will get their G drive or their engine plus radiator possible from Cummins. And then they will couple that to an alternator, a controller from a different supplier. Same with what other Chinese GOEMs do. And then they manufacture it in a factory not owned by Cummins. So it is again only the G drive coming from us. Possible pa din po, of course, it is not impossible for it to happen na ang assembler is bumili sila ng engine and radiator package, ng G drive package from Cummins. And then they bought also a Stamford alternator, which is a Cummins brand. And then yun po yung pagsasamahin, and then they will put on a different genset controller and then market it as their own. So we also have actually controls, genset controls, but yung genset controls po ng Cummins, the Power Command brand, is used only on CPG products, on Cummins power generation products. We do not sell the Power Command controller po as a separate item and then para gamitin ng ibang manufacturers on their generator sets. It is solely for Cummins power generation products. So why are we saying all of these things? Why is Cummins Philippines sharing this with you? What we would like to emphasize here po is because there are certain critical differences. On the outside, they may look the same na, generator set, that is a generator set. Cummins is selling also a generator set, so that must be the same. Unfortunately po, it is not the same. Of course, a Cummins branded generator set package has a lot of advantages po that are unique to us and our competitors, especially these assemblers. Simply they cannot replicate what we are offering. The first of those being that the Cummins advantage is having uniquely integrated products. We call it the power of one. So the power of one translates directly to the Cummins gensets. So what we do is we perform po the necessary design, our factory team, our engineers do all of the engineering. We include, of course, the manufacturing experience and expertise across all of the critical elements of the generator set. Cummins Incorporated po, the Cummins company, has been in the market and in business for more than 100 years. So you know po that all of the experience of those 100 years and beyond are integrated into our generator sets. Cummins Philippines po has been in the Philippine market for more than 20 years. So we also understand the market. We also understand the needs of the customers. But also we have to incorporate what we know and what we believe is very beneficial and they should be a requirement by our customers. And one of those, of course, is that you have an integrated product that meets your requirements and that is backed by the experience of a company that is more than 100 years old. So, of course, part of our advantage is the integration of controls, alternators, and engine technology into unparalleled power generation products. One of our unique advantages is since we have our own controller, the controller is tailor-fit to the engine. The controller is also which is also tailor-fit for the alternator. So when we design the generator set, kasama po yung controls doon. Of course, kasama yung sensors and everything, all of that, it's a complete package that we offer to you, including the technical expertise to recommend the right solution for specific applications. There are some po kasi that will say, hey, it's just a generator set, parehas lang yan. Potato lang yan. No, what we have the expertise that we can share, we can offer to you, that we can offer to you solutions po that will be exact to your needs. Kasi baka po may times na ang kailangan nyo pala is prime, but you are offered a standby, sabihin. Kasi ganito lang yan, ganito lang. Or maybe you need data center continuous, pero ang i-offer sa inyo is a standby lang, and then they give you a promise that it will run for so and so period. So we have the technical expertise to recommend the right solution for specific applications. And of course, the quality aftermarket service that is provided by our worldwide distribution network and our trained technicians. These are selling points po that cannot be replicated by other GOEMs, because what they will do is get the engine, get the alternator, as long as the rating is similar, may match mo yung flange to flange, sige, and then pagka nakuha mo yung communication between ECM and the controller, that's it. But our advantage is we do, of course, all of the integration work. Kaya po paglabas ng factory namin, alam mo na the controller is fit talaga for the engine and for the alternator and for the genset itself. The next, of course, of our differentiation is in brand and color. You know po that color is a very a highlight, even if I could say that, of any product, because it reminds you kung pag nakita ninyo kulay green, ay Cummins yan. Ay pag nakita ninyo na ganito yung kulay, ay ganitong brand yan. Diba? So, ang aming pong products, the Cummins Power Generation brand, it is always the Cummins green color, as you can see in the photo. Ganitong kulay ay Cummins green, but only the genuine Cummins gensets have the logo of Cummins Power Generation, as you will see. I have not seen, so far, I have not seen in the wild po a non-Cummins product bearing this, because we are the only authorized, CPG products are the only authorized products to use this logo, the Cummins Power Generation. In the photo po, in the genset itself, you will see it is in all white, of course. So Cummins Power GOEMs, they are not authorized to use the Cummins Power Generation logo. So if you are in doubt po as to the genuineness ng inyong product, you can you can talk to us. Please reach out to us if medyo nagdududa na kayo na baka kinaya lang yung sticker ng Cummins Power Generation and nilagay so that it can look like a genuine Cummins product. Please do reach out to us. We will help to identify kung ang inyong product ay genuine na Cummins CPG product. Another one po of our differentiations, of course, is the alternator. The alternator is a Stamford alternator. By default po, our generator sets that we offer in the 1800 RPM range are Stamford brand, which is a Cummins brand. So it is a genuine Cummins brand. It comes po with a certificate of conformity. It has a hologram anti-counterfeit label. Di ba? Makita na rin natin yan kahit sa cellphones. Merong mga ganyan na ngayon para malaman natin kung genuine or not. Meron siyang 7-digit anti-counterfeit code. It has a uniquely synchronized serial number on the alternator body, nameplate, certificate, and label. So of course also has Stanford brand na naka-engrave po dun sa body niya. So kapag po GOEM generator sets, it is not necessarily kasi na it is not necessarily using a Stanford alternator. There are several brands po. I believe you also know this, that yung mga gensets nila is Cummins engine and then they will partner with Leroy Somer, or they will partner with McAl or Marathon or some other brand. So kami po, Cummins will only use Stanford, the Stanford alternator. You will always see that kapag po mag-ask kayo ng specs sa amin, it is always the Cummins engine and Stanford alternator. They are both owned by Cummins Incorporated, and if there are counterfeit products, may mga similar appearance pero hindi po nila kayang gayahin ang aming yung power output. Nasabi ko po yan because I have had an experience where someone reached out to me and then they sent me the photo. Sabi niya sa akin, pre, paki-check mo nga itong alternator ko. Pinadala po niya sa akin yung nameplate, yung photo ng nameplate. And then nakita ko, it looks a lot like our Stanford alternator. So I pulled up the datasheet ng alternator namin, even down to the model name, very similar. So hinanap ko po, I look for a matching alternator that is a genuine Stanford brand versus yung binigay po sa akin na picture. Nakita ko talagang ginaya, pati yung logo, ginaya yung kung ano po itsura ng pagkakalagay sa table, voltage, ampere, ang power nakalagay, ang kVA, power factor, all of that, ginaya po. But one thing that I noticed na hindi nila nagaya, nakuha nila ang voltage pero hindi po nila nakuha ang power. Yung power output po nung counterfeit product na yon that very much looks like a Stanford alternator, hindi po niya na-reach. Kahit sabihin mong 5 or 10%, sa ating industry po malaki na yon. Malaki ng difference yon. It is lower yung counterfeit product. Really, they cannot fully replicate the Stanford product. Similar ang appearance, but when it comes to performance, of course, we rely on the original only. Another one po that we have differentiation for is our power command. Ito po yung sinasabi ko earlier. Our Cummins gensets 100 kVA and up are equipped with Cummins proprietary power command genset controller. So we allow for a total package integration. Ito pong controller na to, as I mentioned earlier, we use that exclusively for CPG products. So for this more modern power command, the latest iteration po is power command 3.3. Yun po is, it has the AVR built-in. Integrated na po yung voltage regulation dun sa controls na yon. Kasama na siya kaagad. So kasama po dun, of course, kaya alam nyo na tailor fit yung steady state stability niya, yung steady state controls, voltage controls, transient capability, monitoring, protection, all of those are tested and tailor fit between the alternator and the power command controller. So we have an integration po of the total package. We have stringent analysis and test. We do short circuit, thermal, structural, torsional, acoustic, fluid dynamics. Of course, some of those are done within the within the Stanford manufacturing facility, and then tests for the engine are done on the engine facility, and then pagsasamahin na sila sa engine manufacturing area, alternator, and then pagsasamahin sila. And then itetest po as a whole using our power command controller. So very very robust po itong power command controller. Actually, the base model of our power command can do power transfer controls or similar po sa controls, actually ATS controls kaya po niya if talagang kakailanganin. So ang kailangan mo na lang i-partner with the genset is an electrically operated circuit breaker. It can control that and then do the transferring, time delays, kasama na po doon, transferring delays, auto mains failure, integrated na po into these controls. And that's just the basic. You can expand if you want to order the power command with masterless load demand, if you have 2 or more generator sets and you order the power command with masterless load demand, wala na pong kailangan master controller. If you need simple synchronization, kahit sabihin natin 4, 5, hanggang 8 gensets, I think up to 16 if I'm not mistaken. If it is just a basic synchronization of 16 generator sets, kunyari po, and then they will supply power to a very large facility like a commercial facility, they will synchronize among themselves. You do not need a separate cubicle for the master controller. They will synchronize and they will load share among themselves. So very convenient, space saving. Of course, yung switch gear nyo po is one switch gear na lang and then the gensets can control that. If you need more information, please do reach out to me. I will post my my contact details on the chat box later so that if you have some questions po about our power command and how we can help you design your facility when it comes to emergency power supply, please do reach out to us. We would appreciate po na makuha ang inyong makashare sa inyo ng ng technical expertise and knowledge. Next po na differentiation namin is the factory tests. All Cummins gensets are load tested up to 100%. If for prime, 110% siya to ensure compliance to performance. And then we issue the certificate that it is tested to do under what conditions, ano po yung naging line-to-line voltage measured, ano yung full load output niya, all of those things, the important electrical information will be provided together po with our generator sets. Ang maganda po doon is that what happens with when Cummins designs a generator set is it undergoes prototype testing. So ngayon po, of course, the ones in our product line, they do not undergo prototype testing anymore. Because in the past, ginawan po muna ng prototype tests. So they built a prototype, they tested it to different standards, they tested it to check its robustness, sometimes even for seismic applications, tinetest din po yan. And then you will find, kapag kami kailangan baguhin, aayusin ng factory team until we come up with a robust product that is compliant to international standards, to ISO 8528 and other standards that are applicable for generator sets. Yung iba po kasi ang gagawin, bibili engine, alternator, controller, radiator, skid base, pack, benta na sa customer. No testing done. O kaya po paaandarin lang to check na aandar, okay, nag-start ang generator set, nag-rated power, nag-rated voltage, nag-rated speed, sige mag-supply. Pag nag-supply siya, okay na yon. Labas na ng factory. No. What Cummins does po is before we market a certain generator set, it undergoes prototype testing until maging satisfactory po yung kanyang performance. That is the time when we would only do marketing for that. So all of the Cummins power generation products po in our portfolio that Cummins Philippines markets are tested in our facilities. Yung which some Chinese OEMs or other GOEMs cannot replicate that. The level po of accuracy or talagang of attention to detail na ginagawa ng Cummins International when it comes to our products. Again, we also have the environmental friendly differentiation. Cummins cares for very much cares for the environment. In fact, hindi lang po tungkol sa brands namin, sa products namin actually ito eh. Kami po as employees, we are actually required po to participate in social in environmental friendly activities para po kami din mismo ma-inculcate sa amin na that Cummins is not just manufacturing for the sake of money. We are also helping the environment. And recently po ni-launch ng Cummins International yung aming yung Destination Zero na goal. The Cummins leadership made public that we have this Destination Zero, meaning that we aim at a certain year to really help the environment heal para po bumaba yung carbon emissions, maging mas efficient yung mga gensets natin such that yung emissions niya are very minimal and kayang kumbaga hindi nasasabayan ba ng environment natin na mag-clean yung air natin. Kaya po it is a very close to the heart of Cummins leadership. So all gensets that CPG gensets are designed with a robust frame, 100% fluid retention capability to protect the environment. Ayaw po ng Cummins na pag nag-leak ang oil, nag-leak ang fuel, pupunta sa lupa, pupunta sa concrete, i-absorb na lang ng surrounding environment. It does have those fluid retention channels po. Here you will see in the photo, dito sa kabila hindi masyado. But those are fluid retention channels na if magkaroon po ng leak sa genset, pupunta yun dyan. Some other brands or GOEMs do not have that. Or meron po silang ganyan but as an option. Ito pong sa amin, especially itong mga naka-enclosure, merong ganyan, may fluid retention capability. Because again, Cummins really does care for the environment. Hindi lang po makabenta lang ng generator sets. Next po is of course our CE compliance. So ito po hindi masyadong applicable sa Philippines but for regions or countries na applicable ito, merong CE regulation. So it protects the health and safety of the operators. This is mostly po alam ko sa Americas and sa Europe. So para po makakuha ng CE certification, kailangan makakuha siya ng directives na machinery, low voltage, EMC, noise, and ROHS. So you know that pagka may CE mark, ano po yan? Definitely that is a Cummins product, that is a Cummins genuine product. We do not see that as much here in the Philippines, but if you do want a CE compliant product, I believe that is an option in our with our sales. You can talk to our sales and ask about CE compliance. Next po namin of course is the warranty and aftermarket support. We have a one-stop shop for aftermarket service by an authorized distributor or service provider. Dito po sa Manila of course is we have our team here in Manila in Laguna, that is our team of trained service technicians that do aftermarket support. We have a separate team for aftermarket, separate team for service. Sila po ang katunggali po namin when it comes to katuwang namin rather when it comes to supporting our customers. So there are also 600 company-owned and independent distributor locations and 7,200 dealer locations worldwide. In the nation po, we also have partners here in Visayas. We have partners that do the aftermarket support. They partner with us directly. And of course, they are trained to maintain and service our CPG genset. So may ibang difference po kasi dun sa ibang GOEMs is that they do sell the genset, but when it comes to servicing, they have a different entity working for them. Ito pong sa amin, we have our own service technicians. They are Cummins employees. They are trained by Cummins in our training facilities, and they have the necessary tools to work on the generator set. So halimbawa po pagka sa GOEM or sa OEM manufacturer, sa mga assemblers lang, packagers lang sila, Cummins brand lang ang engine but the rest we do not know. So kapag ka po lumampas na yung warranty, kunyari sa akin, ako yung nagbenta, ibinenta ko sa inyo, after 2 years, you're on your own. Hahanap na lang kayo ng sino kaya ang pwede sige, let's go to Cummins to service the engine. Let's go to some other servicing agent para sa alternator. Pag nagloko ang controller, sige, papalitan na lang natin. Another person na naman, another agent na naman, another entity na naman. You're talking to so many people. But when it comes to CPG, you only talk to one. You only talk to Cummins. Kami po, the whole package, we will service, we will diagnose, we will check, we will support you. Kaya po, talagang kapag nagkaroon ng fault yan, alam namin. Kasi pupunta ka sa controller, pag chinek doon, okay, may engine fault, or may problema sa alternator, or mayroong ganito. So makukuha po ng power command. And then, the service technicians will know what to do. So that is a very big differentiation po that we believe is a driving force. We do understand po, of course, that all of these things, all of these items from our service and support, from our global service network, from the engine, alternator, controls, one-stop shop, warranty, all of these things. I would like to be honest with you. Of course, it comes with a price. Pero sa amin po, that the price of the higher price perhaps of our CPG gensets compared to a same rating na GOEM, opo, mas mahal yung sa amin in terms of pesos or in terms of dollars, but what you are also paying for is peace of mind. Because you know that the product that you bought, you know that the product that we sold to you is a genuine Cummins power generation product. It's a CPG product, tested, well tested in our factories. It was prototype tested. It is built using genuine Cummins components, including yung filters. Kasama na rin po yung mga fluids. What we use for our oils is Valvoline. It is, I believe, it's a Cummins brand as well, owned by Cummins. We use filters Fleet Guard. Fleet Guard po is also owned by Cummins. Yung Fleet Guard, alam ko ngayon, nag-rebrand sila into Atmos, but you still get the same quality that you get with Fleet Guard. All of those things po, Cummins branded, Cummins owned, pinagsama-sama yon to come up with and then tested, prototype tested in our facilities before we market that. So that when it comes out of our factories, you know that we stand behind our product 100%. So that is something that we offer to you that cannot be offered by a simple packager. The peace of mind that you know that the generator set sitting and on standby in your facility is a genuine Cummins power generator generator set, and we will support you. We will be behind you when it comes to that product. Kapag po nagka-problema, we will support, we will service through our global service network and through the capability of our certified service technicians. So we hope po that through this presentation, karoon po ng differentiation between our product, the CPG product, and GOEMs, the product offered by our competitors, the assemblers. Yes, they may have the same kilowatt rating or kVA rating. Maaari pong Cummins engine din yung ginagamit nila. But at the end of the day, a CPG product will outperform something that is just a GOEM, because you have the more than 100 years of experience poured into that product, the CPG product. And we hope that through this presentation, we were able to share to you and give you peace of mind that if you do already have the Cummins CPG product in your possession or in your ownership, in your company's ownership, we hope na nakapagbigay po kami sa inyo ng peace of mind that you know that your product is a genuine product. And if in the future po there are our partners, our co-electrical practitioners out there, our consultants, customers that would be purchasing gensets in the future, please know po that when you are buying from Cummins Philippines or through our sub-dealers, if they are in your area, we are marketing to you, we are selling to you a genuine product that will meet your expectations. Thank you very much, everyone, for listening. We appreciate for your time. Thank you once again for IIEE and for the people who arranged this presentation. Thank you very much for the opportunity. We are truly grateful. That is the end of my presentation. And I hope that this has been very informative to you.
Thank you so much, Engineer Joshua Valle from Cummins Sales and Service Philippines Incorporated. Ayan, ang daming nagpapalakpakan ngayon, Engineer Joshua. I would just like to read some of the chat. Meron kasi dito nagsabi that from Engineer Benji Semini, sabi niya, I can vouch Cummins product. Most of my projects in Saudi Arabia, I recommended Cummins genset.
Thank you, Engineer Benji.
Maraming salamat. And Engineer Joshua, we also have someone here from our participants were asking for your contact number. So since you're actually a panelist naman po dito sa ating I think you can actually reply them with your contact number. In behalf din po in behalf of the Institute of Integrated Electrical Engineering of the Philippines, Eastern and Central Visayas Region latest summer chapter, pinasasalamatan din po namin ang Commons Philippines for your partnership and sponsorship dito po sa ating programa, dito sa ating technical session for today. Thank you so much, Engineer Joshua, at ipaabot niyo po ang aming pasasalamat din po sa inyong napakabuti at napaka-genuine. Parang that is actually the word of the day, genuine na company, Commons Philippines. Thank you so much po.
Thank you po. I just sent my my contact details sa chat. I hope nakuha na ng mga participants and attendees natin.
Alright, sige po. We will see to it din po, Engineer Joshua, that the moderators po and the technical team will be sending also your contact numbers to all of our participants. Maraming salamat po for your presentation. Okay, so moving forward, tapos na po tayo sa isang sponsored technical presentation. We now proceed to another topic. Opo. Since this is a virtual, I believe that everyone is working lunch. Working lunch po tayo on the side because we have so many lineup po. Ang dami pong lineup ng ating mga topics for today. Kung kaya we will have to proceed with our next speaker. So our second topic for today is entitled Emerging Solar PV System Storage for Residential Energy Solutions and CIE Energy Solutions. So of course, due to the climate change becoming more severe, major weather events will worsen, causing more power outages for longer duration. In fact, the coronavirus has also emphasized importance of sheltering at home. Battery backup, of course, with solar is the most effective way to ensure that the light can stay on in an outage. Solar installations has grown quickly over the past months here in the Philippines, but ultimately, to tap into the full value of solar energy, we need a way to control the timing of that energy use. And the best way to do that is with battery energy storage. As the demand for energy efficiency and conservation grows and playing an increasingly important role in the transition to a world powered by renewable energy, solar plus battery energy storage boost electrical systems resilience and aid in grid flexibility and mitigating peak demand. Ladies and gentlemen, our resource person for this topic is all the way from Quezon City. Ayan, his specializations po are on power substation engineering and design, solar PV energy system for residential C&I and utility scale platforms, and subspecialization po on instrumentation and controls and energy efficiency and conservation. He is the CEO of Losares Solar Power Engineering Services, that is from June 24, 2021 up to present, and the National Treasurer of the Institute of Integrated Electrical Engineers of the Philippines Incorporated. Ladies and gentlemen, a round of applause to Engineer Virgilio Sanchez Lozares. Hello, Engineer.
Yeah.
Good morning po, sir.
Yeah, good morning. Thank you very much. So, na-late ng konti, no?
Opo, medyo na-late po tayo ng konti.
Yeah.
Sige po.
Anyhow, thank you very much for this opportunity. In fact, I'm nag-ano ako sa for the invitation here. Hindi ako nakapag face-to-face ngayon because of hindi ako nakakasama ngayon sa board. So I will be doing this face-to-face. Okay? So without much further kasi yung oras natin, I want to share now. Okay? Okay na to? Yeah?
Ayan, nakikita na po, sir.
Nakikita? Okay. So my topic for to share to you is about the emerging solar photovoltaic system storage for residential and commercial industrial energy solution. So as have been mentioned no kanina in the introduction, a solar power energy system can be used by anyone to supply all their electrical needs, provide backup power, or even just as a supplement to the normal electrical grid connection to a utility company. It is ideal, no, kapag lalo na kapag mga remote location, we need no this hookup about what we call the battery energy storage system. No? Ito na ngayon ang trending ngayon. No? In fact, we are looking forward na sabi nga nila, solar power transforming no, the energy future. So ngayon, with this solar power, which is the main no, character now, no, the main thing, daw kailangan niya ngayon ng kapares. No? So para bang what I can say, with the sustaining no power now no from the sun, okay, kailangan niya rin ng ano kasi it is a variable renewable energy sources. So kapag meron ng intensity of light, that is photons coming from the sun, yun lang ang meron ng harvest. Kaya pagdating ng gabi, wala na ng intensity of light, okay, wala nang harvest, so wala tayong, there will be a power outage. So what we need now, in order to sustain that, is a counterpart, and that is the battery energy storage system. Okay. Okay. So I start with this. No, these are the challenges of the future power grid. No? Long-term drivers for energy storage. That is the electricity consumption on the rise. Electrification of everything moving towards electricity as the primary source of power. Then we have to retire no? The coal plant, no? Reducing baseload power capacity. Kasi alam natin itong coal is not a renewable energy, no? Una-una, yung nagmamahal ngayon, ba? The same as some other fuels. Then we have the growth in renewables, and this is the main thing now. Government and industry moving towards solar and wind. Ang kailangan lang natin, kagaya sa ibang bansa, especially in America, no, is the incentives, no, coming from the government. Doon meron silang tinatawag na ICT, no, or the ITC, the investment tax credit. So on that, we are looking forward that our government, that the Philippines, will have what we call tax and regulatory incentives regarding that matter. No? So because of this growth in renewables. Then we have the electrification of transportation. So you have now the electric vehicle, di ba? So based on that, ano natin, no, RA 11697, so more users of electric vehicles can increase peak loads, placing more strain on the electrical grid. Increase in high-speed rail. So what will happen? Because of these challenges, no, kapag dumating na rito, no, kaya hindi pa masyadong ano rito ang electric vehicle because of our charging infrastructure. Kaya lang pag nagdatingan na yan, that charging infrastructure needs no power, no, needs that from the grid. So what will happen? May strain ng grid. So pag na-strain ng grid, then we have not much enough power plant to do that, then that will be a problem. Kaya we need now this what we call now the battery energy storage system, the best. No? Ito ngayon, may mga smart grid na nangyayari all over the Philippines. Meron na tayo mga in fact 30 plus more no of battery energy storage system no in the long scale, no, yung mga 20 megawatts, 60 megawatts, 100 megawatts to support no the smart grid. No? Then we have the proliferation of this, no, that what I have mentioned, no? The smart grid technology. Bidirectional flow of power requires additional coordination between power supply and demand. And in terms of application, we have these three main things. No? That is the unprecedented records for the economics of solar price storage, demonstrating a variety of value streams and creating an even more supercharged appetite for this fast emerging generation source. So the combination of plummeting solar and batteries of cost deem the future of traditional generation. So you see, on this application, we have microgrid management, no? So self-sustaining na. Then we have the best grid services and the renewables integration. So right now, in terms of the renewable, ang pinakapaano talaga natin, when we apply it to residential, commercial, pati utility scale, is solar power plant. Okay? So these are the applications that we will be doing. So what I will share to you now is what will be this emerging technology on storage just for residential and commercial and industrial. So we are looking for a rooftop, no? Solar power plant integration into a battery energy storage system. Okay, and this is the grid connected, no? Energy storage system application. So you can see all over there we have the sorry. I want to have the poll. Okay, so we have here the power plant, no, for the load leveling. Then our purpose now for this discussion is on the residential, okay, for the ESS. So we now have the solar plus storage. Then we have the commercial and industrial. So with respect to that, we speak about peak shaving, no? Because of the industry, because of the commercial use, no, malalaking loads sila. And for that, that will also be on the residential. We have what we call the solar PV time shift. Yun yung tinatawag natin time of use. Because ngayon, because of the battery system technology, no? Ano na ngayon, ang battery is not just during brownout or power outage. We can use it now to support, no, the solar PV for your load, no, yung hina-harvest niya, support also because of the AC DC coupled technology. So the battery now can support the load at the same time with the solar harvest. Okay, so how does a solar system work? No, simply to say, we have the solar panel, diba? Or we call it the solar modules. And that is DC, no? That is photovoltaic, which means to say photons, no? Photo is photons, no? So that is the intensity of light coming from the sun. Then we have volts, no? Voltaic, that will be the voltage, so that will be our power. So the DC will be converted to AC because ang load natin sa bahay or our home appliances are AC power. So we need for that what we call an inverter. Okay, so the inverter, whether it is a centralized or string inverter, then now meron tayong microinverter. Okay, which I will share to you later. No, what's the difference between those two types? No, so converting it to DC to AC. Okay, then we have the electrical panel for that going to our main power. Okay. Now, what will happen if the grid fails or since this is DC, okay, pag may weather tayo, di ba, bumababa yung harvest, no? Kasi we are on the standard, let us say, on the irradiance, no? That is the intensity of light irradiance is at 1 kilowatt per square meter and at standard condition of 25 degrees centigrade. So what does it mean? Kapag ang irradiance mo is bumaba doon sa 1,000 o tumaas, bumaba doon sa 1,000 kilowatt per square meter, so bababa ang harvest. Okay? So let us say, yan yung pagdating ng hapon, bumababa na. Ang pinaka-peak natin during the, di ba? During the 12 noon, so we have that 9 to 3. Yung pinaka-ano natin ng peak sun hours, especially during noon time. But there are some areas na, kagaya sa Mindanao, there are some areas na sa 12 hindi kasi because of the shading effect. Kaya yung shading, saka yung pero tayong let us say, umuulan, so bumababa yung irradiance. Okay? And also, one effect of that is temperature. So pag masyado mataas ang temperature, So there is an effect, no? Kasi heat yun di ba? It is not the heat that we need from the sun, it is the intensity. Okay? So pag ma-heat, aano yung no? Mag-aano yung harvest. Also kapag pag naman malamig, that will be also affect, no? The performance or the solar irrigation. Kagaya ng mga design, no? Na let us say when you go to Tagagaraw, masyadong mainit, no? Visayas. Different yan pag mag-i-install ka sa Baguio or sa Tagaytay. Okay? For the temperature. So when there is, if the shine is shining, okay. But if there is this one, what happens during a power outage? So walang grid, o kaya umuulan, mababa ang ano nito, then merong clouds, di ba? So baba. Kaya in fact, di ba, kagaya nung kanina, with my experience on a solar power plant in Negros Island, that is in Manapla, we put up there a 48 megawatts, no? Solar power plant. Then marami na dun sa Negros Island, nandun yung pinakamalaking solar power plant natin sa Cadiz, yung 135 megawatt, no? In 138 kV line. Isa Manapla namin na 48 kV, it is 69 kV. Then nagsimula yun sa San Carlos, sa La Carlota, sa Bais. So marami na nandun. Kaya lang, kasi during pagdating ng clouds, bagsak ang planta. So kapag walang backup system, which is now the battery, walang mangyayari. So when a grid outage occurs, solar inverters must shut down. So ayan yung kanina na yung sinasabi ko na kapag nag-shutdown siya, dapat merong anti-islanding effect yung inverter. Which means to say, pag nag-power outage, di ba, papatayin ng AC, di ba? Patay ang AC, okay? Kaya lang, meron tayong DC. Di ba? Ngayon, kapag ganito, meron siyang voltahe doon, no? I will discuss it also later, no? Ang ano rito, dapat yung inverter natin kasi aayusin yung utility. Kasi merong problema sa outage, no? Nag-brownout, nag-power outage. Ani utility, dapat yung inverter mo magkakaroon ng anti-islanding. It means to say, hindi magba-backfeed yung kino-convert na DC to AC ng inverter mo. Okay? Okay, now with the emerging technology now, ito na ngayon ang battery energy storage system natin, no? So we have start ng Tesla Powerwall. Nakaano na yan, modular type na. Ito na ngayon yung battery na lithium iron phosphate, no? That is the LiFePO4. No? Then meron ding lithium, nickel, magnesium, cobalt. Kaya lang itong LiFePO4, yun ngayon ang system. So we have Tesla, we have here Huawei, no? Na from here, we have the battery management system. Then yung meron, naka-ano na siya, naka-modular. Parang per let us say, per battery system of 5 kilowatt-hour. Kagaya nito, tatlong battery module. So it is a 15 kilowatt-hour. 15 kilowatt-hour. So dalawa siya, means to say, in a particular inverter like this one, yung dalawa MPPT niya, kaya nakakabit yung dalawang battery. So one MPPT can handle, or one battery management system in one MPPT can handle 15, kaya total ito 30 kilowatt-hour. Yan na po ngayon yan. Kagaya rin dito sa Powerwall. Then this one, it is what we call a battery inverter battery system. Hybrid. So meron siyang battery inverter at the same time meron siyang, let us say this one is a 10 kilowatt, no? 10 kilowatt hour battery system. So nandun na yung battery inverter, kaya diretso na siya sa PV on this. Then at the same time merong battery. Yan ngayon po yung emerging technology. So before we discuss much about this, let us have first, no, some important definition of this battery, no? Different battery technologies. So ito yung mga residential storage stage, the charge and discharge, no? Yung tinatawag natin depth of discharge, di ba? Ano natin, di ba? Sa what you call that, sa cellphone natin, di ba? Sa smartphone natin. Nandun yung ano, di ba, na let us say, pagdating ng 20, kasi lithium yun, di ba, lithium ion, pagdating ng 20, dapat i-charge mo na. Then, dapat hindi mo siya i-overcharge. Kaya lang ngayon, yung mga bagong technology ngayon, may tinatawag sila na, kasi kalimitan, kaya nasisira yung battery, na overcharging, no? Kaya yung cycle niya. Okay? So there is that the discharge, no? The cycling, so the density, the cycle capacity, and cost. So ngayon, narito na tayo. Yung mga lead acid, matured na yan, pawala na yan, di ba? Yung mga liquid type. So pumupunta na tayo, pati ginagamit kay electric vehicle, nandito na tayo sa lithium iron. And particularly now, we have that lithium iron phosphate, na LiFePO4, no? Okay? So this is this one. Kita nyo rito yung characteristics, di ba? Ito yung matured technology na, yung mga liquid type, no? The BRLA batteries. Okay? Yung mga AGM, yung absorbed gas mat, no? Wala, paano na po yan? Nandito na rin po tayo ngayon, no? Sa lithium iron phosphate. Then, in the future, we have this increasing performance of some other battery technology. Okay? And that will be the energy application. When light capstone hits spins magnet, lights on stands on that. So let us have, when I say life cycle, it is the cycle of the battery in a single discharge or discharge. It refers to the number of times a battery can be charged and discharged before it needs to be replaced. Kaya pag hindi natin na manage yan, madaling masira ang battery. Okay? So although all batteries can be discharged to 100%, okay, many battery types should only be discharged to 70 to 90% of the total capacity. Kasi ang lifespan can either be measured in the number of years or the number of cycles. So ito yung yan. Kagaya ng lithium battery, as you know, for example, has an estimated lifespan of 13 to 18 years, or around, when you speak of cycles, that is 6,000 to 10,000 cycles. Okay? Now, what do you mean now by depth of discharge? How much it is charged before it's charged back again? So, eto ngayon, yung mga liquid type, ang battery depth of discharge niya is 50%. Okay, 50%. So, ibig sabihin, kapag sumobra ka doon sa 50%, madaling masira ang battery, saka yung cycle niya. Ngayon, ang mga lithium iron phosphate, no, the battery chemistry now, it is now 90 to 100% DOT. So particularly, may mga na 100% DOT. Let us say if I have a 5 kilowatt hour battery, it means to say that I can use that battery, in 1 hour, if I have 5,000 watts, no, 5 kilowatt. Now, if I just use that battery, for a half or 2,500 watts, then I can extend the battery life. So it will become now 2 hours. Okay? So 5,000 per hour, 2,005 for 2. That is 100% depth of discharge. Okay? Now, so the lifespan of the battery is how long the battery will last before it should be replaced. Yan yung cycle ng battery. Okay? You see here, discharging from 100%, okay, to 20%, then charging back again to 100%. Example, 80% means we can discharge up to 80% with the battery. Okay? Of battery capacity. So DOD available, 10, 20, 50, 80%, 90%, 100%. Okay? So on that. So yung sinabi ko kanina, yung depth of discharge pag liquid type is only 50%. So now we are now going to 90 to 100% DOD. And that is the number of times. So you see here, as DOD, the depth of discharge increases, battery life decreases. Diyan yung po yung nasisira. Buti, sabi ko nga sa iyo, kagaya sa cellphone, di ba, kalimitan, sinacharge natin sa gabi yan, nakakalimutan natin pagtulog. Okay? So yung mga, ngayon, yung mga technology, kita natin, madaling masira yung battery. Ngayon, buti ngayon, meron na tayo ngayong di ba, na yung mga smartphone na lumalabas ngayon with the modern technology, pagdating ng let us say if that is at 80%, iti-tickling charge na nila yun or 80 or 90%. So para hindi sirain yung battery. Okay? These are the types of solar batteries. No? Ito yung mga lead acid na ginagamit nung una. Then we have now, okay, the same as the battery used in our car. No? This is already technology already. Then we have the hybrid car technology. A car battery using case of cars using electric and mechanical motors. Ito yung nagsimula sa recreational vehicle, no? Sa mga golf cart. So we have that. And ngayon, ito yung this battery that we have, it is a lithium iron phosphate available na rin in the market, no? Na pang-replace, no, sa ano natin dito sa liquid type. Kaya lang ang diferensya niya mas mahal. Okay? So in internal combustion, yan, lithium iron phosphate na ginagamit ngayon. Tawag nila rito ready go, yung bateryang may utak, no? And you can analyze this, no, for that process. The reason why I show it, no, because of the lithium iron phosphate. Saka ano yung magaang lang yan. Okay? So these are the technology. No? Now, so these are the batteries, no, that I mentioned are the lithium iron batteries are the same type of batteries found in your cell phone, laptop, and other electronics nowadays. So a typical lithium iron battery will give around 6,000 to 10,000 cycles at 90% discharge. So they will have a lifespan of roughly 13 to 18 years. At kalimitan, no, with respect to this now, they are less prone to thermal runaway, also known as exploding. Yung mga unang labas, di ba? Nagkaroon tayo ng problema, di ba? Mayroong nasusunog agad, pumuputok na cellphone. Ngayon, na ano na yan for the thermal runaway. Nagkaroon kasi 3 years ago, no, sa America regarding that particular battery. So these are the two most common types, no? The lithium iron phosphate and the lithium nickel magnesium cobalt. Yan na rin ang ginagamit ngayon sa electric vehicle. So this is as I mentioned to you, the most commonly used battery type and prepared for the stability, durability, and performance. Yung nickel, magnesium, cobalt are the second most commonly used and are prepared for the high energy density, lower cost, and long cycle. Ito dati ginagamit ng Tesla noong una. Ngayon pumupunta na tayo rito. And there are two battery manufacturers in the world. Yung CATL saka BYD, no? Okay? BYD, those are the batteries now na ginagamit, no, in the industry. Okay? Now, going with this battery system, how does solar plus storage work? So that is, sabi nga, the Batman and Robin, no, of the industry. You have now solar as Batman, then the storage is Robin. So it works by adding a battery to their solar system installed on their home. And there are two primary reasons why one solar and storage. Well, una, diba, sabi natin, to have a backup power when the grid goes down. So para hindi na tayo mag-rely sa diesel genset kasi ang mahal ng fuel. Kaya lang, ngayon with the solar plus storage, as you know, as we go on, here in the Philippines, hindi pa rin maalis na naandun pirming kasama, talagang pang last resort, gagamitin natin diesel generator. Kasi yan ngayon nandun train na meron tayo, maraming sa bahay, meron yan, di ba? So solar energy produced during the day gets stored inside the battery for later use. Yan po yung di ba? Okay. Now, the second one is this, to take advantage of time of use rates to lower their electricity bill. Ito po sa Meralco, merong ganitong services. Not just from our regular. If you can apply for a time of use, what do I mean? Na pag meron ka solar plus storage, you charge the battery during the night. Kasi mas mura ang rate. Then you use that battery fully charged during the day for your load consumption. Doon mahal kasi ang rate. Eh pag ginamit mo yung battery mo, ano, di ba? Na mura na rate, din gagamitin mo sa during the day at mataas ang rate. So, doon pa lang savings ka na. Diba? Okay? So, that is charging or the solar energy produced during the day gets stored inside the battery for later use. So, sinacharge niya yung battery. Okay? So, when the solar production goes down in the late afternoon and time-based rate spike, energy can be drawn from the batteries rather than paying for expensive power from the grid. Lalo na ngayon, di ba? Napakamahal ng kuryente ngayon. Ba? Okay? So, you use power from the batteries with their energy demand is highest to lower their demand charges. Ito po yung ano, no? Yung tinatawag na time shift solar generation. 2 hours of peak demand with solar energy storage. Ito po yung PV generation natin. So, nagsimula sa umaga, wala pang madaling araw. So, 6 a.m., meron intensity of light. So, nagpipik yan, okay, up to 4 p.m. Okay? Ngayon, depende sa ano, sa intensity of light, kasi ngayon, because of the efficiency of the inverter and the solar panels or the solar modules, kahit na intensity coming from the moon, meron pa rin silang harvest. Okay? Then, you see here the load. Ito yung load niya. Okay? Itong dark one on this. So, traditionally, PV peaks in the afternoon and loads peak in the evening. Ba? Ito yung tinatawag natin. Ito yung tinatawag. Makita mo parang duck card. Ba? Kasi bakit nagpipik sa evening? Ito yung ano, di ba? Pagdating ng hapon, yung mga nasa trabaho, marami na tayong tao sa bahay. So bukas lahat ng mga ilaw, bukas ng aircon, or some other ano. Bukas ng refrigerator, open and close, di ba? So nagpipik ngayon dito. Eh wala na tayong PV. So diyan papasok ngayon. No? In order to compensate for this, para hindi muna pumasok yung malaking bayad natin sa utility or the distribution utility or the grid, battery ang pag-ano natin dito. Okay? Ang panlaban natin dito. Okay? So that is a storage may provide an alternative by allowing solar customers to store their excess generation rather than feeding it to the grid. With respect to that. Yan po yung duck carb. Okay? Kita nyo, di ba? Ito yung kinaano natin. At para ma-solve to, yan din ang ginamit ngayon sa smart grid integration. By installing those battery energy storage system, yung sinasabi ko kanina na 20, 40, 60 megawatts, 100 megawatts all over the country to support the grid para mawala itong duck carb na to. Okay? And this is this thing. Okay? Kita nyo rito, when we have that, etong kulay, kulay pula, grid electricity consumption. So, sino tumatakbo rito for our load? Yung supply from the grid. So, ito yung consumption meter natin. Pagdating ng 6 a.m., mag-aano na yan. So, there is now this PV generation. Ba? So, what will happen is that the PV generation will have a direct load consumption. Kung ano yung mga load consumption natin, then, kapag inauunahin niya, pag may sobra pa doon, i-charge niya yung battery natin. Okay? So there is the battery charge and the grid feeding on that case. Pagdating ng hapon ngayon, what will happen? There is now the direct feed in. Papasok ngayon kasi ano na to, di ba? Ang papasok na rito yung yung kuryente natin from the grid. Kaya pag wala tayong battery, diyan magpapasok ngayon ang battery. So we now have the battery discharge here. That is how and the supply from the grid. Pag hindi na kaya ng battery, there is that supply synchronized sa grid. So that is the usual process that we have. Okay? Then, this is the, let us say that is maximizing self-consumption based on that last slide. Ganito nangyayari. Okay? So we have power purchase from the grid, then supporting the PV now pagdating dito. Then we have they're also charging your battery. Then discharging the battery at the same time pag kulang, you have the ESS. And those are the early morning, kung ano nangyayari, the morning, the noon, ito yung kaanuhan ng ano natin, that we have a sustaining here. Pag konti lang ang load mo, so we have it, no? Then, ito yung evening ngayon, nagagamit ngayon tayo ng battery. Then kapag wala na masyadong battery kasi hindi mo na po pwedeng i-fully discharge yung battery mo. Dapat may matitira doon para kapag nagkaroon ng power outage, meron ka pa. Okay? So, lalo na, let us say, kapag ngayon, if you have a qualified net metering end user, okay, a qualified end user of net metering, so kapag sobra yung there is an excess power from the sun and the battery that you have, what will happen is that you can now sell it to the grid. So you become a producer at the same time a consumer. So you are a consumer. Okay? So when we pay for the consumption from the input meter, we are a consumer. So when we export, no, the excess power, we are a producer. Okay? We sell it to the grid. Yan po yung ito yung time of use na sinasabi ko sa inyo kanina, which is ESS charge prior. Okay? Then we have this connection, no, of the solar, the PV plus ES connects to the single phase grid. Okay. And we have this this PV SPS operates in a purely off-grid condition. Okay. Then we have from that, as you can see on this residential PV plus BESS plus EV charging, we have now the reliable system. So we can have the solar with the storage, then at the same time, you can now charge, you can now have a charger, no, for your electric vehicle. And what will happen? Libre na yung fuel mo. Pati ngayon para the electric vehicle, maintenance of this, kasi electric siya, wala masyadong mechanical parts, tatagal ng maraming taon. Then libre ang fuel mo if this is the system. Ito na po ngayon ang ano. So when we have that, we have a better cleaner energy and clean energy backup storage too. So you see, naka-modular type na siya with respect to that. No? And these are the components. No? So we have the solar photovoltaic panels, the inverters, no? And the battery storage. Then kapag meron tayong battery energy storage, kapag pag kulang yung battery mo to support it during the power outage, we have what we call a critical load sub-panel. Or what? This is optional. Yung tinatawag na backup box. Essential loads lang. Kaya lang kapag sobra naman yung battery mo, per your design, hindi mo na kailangan to, kaya optional lang yan. Okay? But usually, kasi sa ngayon, mahal pa ang battery. So we need these things. Okay, then we have other components as AC/DC disconnects, fuses, and so on our part. Then we have the racking and mounting. Kagaya nito, kaya ako inaano rito to make up this emerging technology. Importante itong racking mounting. Hindi basta mounting system to. Lalo na ngayon that we have signal number 5 o yung wind velocity, dapat hindi na yung dalawang railing lang, dapat tatlo. Okay? Para may pang-ano siya. Okay? So we have this performance monitoring system na ngayon na natin, from your smartphone, from your smart logger, you can have, no? You can have this monitoring system. And that is how system works, no? AC/DC, the inverter, then we have the battery to support that. Okay? Now, ano to yung mga no? I want to include this, no? What is this basic type of inverter? We have the string or centralized. Kagaya rito, ito yung string natin, di ba? Then this is, etong kulay blue, that is the string inverter or centralized inverter. So the single inverter connects your entire array, no? Array to, di ba? Of solar panels to your electrical panel. Kaya dito, DC to, meron tayong DC cable, then pag ano dito papunta ron, AC na to, right? So multiple strings of panels can be connected to its inverter. However, if the electricity production from one of the panels or string drops, o may shading dito, makaka-apekto kasi naka-series to. Okay? So that is the thing there. Okay? So we have this string or centralized. And those are the different types of string inverter in the market. So we have Huawei, we have SMA, we have Pronius, we have ABB. Ngayon ang ABB ang pangalan niya na Fiber. Binili na siya ng ano, yung ABB string inverter binili na ng Italy. Ang pangalan nila Fiber na. Those are the tier 1 brands of inverters in the market. Okay? So we have that. So as I mentioned, pag centralized, meron tayong isang inverter, naka-string siya. Pag nasira to, wala na lahat yan. Ito naman, this is string, tatlo naman to, pag nasira yung isa, pwede pa yung isa. Okay? Ngayon, sa mga solar power plant, dati, panay centralized. Ngayon, pinapalitan nila ng mga string. Okay? Kasi pag isa lang, sira na lahat. Okay? So, ang napakahirap pa nitong gawin for the solar power plant. Okay? And that will be something like that. No? Centralized, then we have that, no? Presentation kanina. Okay? Now, another is a microinverter. Okay? So, kita nyo rito, ang microinverter, this is one is installed at each solar panel. Okay, nakalagay na siya eh. Nandiyan yung converter niya. So what will happen, paglabas niya, AC na. So ito na ngayon yung trending system ngayon, papunta na tayo rito. Para wala na tayong DC kasi ang DC voltage masyadong not safe. Just imagine a residential that is 600 volts. Then in commercial industrial, that is 1,000 volts. Ang kaya lang ng tao, di ba, 80 volts, kikilitiin ka. So, kapag dito, wala ng DC, that is more safer. No? Sabi nga, solar is safer with respect to that. Ito, bawat isa to. No? Tapos, at the same time, if we have this, no, it maximize production, kaya yung harvest. Kasi hindi mo na kailangan string dito eh, bawat isa to. Okay, kapag yung isa, merong, let us say, may dahon o may shading, hindi maapektuhan yung iba. Hindi kagaya rito sa stringing, ba? Series yan eh. Paano makakaroon yung epekto ng iba? Okay? So, if some of your panels are shaded, times of the day, or if they aren't installed facing the same direction, microinverter modifies on that. Kasi dito sa, di ba? Pag sa string, lalo na yung mga nag-ano ngayon dito, dapat to, facing in the same direction, naka-string siya. Dito sa inverter, microinverter, pwede mong kahit saan. Ano mo lang siya, di ba? Dito sa Pilipinas, we are in the Northern Hemisphere. Kaya dapat yung panel natin naka-elevate papunta sa true south. Okay? So wag north, wala kang maha-harvest doon. So pwedeng true south for 100% performance during the peak sun hours or east and west, ba? So yung from the silangan papunta sa kanluran, di ba? From the east to the west. Okay? So pwede yon. Kaya lang may bawas ng konti ron, right? Hindi kagaya sa Australia, which is now talagang doon, nandun na lahat ng pinakaano sa Asia, no? Sa Australia, Asia Pacific. Nasa sila, nasa Southern Hemisphere, kaya baliktad sa atin. Sila naman, inaano nila panel nila sa northern portion. Okay? Sa south nila, hindi pa pwede. Ngayon, pag Singapore ka, nasa gitna. Kaya value, yan, ba? You can choose now how you position it. Okay? So that is a type now. Ito yung mga sample ng microinverter. One of that. No? One is N-phase. No? You have also, this is from US. Then there is Hoy Miles, no? Which is those are the popular inverters now in the industry from China. One inverter inside. No? This is something like this. No? Nakakabit na siya sa railing bawat isang panel. Okay? So you see, you have that. Okay? So whether
Engineer?
it is, yeah.
Yes, engineer, last 10 minutes po. Bali 5 minutes to wrap up po, and then we will be entertaining questions. Thank you po.
Okay. Sige. So I have the single phase and we have the three-phase system. Nag-aano na pala ng mabilis. So you have now, ito naman, it is now the power optimizer. So it is a hybrid, no, of the string and the microinverter. Kaya lang, ito yung mga optimizer. Hindi sila kagaya ng microinverter. It is just a conditioning device. Kaya pagbalik nito, DC pa rin, then we have this one. Ito pa rin yung inverter na string, kaya hybrid siya going to that. So what does it need? Yung power optimizer na yung ginagamit in order to increase the production. Okay? 11 to 13% or up to 30% energy. Tapos itong dalawa nito, yung kailangan natin ngayon na rapid shutdown for safe installation. Rapid shutdown system. So may built-in, ang microinverter may built-in rapid shutdown at the same time with the optimizer. Ito kailangan natin sa industry kasi kapag nagkaroon ng power outage, meron DC pa yan, meron doon 600 to 1,000 volts na nandun sa taas. Kaya delikado yun. Okay? Okay, and that is the optimizer. Every module also regarding that. So kita nyo rito, kapag may optimizer, there is up to 30%. So kagaya rito without optimizer, kapag merong isa, yung ma-affectan nyo ba? Pag with optimizer, then yun lang ang may problemang isa, yung iba, 100% performance. It is something like that in terms of the yield. And this is a safe house because of the rapid shutdown system. So yan po yung natin. Ito po yung battery energy storage system natin ngayon, na with the battery management, then we have the module. Okay. I'll just go on this. Ano na tayo? Then we have the racking mounting system that we have in the hardware. So depende sa mga roof type, pag mga steel lang, L-type. Kaya lang kapag mga Japanese style, yung pinamalit natin sa ngayon, sa Tegula, di ba? Yung mga carb, yung Japanese style na kawara, we need a Z-type on that kasi hindi po marami siyang patents, beatens, mga steel forming, 5 layer yun. Kaya dapat Z. Hindi papasok yung, hindi natin maikakabit yung Okay, so you have this one, ito yung Z-type. Okay, yan, kagaya rito, ito mga Tegula yan. Okay, so those are the different types, and also the materials that we need for this, and the performance monitoring, meron na tayo for the smartphone, may sure na natin, di ba, yung yung makikita na natin performance sa bawat panel, performance ng buong system, kapag may problema, and you have that on the system and the grid flow, you can have that here, makikita mo siya, and also the production per day, the consumption per day of your load, and also every month, so you can monitor everything. So you have the visible power flow from the grid, kung ano yung nangyayari doon sa system mo, then you have the module level monitoring of its, and the statistical indicator every day and monthly and all throughout. Okay, and this is the nating arc fault positioning. Ito yung mga may problema pag may mga, let us say, may mga crimping ng PB connector natin, di ba? Na may arc plus, yan, mamomonitor mo na ngayon, ba? From this application. Pag wala niyan, problema yung arc fault kasi, or arc plus, that is up to 3,000 degrees centigrade. Okay? So yan po yan, na auto detection of everything in the single pump. Ito yung hybrid system natin with the storage. This one with the best, yan yung configuration ngayon. Meron tayong lithium iron phosphate, then we have the critical load, yung sinasabi ko sa inyo ng panel, kapag kailangan natin ng backup. Okay? Just for the essential loads. And this is the technical innovation that changed the game. AC coupled, systems are modular, and you can add more batteries as needed in the future. Yan po yan. Ngayon, the emerging technologies now, okay, with respect to this, okay, I'll go to this. Ito na po siya ngayon, yung tinatawag na battery inverter. So meron siyang battery inverter at the same time, meron na siyang battery. Okay? So, you have this, in terms of this one, of this setup, where we have maximum 10 kilowatt for the PB, 5 kilowatt charging, 5 kilowatt to the load. So, firming ganun na nagiging tandem niya. Okay? So, also something like this. There is the PB. Ito dati, pag nawalan, ito magkakaroon tayo ng grid forming kapag meron tayong battery inverter. Wala na rito, wala na lahat, di ba? Not working na yung inverter mo. Ito, meron kang battery inverter, so still, it is working. So this is also for the zero export for that. Okay. So solar plus storage allows you to generate your own green electricity with your very own rooftop PV system. And alternately, you can store the electricity in the battery for later use. That is the concept. A storage system can make you even more independent of utility companies. So, pag may solar storage kagaya na nangyayari ngayon sa Amerika, parang ang grid na lang or yung utility is your backup. Okay? And this is the future, okay, of the solar plus storage residential energy solutions. Okay, so you have the microgrid there, you have now charging station for your battery. Lalo ngayon charging ngayon ba for the technology. In 8 to 10 minutes you can charge the battery and that battery can go can move you 500 to 600 kilometers. Just imagine that. Okay, so you have that. This is the Huawei Luna 2000 Smart Stream. Kita nyo dito, modular type. Ito, 5 kilowatt lang to, yung nasa taas niya, battery management system. Okay? And this is the battery inverter. No? This is an Alpha ESS brand in the market. And the Enphase, home energy solution, they have also their Enphase Enlighten. No? And Enlighten battery energy storage. And for you have that one, that's Huawei. So you see, okay, the modular system, something like that. Okay. So you have now everything there, on the with your electric vehicle charging. And this is the commercial thing. With respect to that, you can use it on the system of Enphase. Then we have this Huawei from the EyeSight. So yung merong power module niya, this is a battery inverter. Then ito yung mga battery module niya. So 5 kilowatt bawat isa. So we have now 15 kilowatt on that. Okay? And that is the system how it works. So 150% backup load, no? So you have, because you have a battery, solar plus storage, no? And a battery, and it is a grid forming function, as I mentioned kanina. Okay? That is the emerging technology now, no? You can see it, no? Then also, you can also integrate yung luma pa rin natin na diesel generator. So, pwede na siyang off-grid. Santayan lang po yan. Just to show how the technology now, no? The perfect combination of art and science. That is the module level shutdown to ensure safety. When rapid shutdown. And an artificial intelligence powered arc protection. Okay, following the light of the sun, we left the old world. So if you want to go fast, go alone. If you want to go far, go together. Thank you very much po.
Thank you so much, Engineer Virgilio S. Lozares. Thank you po sa inyong presentation. So we will be entertaining, before we award, of course, our plaque of recognition to our speaker, we will be entertaining isang question po. One question po na nag-send sa ating Q&A chat box from Sir Jeffrey Pahayahay. Ito po yung tanong niya, sir. Thank you, Engineer. I wanted to know from your perspective how long we can get return of investment with and without battery system, because the salesman usually says 2 to 3 years ROI without battery system.
Tama nga yun po, kasi nga nag-ano po ngayon ng nagmumura na ngayon ng without battery, nag-ano na po tayo ngayon ng mga 2 to 3 years, na dating 6 to 7 years. Ngayon, with battery, kasi hindi pa masyadong kamurahan ng battery. Kaya lang, because of the technology, it is now going to that. No? Minsan nga, bumababa pa ng 2 years kasi, why? Because of the savings that you can get. Depende po kasi, variable kasi yun, depende sa gamit mo. But, because of the solar plus storage integration, then you can, sabi nga, it makes your savings shine regarding that matter. Kasi the battery will now support the solar production that you have to support your load. Yun po. Thank you po.
Thank you so much, Engineer Virgilio Lozares. Of course, we will be awarding our plaque of recognition to our technical resource speaker. So, IIEE, Eastern and Central Visayas Region Latest Summer Chapter would like to award this plaque of recognition to Engineer Virgilio S. Lozares, in grateful acknowledgement of his invaluable service rendered as technical resource speaker during the 22nd Eastern and Central Visayas Regional Conference, given this 20th day of July, year 2023 at Summit Hotel, Tacloban City. Maraming salamat po, Engineer Lozares, for sharing your knowledge and your expertise in this field to the other electrical engineers who are with us in this online and technical session. Thank you po.
Thank you. Thank you too. Thank you very much.
Thank you. So now let us proceed. Kasi marami tayong naka-line up pa. We will now proceed to our next speaker. So our next topic is about short circuit calculation for low voltage system. So just a synopsis. This seminar covers only the steps and techniques in undertaking short circuit calculation for low voltage system manually as per ANSI standard. It is important for us to calculate the different short circuit currents in the various point of electrical power system. Having the short circuit currents, electrical practitioner can specify the important ratings of the overcurrent protection devices or OCPDs, such as the KIC and the momentary ratings. Furthermore, the withstand rating of cables and bus bar bracing can also be properly specified. And so, to discuss to us this topic on short circuit calculation, we are very privileged to have our resource speaker or our resource person all the way from Cebu City. Ayan. His specialization is on power system design and installation of industrial plants and commercial establishment. And Presently, he is the General Manager of the Novicio Construction Supply and Services. Ladies and gentlemen, let us all welcome with a big round of applause our resource person for this topic, Engineer Jonrel P. Novicio. Hello, Engineer. Engineer, are you there? Ayan, I think he's here already.
Hello, ma'am. Good afternoon.
Ayan, good afternoon, Engineer po. You may proceed po with your topic. Engineer, I will be calling your attention po if last 10 minutes na po para aware ka lang po that you have to wrap up for the answering of the question. Sige po, you may now proceed. Palakpakan po natin Engineer Jonrel P. Novicio.
Good afternoon po sa lahat ng ating mga participants sa ating 22nd Eastern and Central Visayas Regional Conference. Tanong ko lang po if you can view my screen.
Okay naman po, Engineer. We can already view it po.
Sige po. Let's start, no? Medyo okay lang ba tayo kahit alas 12? Okay naman.
It will be a working lunch po, Engineer. Anyway, online naman po. We can do it on the side. Thank you po.
Anyway. Sige, maraming salamat po, no? So, as mentioned a while ago, our topic would be short circuit calculation in low voltage systems. Then, our objectives for this seminar or webinar, a while ago. At the end of this seminar, we'll be able to establish the basic steps, no, in calculation of short circuit currents in low voltage, and to be able to calculate the multiplying for a while. Multiplying factors applied in symmetrical RMS fault currents to determine the symmetrical fault currents for the specification of interrupting rating of overcurrent protection devices like circuit breakers. Now, for our limitations, we will not discuss the theoretical discussion on short circuit currents, symmetrical components, as well as the network theorems, as well as derivation of formulas. And it is our assumptions that the attendees has a prior knowledge in electrical engineering, especially in the short circuit calculations. All right. So, introduction, the power systems at start must be planned, can be projected or constructed before it will be commissioned and put into operational. As much as possible, the loading profile of your electrical power system need to be available so that the factors or many factors to be considered in your design. And one of the requirements for the design is the short circuit currents, because the short circuit currents will be the basis for our setting of the protections of your power systems. So that means the presence or the influences of lightning strikes nowadays, very common. That we know that it will disturbs our power system. So that is why we have some protections like lightning arresters or surge arresters, just to make it sure that our system is not being disturbed with those kind of natural phenomenon that is present in our environment. So this means that short circuit currents is a very important considerations in our designing or in the safe operation of your equipment in the power system. So how to solve short circuit currents? Actually, we can do it manual, meaning by hand computation. And we can do also by using computer programs like software. One of the common software that we have in the market is ETAP. Now, it will depends on your how big or how broad is the system is. But if it's a radial system, that is short one, we can do it manually, depending also to your what you call this data available. If it is a network system or a bigger one, so it is more practical or logical to use computer programs, considering the what you call that, the steps or the laborious works to perform those calculations. Now, why we need to solve the short circuit currents? How we are going to use it? Now, here are some of the applications of the short circuit currents. It can be used in the interrupting capacity of your overcurrent protection devices. It can be used also in protection relay, and even also in arc class studies nowadays. So if you're familiar with the Dole, what else, the OBO, nowadays they are now requiring designers to perform this kind of calculations. This is for additional safety of our system, as well as to the maintenance personnel or anybody who will occupy in that building, that to see to it that our electrical systems is properly designed. All right, so what are the causes of fault, and why is it that there are faults, by the way? So for a while, okay, thank you. Sorry for that technical issue. So going back, what are the causes of fault? Actually, the fault occurs in the system. It can be in an internal factors, and it can be also an external factors. Now, for internal factors, basically this is more on the insulation problem. It can be inherent. That means over time, the insulation will degrade the performance. Its insulation resistance will going down, and that's the time it will start the insulations to collapse, resulting from either can be a surge, or it can be a lightning strike, or it can be really a fault that will damage your insulations. And if you're not taking consider that one, it might cause into a short circuit, and it can be a disastrous one if we're not able to handle it properly. Now, for external factors, these are incidents that will happen more often times for the outdoor electrical substations, or it can be a transmission lines like animal intrusion. In mountainous area, very common, snakes. It will come to the cross arms of the electric post, or it can be vegetation. When there is vegetation below or beneath the transmission lines, then once the lines or the minimum safe distance is being breached, then it can create shutdown, or it can create power interruption. And commonly in the urban areas, so we have this earth construction works for underground system. So there are instances that the power line is being hit by the excavator, and there you have also faults. But these things are not commonly happen. But oftentimes the problems are here in the internal factors. All right. Wala. Okay, so what are the types of fault? So faults are being categorized or being identified as unbalanced or unsymmetrical fault. The other one is balanced or symmetrical fault. So what does the unsymmetrical fault? These are single line to ground, line to line, and double line to ground faults. Whereas for the balanced or symmetrical faults, this is what we call as three-phase fault. Then as to in terms of occurrence in our electrical system, the unbalanced fault or the unsymmetrical fault, it will happen 87%. No? Most of the time, this is the kind of fault that we will encounter in electrical system. For three-phase fault, this is of course, this is the largest faults that will happen in our system. However, the occurrence of this one is about maybe 10% in our system. This will happen only when there is what? There is metal that being extended to the power lines, or you have this vegetation falling down to your transmission lines. There you have your three-phase fault. But most of the time you have the single line to ground fault and line to line fault. So what are the fundamentals consideration? So in fault calculation, the proper selection of protective devices and their selective trip settings is based on short circuit calculation. So I mean to say that the interrupting rating of your circuit breakers, the trip settings of your protection relay is based on short circuit calculation. So that means short circuit is very important in any electrical system design. So having this value, you could say na mas safe yung data na yung system natin, or it is well designed. Parang ganon. So of course, the main short circuit protective devices in electrical systems are breakers and fuses. Okay. Now, why is it we need to calculate short circuit? Because if we undersize the interrupting rating of our overcurrent protection devices like circuit breakers, okay, so this will end up a disastrous incidents. It can be a fire-borne explosions, and it can injure personnel, and worst case, there are fatal incidents. So I mean to say, we really need to specify the right one or the correct one. And oftentimes, we will not calculate, because as I've said, it takes some requirements or data requirements. It takes some calculations, and maybe in because of time requirements, we'll just assume. Let us say, okay, that's 10,000 kiloamperes. the interrupting rating of your circuit breakers without religiously calculating the entire power system. Now, what if the fault is greater than that amount? So if the short circuit current, shall we say, is 15,000 or even 20,000 amperes, then your circuit breakers were not able to hold the magnetic force during fault, so it will explode. Or the bus bars, the support, because of the high thermal energy that is occurred during the fault calculations, it will also melt down and burn, and it will start fire. Now, conversely, if we will also oversize or overrated our protective devices, as to short circuit issues, lamang tayo dyan, no? Wala tayong problem kasi we size it a very high short circuit capacity of our protection devices. So, I mean to say, we are safe. However, it is very costly. So, I mean to say, kung masyadong mataas yung interrupting rating ng circuit breaker mo, napakamahal din naman niya. So, yan ang implication niya. So, in other words, it really takes calculations so that we can come up those correct sizing of your overcurrent protection devices. So it cannot be underrated because nasasakripisyo yung safety. And it cannot be also oversized or overrated because we sacrifice also the economy. So yung project baka hindi na matuloy or baka yung breaker mo mas mahal pa sa building yung mangyari doon. So what I'm trying to say is we need to undergo or we need to go through the calculations proper in sizing up your overcurrent protection devices so that we can specify the correct or the safe and the safety and economy factors should be meet up halfway. Okay, so again, it follows that the short circuit calculation will be their utmost importance, and the interrupting capacity of the short circuit is the maximum short circuit current that will occur in your system that your protection devices like circuit breaker will able to handle, or able to hold na hindi siya sasabog, na hindi siya mag-explode. So even also the bus bars, the supports, and other components in your switch gears, they were able also to withstand with that kind of thermal and mechanical stress that will occur during the short circuit. So sila, they must be also coordinated with the short circuit also. They are also need those values for the publications. So what are the assumptions? Okay. So our assumptions in undertaking the short circuit calculations are load currents are not considered. So what are these load current? These are rated load or normal current. The voltages is in nominal and the motors are run in rated voltage. Transformer impedance, we use the actual values. And the switchboard, the bus bar, the switch gear, all of the impedances of the bus in this equipment or components are neglected. Anyway, this is very short. Then the fault is bolted. That is, it has zero impedance. In other words, the materials, or shall we say the metal that being short circuit from line 1 to line 2 or line 1 to ground has zero impedance. Then reactance of breakers, transformers, current transformer for CT and PT are also neglected, as well as the exciting current of your transformer. So thus the type rating of the protective devices will be higher. Why? So we are taking a conservative approach in the calculation of short circuit current so that our assumptions will be a little bit higher as what is the actual current really occurs in the system. So we cannot also afford that it's too much high, because I have said there is an economic implications after your design kung maging ganun yung approach natin. So I know there are a lot of literature all over the internet or journals or whatsoever source that you have of knowledge in how to solve or how to undergo short circuit calculations. But this is the steps that we're able to develop over years. Then we do it in a step-by-step procedures so that for those new in this kind of calculations will not get lost along the way. Anyway, if you're really good at it, you can look and maybe you can enhance, or maybe you can help us on how to really do a short circuit study in the most comprehensive and in the most AC way, because oftentimes why people or why engineers sometimes neglect or did not perform short circuit studies because of many data to get. Or other one is there are more calculations actually. Now this is more than Ohm's law, but actually Ohm's law is still there. We cannot be taken out in any electrical calculations. All right. So as we have developed 7 steps. Step number 1 is we are going to prepare the single line diagram. Okay. Yeah. Number 2, select a convenient base. Number 3, get the proper impedance. Number 4, make an impedance diagram. Number 5, combine the impedances using the Thevenin theorem or circuit. Determine symmetrical current values and evaluate the fault XR ratio to the standard test XR ratio of low voltage circuit breakers. And we need to apply multiplying factors to the calculated symmetrical values if necessary. So again, we start from the very beginning or from the very basic one going to the end. Okay, so let's do this one by one. I will present here, as an example, but I suggest that when you do your short circuit study, much better if the single line diagram is the one in your working area, or is the present na ginagawa nyo na project. That would be more interesting, kasi kapag ginagawa talaga natin or meron talaga tayong project, so pag calculate natin, nakikita agad natin doon sa site or na-apply natin immediately. So parang from theory to practical agad eh. Pero kung diagram lang, well, for the meantime, nawala pang project, practice muna. So here, I have your example of single line diagram. Now, this is my single line diagram, a very short one, from transformer going to bus 1, 4.16 kV, and have here a transformer. Then going to bus number 2 at 230 volts. All right, so this is an example of single line diagram. This is one of the requirements before you can do short circuit current. If no single line diagram, we can never calculate the short circuit currents. Okay, so very important, step number 1. So even meron akong mga friends din or kakilala na they'll ask some help regarding short circuit calculation, so we provide the data. So number 1, sabi ko, please give us the single line diagram. Kasi kung walang single line diagram, we can never proceed to step number 2. Okay? So step number 2, select a convenient base, MBA or KBA. So, since yung methods natin in short circuit calculations, we are using per unit system. So we must have this convenient base, either MBA or KBA. It will depends on how big is your system. So we have here recommendations. Use MBA or KBA that is available in the system. When you say, let us say your transformer is 1,500, I'd like to use that one. Though it is not really shall we say, a standard, but later on there is, kumbaga, you're one step ahead. If you're using an MBA or KBA value that is available in the system. So why I use 1,500? Because this is the rating of our transformer. Okay. Step number 3, get the proper impedance values. Okay. We're done with number 1, number 2, and now we are in step number 3. We have 4 or 5 steps left. So what are the impedances values needed? Basically, these are the electrical system equipment or materials found in your system. So what are these impedances? Okay, these are the sequence network diagram that we have. So if we study the symmetrical components, which is not part of these discussions, we have the positive, negative, and zero sequence impedances. Now for positive, this will be same as the original phasor. For negative, same, the original but without source. For zero, it is equal in magnitude but in phase with each other. Now for this discussion, we only consider the positive sequence. Why? Because we are only calculating the 3-phase short circuit currents. Okay, so that's why we are only use the positive sequence. Now, some author, they are really like to write the positive plus, no, subscript plus, that means positive reactance or positive impedance. But some authors also, they love to write the number 1. So it depends, no? It depends on the author. There is no such thing as wrong or correct, but it depends on the author. If it's positive, is using number 1, or it's negative, using number 2, and for zero, they're using 0. But some author really love to write the plus symbol for positive and negative symbol for negative and 0 for 0. That will depends, no, on how, kung saan kayo maging convenient, kumbaga. So these are the impedances. Basically, ang nasa power system natin are the generators. It can be going to the utility line, no, and going to the transformer, and motors. Of course, there are also what you call this. There are still medium of connection. So that means they are being interconnected by means of wires on keyboards. So the medium connection between these machines are the wires and keyboards. Okay, so how to get the impedance of the generator? So we have here the formula. As I've said, I presume that we have a little background of short circuit theory and short circuit study. So we need to solve the 1 here. That means positive. G per generator, P to per unit. Ito yung formula natin. The rated times the MBA base, MBA rated. Then multiply natin ng voltage ratio and V squared. Okay? So itong per unit value of any quantity is the ratio of actual to the base. Actually, itong per unit is parang unitless, no? Kasi MBA, tapos KB. So parang unitless siya. Yung unit is maging per unit. That's for generator. Okay? So, sorry. Now, next is we proceed to the utility. So, what is utility? It will depend on your areas, no? For us here in Cebu, we have VECO or Visayan Electric Company. We have also MECO, the Mactan Electric Company. But I believe in Region 8, we have LIECO. and some part of Cebu are Sebeco, and if you're in Luzon, you have the Meralco. So this will depend on your area. If you're in Mindanao as well, so you have Sipalco, you have Double Lights, and others. So we have this utility line. We need this one because this is the point where we connect our primary line. And in the system, we have here what we call a short circuit level at this point. So, sino bang may data dito or sinong may alam kung ilang MVA ba yon ang available na short circuit capacity in that area? So, let us say, meron kayong bagong building na itinayo, meron kayong projects. So, part of the electrical system study is to get the short circuit MVA in the tapping point of the primary line. So, as designer, basically, you need to coordinate with the local utilities, no? If it is Beco, Meco, Lieco, Sibeco, or Meralco, and maybe you can, if you can get it immediately, much better. But if not, maybe you can write a letter, not to formalize everything that you need. The short circuit MVA rating of this point due to the following blah blah blah. We have new commercial or industrial buildings to be constructed, and part of our electrical system study is we need a short circuit MVA of this area, and so on. So for me, I have here an example to VECO. Once upon a time, I write a letter. Then VECO reply us that this would be, since VECO is a 23 kV primary line, line to line. So we have here the three-phase fault at that point is 3.41. The single line to ground fault at that point is 2.42. Now, as I've said a while ago, three-phase fault is usually the largest fault that will occur in our system. Then they are also given the XR ratio. No? This can be useful in some studies of the power system. So, mean to say, if I will multiply the voltage and the ampere, I have the volt amp. I have 78.43 MVA. This is the short circuit rating at that point. No? And the per unit value of the utility is 1.0 in its own base values. No? If you're asking why it is 1.0, actually there is a derivation for this, but will not part of this discussion because we cannot finish the time being given to us. All right. So next for utility, transformer. So per transformer, you can go to the nameplate, or me can be, if you have an access for the manual, much better. All right. So same, actually, there same formula for transformer and generator for converting their per unit value. And I have here an example, no, a nameplate rating coming from Siemens manufacturing a transformer. Here is the impedance, no, that we're looking for. That is the Z. Right. Ito yon yung rated. Ito yung Z per unit niya, this one. So much better if you have the nameplate rating. In the absence of nameplate rating, you cannot retrieve, that's available. If manual is available, much better. If not, then you can go to standards. So I mean handbooks or handbook, standard handbooks. There you can find the IEEE or IAC, or even Indians or Japanese, I think we have. And I think the manufacturer nowadays is very accessible, no? Because of the technologies that we have. And maybe you can easily coordinate with them so that you can really get, no, the exact impedance value of the transformer. But anyway, the standards is within the range. No? Let's say 5.5 to 6 or 5.5 to 5.9%. So within that range, and I think the error will not be that significant, no, if we refer those standard handbooks in the absence of nameplate ratings and manuals. Okay. So what's next is the wires, no, and cables. So for wires and cables, more or less, you have same, no, DC for cable and one for positive again, the rotate, the MBA, and squared. And for cables, for low voltage, we have the Philippine Electrical Code, or maybe you can use also the manufacturer's catalog, no? So we have here an example. This is found in table 10.1.1.9 in the Philippine Electrical Code 2017 edition. So there, the title says that this is the alternating current resistance and reactance for 600 volts cables, 3-phase, 60 hertz, 70 degrees, 3 single conductors in a conduit. Okay, please take note. It says 3 single conductors in conduit. If the number of conductors in your conduit is more than 3, let us say 6, so you cannot use this value here. Okay, that means only 3 single conductors in a conduit. And another thing that we need to be aware of, that this values is ohms to neutral per 305 meters. Okay, this is important in our calculations of getting the impedances of cables. Now, for power cable, now these are the high voltage one, or the big cables. The impedance, as we know, is Z is resistance plus reactance, no, or the J. And we will not go this one in details. I just like to show that we can calculate actually, the reactance or the impedance of the power cable using this found in standard handbook or this IEEE and other references. No, if you have plenty of time, if you have the luxuries of time, I suggest you calculate, because it is more anong tawag ito? Parang mas maganda ang feeling ba kapag talagang kinu-compute mo manually, na then you get the right answer. The big challenge lang kung you do it manually and you get the wrong answer. But anyway, so this is the formula, no? We'll not discuss in details. These are some of the configurations when we install the power cables. Oftentimes, we recommend that it should be in trefoil or kanina ka triangle yung orientation niya. Then we have here an example, no? I just like to show.
Okay, I think na-disconnect po si Engineer Novicio. We'll just, ayun. Okay. Engineer. Okay, I think we're having a little technical error. Na-disconnect po si Engineer Novicio. But I see him already on the line. Engineer? I think may problema with the internet connection with Engineer. Engineer Novicio? Okay. Habang hinihintay po natin si Engineer Novicio, I would just like to remind our participants that for those who have questions po, you can actually chat it at our question and answer chat. Engineer? Na-disconnect po.
Pasensya na po. Itong internet talaga namin eh. Ayaw makipag-cooperate.
Opo. So, paano po? Can we continue?
Yes, ma'am. You will continue
okay,
po.
Sige po. Okay po. Sige po.
Sige, thank you. Okay, so pasensya na talaga. Kasalanan ni PLDT yun. Anyway, so dali ha. Hindi ko makita. Okay. So let's continue. So I have here an example. Actually, this is an excerpt from the technical report of Engineer Brian Pasilan during his PE examinations. Now he's our governor. So here it shows it is a 240 mm² XLPE power cable. Then it's installed in this configuration. Now if you really calculate, you have this formula. Now again, I just like to show now this is how it looks and this is how you're going to calculate. There are many references here, IEEE as well as the symmetrical components. Now let's go to this page. This is the calculated reactance. Okay, the value is 0.11525 ohms per kilometer. And if we try to compare it with the tabulated reactance, okay, so as you can see, it's 114.114 and the calculated is 0.115. The difference is not that significant. So what I'm trying to say is, if time is your problem, then you can escape this calculation, and let us say you have 50 or 100 feeder lines. You will do it 50 times. Whereas if you are using a table, you just go to the table and put it there, then it's done. So that's another way of getting the reactance or impedance of your power cable. It depends. It depends on your situation. You can do it, calculate, and you can also refer to the table. All right. So we're done with tables. We're done with wires and cables. We proceed to motors. Now, since our topic is low voltage system, our motor also in this discussion is also low voltage. Okay, so you can also refer to motors and other international standards. And again, if you can have the manual or if you can have the nameplate rating, that is the best. But what is usually happen in the industry is that the design stage is unang nangyayari after na yung procurement ng mga materials. So that is why for calculation reasons, we need to refer to the handbooks or need to refer to the standards. And I think that's the work of the project manager, or it can be a technical consultant to review the design later on once the project is about to be implemented, just to counter check that yung mga specs, especially the short circuit, is within the safe value. So for low voltage motor rated rated, the reactance is 0.25 per unit. Take note, this is on motor rated kVA, right? And these motors are below 600 volts. And for, let us say, 660 volts or maybe 1000, you can use 0.20 per unit. Okay, because in low voltage induction motors, approximately the kVA is the same as the horsepowers. Approximately, they're not really equal, but approximately the same. For calculations, this is coming from IEEE standard. Okay, so For negative sequence, no, just in case you will do unsymmetrical short circuit calculations, for motors below 600 volts, it's 0.15 per unit. No? This is coming from the book of symmetrical components for power system engineering by Blackburn, and also in IEEE 141 1993. All right, so that's for the motor. And let us try to check for the impedances. We're done with generators, we're done for the utility, we're done with the transformers, we're done also with the wires and cables and motors. I think in step number 3, we're done for it. And we're done, yes, done wires, we're done also, okay, induction motors. So we'll go back to, we'll proceed to the next steps. All right, we're done with step number 3, which is get the proper impedance values. Okay, step number 4, make an impedance diagram. So we have a single line diagram and we have also impedance diagram. So how does the two are related with each other? Okay, so if we recall, a while ago I present this one. This is the single line diagram of our system that we're talking today, and this is the impedance diagram at the right side. Now, as you can see, we have here the source, the utility, which is here from the bus, and you have here the transformer, the XTR. Okay, here, and we have here the impedance of the cable, this XLPE. Okay, ano siya, yung equivalent diagram, and this is the bus, and this is also the bus at fault number 1 at 4.16 kV, and down to the low voltage we have the transformer, a 500 kVA. Okay, and this is also the transformer here. This is the impedance, and of course the XLPE. Sorry, this is the PVC now, no? THHN, I think, or THW, or not being specified, but it's a low voltage cable. And we have the load, which is the motor, and we have here the reactance of the motor. And again, where we're going to get these reactances for utility, you get in the utility. For transformer, you can do nameplate or catalog. Power cable can be formula, or it can be a table as well. The same for transformer. And for LV motors, LV conductors, you can go to directly to the PEC, or you can do also in the catalog of the manufacturers. Likewise with motors. Okay, so that is where we're going to get those values. Okay, so here, how we're going to get these values? Okay, for utility, we know that it is 1.0, no, at 78.43 MVA. For transformer, you have also the present impedance, but we have here the cable, no? Ang cable is, we need to refer to the table, no? So this is the table. It is 70 mm squared. No, this is 70 mm squared. I'll try to zoom it out here. These are the values. Okay. So you have this, take note that the values is in ohm per kilometer. That is not yet in ohms. So we need to convert. Okay. And take note also that the reactance here is at 50 hertz. But our system in Philippines is 60 hertz. We need also to express our reactance in 60 hertz, not in 50, this value. Okay. So with this data, we can now calculate our power cable. No, this is 3
3420 plus 15961I, no, for the J components. 10 is 10 meters, no, ang length sa cable natin. Yung 1,000 is to convert, no, the 10 over per kilometer kasi yung ano natin. So if you do the math,
Yun. Na-disconnect na naman po si Engineer. Engineer Nevisho, I think he's having problem po with, ayan, Engineer. Engineer, wala na naman po tayo. I was just actually about to remind you na po kasi it's last 10 minutes po for the presentation.
sige po ma'am.
Sige po. Okay po. Please continue.
Pasensya na talaga. Okay, so you have here did you see my screen, ma'am? No?
Not yet, sir. It's not visible yet.
Not visible yet. For a while.
Yes po. Hindi pa po siya nakikita.
That one, ma'am.
Wala pa po, sir.
Wala pa po.
Wala pa. Sige, hintayin lang natin baka. Ayun, I think it's starting po, pero black pa siya.
Mahina talaga yung internet sa amin eh.
Baka may delay lang, engineer. For the participants, you may type your questions because after mag-wrap up ni engineer, we will be answering questions po. Thank you. Ayun, it's already visible na po, engineer.
Sige po, ma'am. So, okay, so we're done with the power cable. Ang transformer din natin is nasa nameplate rating naman siya. The other one is the low voltage cable. As I've said, we can go directly to the PEC, no? This is a single conductors. You have here the reactance, and we have also here the resistance. So you have here the number 0.027 and 0.059 for 250 mm squared na kable na ginagamit natin. So here, but take note, as I've said, it is 305 per meter, no? Kaya meron tayong 305 dito. And why this is merong divisor na 4? Because it is 4 conductors per phase, no? Habang dumarami yung kable natin, lumiliit yung resistance at saka reactance kasi naging parallel sila. Okay? So, yan. Tapos na tayo sa tawag ito, sa pag-convert, no, into its per unit value in their rated values, no? Naka per unit na lahat. Meron pang wala pala, yung kable, no? So yung kable, i-convert natin yan same as the utility, same as the transformer, no? As well as the motors. We need to express this one into per unit values para we can combine or we can simplify the circuits. Okay? So how to convert the per unit values? We have this formula we discussed a while ago, no? Now, our chosen base value is 1,500 kVA or 1.5 MVA, and we distribute or substitute, in the formula, and we have this value. Let's do the math, and you have this, no? Utility, transformer, cables, what else? Transformer number 2 as well as cables and also motors. Okay, so this is now your impedance diagram into per unit values. Mean to say all the resistance and reactance here are into per unit values. Okay, so after that, anong gagawin natin? So we're done with step number 4. Ito yung step number 4, medyo dito yung maraming gagawin. No? Yung transformation o yung conversion ng mga impedances. In step number 5, we do the impedances or combine the impedances using Thevenin theorem. All right. So what is Thevenin theorem? Again, we will not discuss this as that's details, but it is a network, no, looking at you can get the Thevenin equivalent circuit. No, ganon siya ka with all of the theorems sa circuits. Yung Thevenin theorem is one of the important theorem in solving short circuit calculations. Okay, so ito yon yung per unit. Okay, how it being used in the short circuit calculation, that the per unit short circuit current is equals to the E, the source, the voltage, over the Z or X, no, per unit. This is the per unit ampere. So this is the per unit current using the per unit sad na impedance and per unit pod na voltage. But the actual short circuit current will be per unit times the base currents. So if we solve the base currents or the currents, it's voltage over the KB or MVA. These informations are available naman sa system natin. So ito yon yung Thevenin short circuit natin. Okay? So let's proceed. So ito na yon yung circuit natin or yung impedance natin pala. So remember, in simplifying the reactances and resistances in your impedance diagram, we're going back to the physics or the circuits, no, that you cannot combine or you cannot simplify yung resistance na hindi naman series at hindi naman parallel, no? So in this case, this is a parallel one because the current that will pass are the same. No other path for the current to go. So you can add, you can simplify. We call it Z1, and this other side we call it Z2. If you do the math, you have this result here. If na meron akong mistakes, just let me know. No, just do the calculation. But what is important here, we know the process. No, we know how to do it. No, just use your calculator and let it do the work for you. Okay, so here we can reduce this one. No, okay, we can redraw to make it a little bit friendly to the eye. No, to reduce. Okay, and you have this. We need to know the impedance, no, at this point, no, of the network. And this one is a parallel now. We can combine again. And you know the formula of the parallel, no? It's the product over the sum. If you do the math, okay, you have this. Now you will get the Thevenin equivalent circuit. So we're done with step number 5. So what's the next step? Determine the symmetrical current value. Okay, so this is the formula for the symmetrical current. It's I per unit times the base. Now, if we recall, if we recall, the I per unit is, this is the Thevenin voltage over the Thevenin equivalent na impedance. All right, you do the math, you have this value, and the base. So take note that our base value is 1.5 MVA, and it is a 3-phase system, and the fault occur at 4.16 kV na bus, yung bus number 1. So yung short circuit current is ito yon. And if we try to call the symmetrical short circuit current, which is the per unit times the base, then you have this value, 1.5. So nasa medium voltage na bus na yan. Now let's also calculate the low voltage at fault number 2 here. Okay, this is fault number 2. sorry. Here, this one is fault number 2. And again, let us draw the impedance diagram. And I believe all the impedances were being solved already. It's just a matter of the point of fault now is being changed. But as to the impedance of the cable, transformers, the motors will be the same. Okay, so we have here impedance diagram. We are going to simplify. As you can see, the fault is here in the bus number 2. This is bus number 2. No? Sorry, wala ni na update. This is bus number 2, which is fault number 2 at the bus near the motor. No? Again, same procedure a while ago. Let's do the simplification of the circuit so that we can get the Thevenin equivalent circuit at the point of fault. That's the main objectives why we need to simplify all the networks or all the impedance networks to get the Thevenin equivalent circuit so that we can get the per unit current. And once you have the per unit current, you can multiply it to your base current, and there you can have your symmetrical short circuit that can be used in the specifications of your circuit breakers. All right, here is the diagram. No, just follow for it. No, I believe it is being drawn and can be follow. Okay, this is the Z1 now, the Z2, and if you parallel this one, you can simplify this one, the product over the sum, and there you are, you can get your Thevenin equivalent circuit. Okay, so we're done, and we will solve again the short circuit current, the symmetrical. This is
Na-disconnect na naman po at si Engineer Novicio. Paano kaya to? Engineer, makakabalik pa ba si Engineer? By the way, may mga nag-chat dito regarding the slide. Sige po, we'll take note of this one. Engineer? Nawala naman po kayo.
pasensya na talaga, no? By the way, tapusin ko na. Mali, kunti na lang, kunti na lang.
Opo, kasi we'll have to proceed with the next po. We're
Ilang
already...
minutes? Ilang minutes na lang yung sa akin.
Kanina pa po yung 10 minutes, sir. Opo, we should be entertaining questions already. Pero sige po, extension po
Sige.
ng last 5 minutes. Kasi
Sige.
andito na din po yung next resource speaker natin.
Thank you po,
Opo.
thank you.
Out of time, sir. Opo, thank you.
Sige. Okay, so let's proceed. No, running out of time. So this is now the fault, no, at bus number 2, which is at 230 volts. Okay. So solve na natin yung symmetrical fault, which is the step number 6. Now, let's find the step number 7. Ito yung pinaka-last na steps, no, for low voltage. We're going to evaluate the XR ratio, no, to the standard test XR ratio of low voltage circuit breakers. We need to apply factors to the calculated symmetrical values if necessary. Now, this calculation
Okay. Unfortunately, talagang nadidisconnect pa talaga si Engineer John Yun.
may apology talaga, ma'am, no?
Opo.
Actually,
Paano po?
kunti na lang to, ma'am. Maliit na lang, kunti na lang to. Last step na sana eh. Matapos na to eh.
Opo. So, paano po yan?
Sige, last
Continue
to
na lang po.
disconnect.
Okay po. Sige po. Hopefully, hindi ka na po ma-disconnect, sir. Opo. Sige po.
Sige. Tuloy natin, no? So, ito na yung last na steps. Okay? So, if we study the short circuit current, parang ganito talaga yung behavior na niyo. At start, no? By that time, it will fold. So, ito yung asymmetrical, but over time, maging symmetrical siya, no? For how many cycles. And yung part na yun na nagpalaki sa kanya is called the DC components. Now, let's proceed to the application. Now, in the multiplying factor, meron talagang mga formula dyan, no? Which this one. And as said, over time, yung pag-calculate natin, meron talagang using by formula, but meron namang mga table or tabulated. So let's proceed to the table. Now, for equipment short circuit ratings, depende sa system voltage. Kung medium voltage at saka high, ito will consider the closing and latching and the interrupting capability. Now, for low voltage system, ito lang first half cycle. Ito yung mga interrupting capacity, which is our topic for today. So, forget mo na yung medium voltage. So, from IEEE standard, So, ito yung mga XR ratio natin. No? If beyond this one, na yung XR ratio natin, meron na tayong corresponding na multipliers, which is nandun naman din sa mga tables. So, ang key lang natin, no? Ang key natin dito is if the calculated XR ratio is less than, yung calculated XR ratio, this is your XR ratio at the point of fault. If the calculated XR ratio is less than dito sa XR ratio test, now which is nandito sa from IEEE standard na handbook, kapag less siya, so hindi ka na kailangan mag-multiply. So meaning to say, if let us say 10,000 yon, 10,000 agad. Pero kung above with this value, so you need to add a multiplying factor. Kasi nga, dahil dun sa DC components, no? Matagal kasi yung decaying time niya. In order to your circuit breaker were able to withhold, no, the short circuit current. All right. So ito 'yon, no? Yung mga XR ratio based on IEEE standard. Now, ito yung sa low voltage na mga circuit breaker. Power PCB. Ito 'yon, yung mga multiplier niya. Then we have here, since yung fault natin is nasa 17,000 amperes, so dito sa table meron kasing 10,000 or less. So kung maliit yung kurente mo na short circuit, dito ka. Pero if above, in this column. But if more than 20,000, you use also this column. So madali siya kapag merong mga tables rather than using those formula. All right? So in our case, this one, no, our symmetrical short circuit current is 17,000 17.7 kiloamp. Now, the next step is we need to calculate the XR ratio at point number 2. The XR ratio is 0.18. 54 divided by 0.1041. By the way, what is the XR ratio? This is the ratio of the reactance and the resistance at the point of fault. Now, which is equals to 1.78. Now, kung titingnan natin from the table, yung 1.78, okay, yung multiplying factor natin is 1.0. So, mean to say, yung 70 na yan is good enough, no? In our calculations. So, nakalagay dito, since the XR ratio at point of fault is less than the XR test value, will not add multiplier. Okay? So, what is the closest? Now, according to standard dual equipment, yung 17, wala namang 17, but the closest is 18. No? The 18 will be the minimum. But if you can go 22 or 25, no? If money is not an issue, maybe you can go 22 or 25. But at least the minimum interrupting capacity of your breaker is at 18. All right. So I have here some example, one example only, no? This trend. Ang XR ratio niya is more than 7, it's 7.68. So kung titingnan natin yung table, Okay? Tapos yung fault current niya is 18.7. So you cannot say na 18 siya, or you cannot say na yung ano mo is 22. Because if we try at the if you try to look at the table, yung multiplying factor mo is 1.23. So dito talaga natin ma-determine if we really need to multiply or not, no? That will be based on the XR ratio at the point of fault. So this is the most this is the deciding factor, no? So kung mababa lang yung XR ratio, well, that's safe. We will not multiply. But if it is more than 5, no, as shown a while ago, then you need to multiply na, no? This is more than 5, 1.1 na siya agad. Okay? So the closest for 23 is 25, because if you size it 22, then you'll be undersized. All right? Next. This is now the question. So, or this is the realizations or everything na we discuss is, in undertaking the short circuit calculations, ensure to follow the minimum 7 steps as discussed in this presentation. Now, in the absence of the reference of standard table for the selections of the multiplying factors, after the calculation of the symmetrical fault current, is there a rule of thumb? No? So, the big challenge here is, what if, sir, I don't have those tables and I've done already calculating my symmetrical fault current? Is there a rule of thumb, a number to use to multiply, so that I would say that the one I specified, either my, what you call this, either my OCPD is safe or not? Okay? So the answer is, it will depend, no, on the designing engineer. If he will adopt the rule of thumb, but nothing beats being accurate and specific in your design, especially if you are doing value engineering. No, malaki talagang bagay yung pag specify natin ng short circuit current interrupting capacity niya. Kasi as I've said, the higher it is, the more it's expensive. But in most cases, the multiplying factor of 1.25 is safe enough to use. No? Talagang dito lang siya naglaro yung 1.25. So with that, I end up my presentation. Sinsya talaga sa PLDT.
Okay po. Thank you so much po, Engineer John Real Novicio. Actually, we only have request from our participants na kung pwede daw po mabigyan sila nung presentation, access to your presentation. So, yun yung mga messages.
Pwede naman, ma'am. Saan ko ba to pwede i-email? Wala namang problema.
Pwede naman pong makipag-coordinate po yung secretariat with you, sir, para masend din po ito sa mga participant. Thank you so much, Engineer. But before you go, sir, Engineer, of course, we will be awarding a plaque of recognition din po sa inyo. Of course, the IIEE of the Philippines Incorporated, Eastern and Central Visayas Region, latest summer chapter. Plaque of recognition is hereby presented to Engineer John Real P. Novicio in grateful acknowledgement of his invaluable service rendered as technical resource speaker during the 22nd Eastern and Central Visayas Regional Conference, given this 20th day of July, year 2023 at the Summit Hotel, Tacloban City. Thank you so much po, Engineer, sa inyong pag-share po ng inyong knowledge and expertise syempre sa topic na diniscuss natin today. Thank you for taking time.
Thank you po, ma'am. Thank you po sa lahat ng attendees and enjoy the rest of the conference.
Thank you, sir. Okay, so before we proceed to our next speaker, we will be showing you a sponsored technical presentation of the EDMI. Technical. This is virtual, I think. Paki-play po nung... Dito na po ba ang sponsor natin from EDMI? To our secretariat. Wala pa po ba? Ayan, I think wala pa po ang ating sponsor, EDMI. Wala pa po yung ating Anyone from the secretariat or from the technical? Ayun, wala pa. Okay, so since wala pa po sila, our next speaker is actually already here. So let's proceed to our next presentation, which the topic on conceptualization on electrical design for mixed-use high-rise building. So para po sa ating pag-uusapan on this topic, the development of the electrical power system in a multi-story building is long and tedious. However, in this presentation, it is developed in summary form. It includes the review of applicable provisions of codes, laws, and regulations that have jurisdiction over electrical installation. And so, to discuss this, we have here our regional coordinator for Eastern, Central, and Western Visayas region, National PE Mentoring Committee, and 2019 President of IIEE Cebu Chapter. Ladies and gentlemen, a round of applause to Engineer Raulito C. Baldonado Jr., PEE. Hello, sir.
All right. Thank you.
Engineer, pasensya na po. Medyo na-late po tayo ng kaunti.
Yes. Thank you, attorney, for that short introduction. No?
Yes,
And
po.
Anyway, yun, worry ko din yun, yung internet ngayon, no? Kasi,
baka ma-disconnect ka dun po. Parang
oo.
mga 5 to 6 times po na-disconnect kanina si Engineer John Doril.
I hope yung sa akin hindi rin. Anyway, nandito ako sa IAA Cebu Office Chapter. However nga, intermittent yung signal nila. So, that's why I'm using ngayon yung sa cellphone ko. So, I hope walang problema later on. Sige, so Tony, can I share my screen right now?
Yes, please,
Okay.
please do po, Engineer. And proceed po with the, Engineer, you're given an hour. Tapos, I will just i-appraise po kita if 10 minutes na po so that you have 5 minutes to wrap up the discussion and we can answer some of the questions.
Okay, no
po.
worries.
You may proceed now, Engineer. Thank you po.
Yeah, can you see my screen? And can you see my screen?
Yung nakikita po dito is yung background po ng Institute of the Integrated.
Yeah.
Yan na po ba yan? Apo.
Yes.
Okay po. Sige po.
Okay, thank you very much. Once again, good afternoon to all the participants of this 22nd Eastern and Central Visayas Regional Conference. Okay, so hosted by Leyte Samar Chapter. So I'm very happy that I was invited by the organizer, of course, the host, and our regional governor being part of this program as a resource speaker. Yeah, so my presentation would be, as per earlier said by the host, conceptualization on basic electrical design for mixed-use multi-story building. So I am Raulito Castillo Baldonado Jr. and these are my credentials. Yes, so perhaps my topic is quite common, and I know that some of you who are attending this topic right now or seminar right now are expert on this topic, no, multi-story building. And I just want to emphasize that this presentation is devised to just a basic presentation, no? It's because if we will just tackle all the items included in this topic, 1 hour is very short. So that is why I tried to simplify and discuss all the basics. And later on, I will show example also so that it would be nicer for you or mas madali natin maintindihan, no? Just like our college days na sa example ng teacher pa natin maintindihan, during discussion hindi masyado. So ito yung gagawin ko ngayon. So I think yung medium of communication ko is Filipino at saka English, no? As much as possible hindi tayo mag-Bisaya kasi hindi siguro maintindihan ng iba. Okay? So moving on. The objective of this seminar is to give the presentation to develop a power system design for high-rise multi-story building in summary form and concentrate on calculations which can be made by simple methods. Okay, so basic lang yung i-discuss natin. I know some of you here are very expert on this, so just be, you might just relax in there and listen. And to the new pastors, new RAEs, this is much beneficial to you, this topic, no? So that you could understand the basics of how to design. All right? So let us first define what is a multi-story, or shall we say yung sinasabing high-rise building. Okay, pag sinasabing low-rise building, it is up to 4-story. And then if mid-rise building, it is no more than 8-story. And if you would say high-rise building, it is generally 23 meters up to 137 meters. So precisely 9-story to 43rd story building. Okay, so ang dami-dami nito sa Maynila, sa Cebu, no? And the skyscraper is the 44-story and up. So an example is yung sa Burj Khalifa, no? Sa kuan yung mga matatayog at napakataas na building. Yun yung mga tinatawag na skyscraper. So, paano ba natin dinidesign yung ganitong klase na building for the electrical system, no? Yun yung ano natin ngayon. All right. So, the outline of my presentation will discuss on the basics of electrical designing of these buildings. So, ganito yung ano natin, flow natin. Meron tayong introduction, and in part 1, I will discuss what are design considerations. Yes, of course, reference natin yung sa PEC, no? So, then number 2, meron tayong sample calculation, of course, para mas lalo natin maiintindihan. For the residential, mixed use nga yung building natin. So, most likely, nowadays, yung mga ano natin is probably condominium sa taas, then commercial sa lower floor, no? Tsaka may office din yung iba, no? Ang iba nga parang clinic ng mga doctors, right? So, itatakol natin sa sample calculation paano ba natin i-calculate regarding sa residential, and then tapos dito sa commercial, and then dito sa mga administration loads which are common, the main service entrance, the fire pumps, the elevators, the transformers, the generators, right? So, paano natin i-calculate yun, no? Then we will also tackle the basic voltage drop calculation. Okay? Basic lang, no? At least yung principle ay nandun, no? And ang basic short circuit calculation as well. Okay? Introduction. So, in high-rise buildings distinctively differ from industrial buildings for manufacturing with regards to electrical utilization, of course, installed at the number of floors. Okay, the latter are mostly single or story structure. Yung mga industrial, no? Most commonly single or two-story lang. Due to operational requirements and constraints. Whereas the high-rise buildings normally refer to occupancies for general offices, commercial establishments, hotels, condominiums, or any other dwelling units or their combinations. So the division as to number of floors and areas vary from one party to another. The development of the power system of high-rise building is long and tedious. Yes, I have said that earlier. However, in this presentation, I would suggest for a simple steps. Okay, so this is an example of the single line diagram or the power riser diagram of a certain high-rise building, no? So as you would observe, ang gamit dito is from the transformer, no? Sa main source, nandito siya sa lower floor. Yes, parang sa second floor, galing sa transformer, going to the low voltage switchgear. Meron tayong ATS at switchgear, and then nakabasdak yung supply, no? Going to the higher floors. Then as you can observe, dalawang bus duct, no? Yung ano niya, nag-serve every other floor yung connections. Okay? So this is an example of that. All right? So first, we will have to tackle what are the general design considerations. Ano ba yung mga PEC provisions na pwede nating i-apply sa design, ganitong design? Okay, number one, you should begin, no? First of high-rise building, begin basic review on all applicable standards. So ano ba yung mga standard? Right? So first, our Philippine Electrical Code. So what are the provisions applicable on this design? Chapters 1, 2, 3, and 4. And of course, the Article 6.95 of our PEC, which is the fire pump, no? Fire pump system. Okay? So I include this one in order for you to further study on our basic Philippine Electrical Code. Okay, we will also be familiar with our new electrical engineering law, and some provisions applicable on this kind of design are the sections 26, 31, 32, and 34. And of course, another design consideration is from our National Building Code, especially the electrical requirements for high-rise buildings. Yes, hindi lang tayo rely on our Philippine Electrical Code, sa National Building Code din. It's because meron yung mga provisions doon na applicable sa design natin, no? For example, yung parang electrical room, is it saan ba talaga located, no? Meron yun. And to proceed also, another resources, no? Another standard is the distribution service open access rules, or DSOR. It is from the energy ERC, no? Okay, some of the provisions needed are those for the connection point and the service drop. Okay, so yung service entrance natin at saka yung tapping point sa primary natin sa utility, no? So yun yung ano natin, no? Or example sa dito sa Cebu, si Veco, no? Andyan sa Tacloban, I think Leyeco siguro, no? Correct me if I'm wrong. Anyways, after that design consideration, yung mga standard natin, pangalawang procedure to natin is prepare an electrical load estimate based on areas of the building and other pertinent area. Office ba yun? Dwelling units ba yun? So the PEC has also suggested, no, estimated general information illumination load. Some other books also furnish data of other loads. So an estimated load of 0.1 kilowatt, or shall we say 100 watts per square meter of habitable area may be used as a counter-check estimated load. Okay? So parang 100 volt ampere per square meter. Granting na yung power factor mo is unity, no? So anyways, this is just an approximation, no? For example, if you do the meeting with the other trades, the architects, so, or on the owner, at least meron ka ng background, no? For example, sinasabi nila, engineer, yung ano natin is, condominium natin is precisely mga, let's say, 1,000 square meter. Okay, so you by an approximation of 100 VA per square meter, so 100 times 1,000 is most likely 10,000, no? So 100 kVA ata, no? Correct me if I'm wrong, no? So at least meron ka ng approximation, alam mo na kung ano yung transformer, pero hindi ka pa nag-calculation design proper, no? Yung ano pa lang to, parang ano target mo pa lang, no? But later on, you would have that calculation proper, no? This is just an estimation. So after those preparation, you should consult the local utility company, of course. For example, dito sa amin sa Veco, yung design ko is high-rise, I would consult them if ano ba yung primary voltage nila, no? So 23 kV. Kasi kung nag-design ka kaagad tapos without consulting the local utility, so baka pwedeng magkamali ka, 13.2 yung ginawa mo, right? So it is very important to consult the utility. And then one other thing is for their primary setup, primary metering setup, I mean. So at least meron ka na ng mga requirements because some of the utility company are certain load capacity, mayroong requirement. Just like dito sa Cebu, pag 1 MBA na, sinasabi na, okay, in your design, you include you include MBSG. Yon, no? For example, no? You include recloser, ganon. So it is very important to consult local utility company para yung design mo is appropriate talaga. So moving on, anong consideration natin? Pangatlo, determine other design exact electrical rating of all equipment. Okay? So you should check your counter designers, no? For example, yung mechanical designer. So you should check their sizes of their plumbing elevators, the fire pump. So galing sa kanya yung sizing ng mechanical. No? Ang sa atin, tayo na yung mag-design sa electrical aspect of that. Okay, so consideration din natin, determine your location and estimated sizes. Of course, you should determine first saan mo ilagay yung transformer mo, saan mo ilagay yung generator mo. So ideally, yung generator mo is perhaps at least hanggang 3rd floor lang, no? Including the transformer. It's because kung nasa taas na floor na nun, paano mo pag-maintenance nun? If ever you need to pull out the transformer, you need to pull out the generator, no? So at least alam mo na kung ano yung anong floor para at least yung crane mo is up to, let's say, 4th floor lang. So doon ka lang sa 4th floor. But ideally, at least 2nd floor at saka 3rd floor lang, no? I mean, pwede rin sa ground floor. However, during these days, medyo prone na tayo sa baha, no? So mas maigi kung nasa 2nd or 3rd floor na lang yung dalawa. Saka one other thing also is to design it close to each other, no? Kasi kung yung transformer mo is nasa ibang end dito, tapos yung isang transformer sa kabilang end ng building, ang layo nun, ang pag-link nila, meaning to say, hindi economic yung design mo kasi ang layo ng kable or bus bar ba yung bus duct yung gamitin mo. At least kung close sila, the shorter the better, no? For economic reason. Right? So moving on, consideration din yung sa design ng lighting system, no? So I will just not elaborate more on that. So moving on again, so assign circuitry of the lighting and power after you designate the layouts, no? So i-circuiting mo na rin. Okay, then. After nung mga design consideration nun, so you prepare a riser diagram or a single line diagram. So any design, even hindi high-rise building, ito talaga yung pinaka-reference natin, no? After those design consideration, gagawa ka na ng single line diagram as your guide. Then later on, you could size what are the components of that single line diagram. You can calculate the sizes. So ito yung sample ng single line diagram, no? As you can see, ayan. Okay? Sample yan, no? So I will just not elaborate more. Then again, sa design consideration, check and coordinate other trades. Okay. Sa architectural, sa mechanical, the other MEPF, the structural, and the architectural plans, no? Okay. Now, let's proceed. The calculation procedure. After ng design consideration, yun yung mga standard na kailangan natin at saka yung consideration na dapat natin gawin, no? Parang yun yung mga general guidelines. This one is the calculation procedure. Paano ba natin gawin yun, no? So nowadays, condominium, residential, or commercial type high-rise building are the most common. All right? So you should calculate first the residential loads. Kalimitan sa mga ano natin, ang upper floor are the residential, the condominiums, no? The dwelling units. So yun yung iano natin muna, i-calculate first, no? We will calculate first the subservice entrance per floor. So ano ba yung size ng main protection per floor? Ano ba yung main feeder per floor, no? Then calculate for the total connected load for each unit. Of course, let's say we have 10 units per floor, so you're starting for the number of units, then i-total mo yung lahat 10. Then you could have that subservice entrance per floor. Add the loads, okay? Then compute the current base and number of units. Later on, sa sample natin, mas maintindihan nyo, no? Anyway, this one is being emphasized as the procedure. So determine the size of subservice, conduits, protective devices, and others. And then after that, kung i-calculate natin yung main service entrance for the residential loads. So kung let's say yung floor is for the residential is 4th floor to 10th floor. So dito na yon, i-add natin lahat from 4th to 5th. So we will determine its main service entrance. So add the total connected loads of all the units, no, sa residential. Compute the total current base based on PEC table 2.2. By the way, at the end of my presentation, sinama ko rin yung mga PEC tables, no? So as you can observe, nilagyan ko talaga ng page 61. So para better for you, madali na lang, no? Kung titingnan nyo sa Philippine Electrical Code ninyo. Even if you have your Philippine Electrical Code right now, just open this at page 61. Determine the size of the main service entrance. Okay. After those, no? Then, after ng residential loads natin, we'll go to the commercial loads. Basically, the process of competition is just similar to the residential loads. If magka-different lang sila, is due to the power factor, sa demand factor, okay? Then, calculations na din anong admin loads. So, admin loads, common loads, tinatawag nga, for example, yung fire pump, okay? Yung hallway lightings, yes, ayun. Elevators. So, in this presentation, sample din natin, paano ba mag-calculate ng branch circuit ng elevators. Yung feeders niya, okay? Overcurrent protection pa rin sa elevator. Then sa fire pump, ganun din. Meron tayong example. Overcurrent protection. Ano din yung mga PEC natin na requirement. Okay. So, yun yung sa fire pump, right? So, I will just emphasize while the disconnect for the pump size with the lock rotor current of its motor, this is pertaining to the fire pump. Please do note that PEC 2017 has a major changes adding requirements in sizing the protection aside from lock rotor. Okay. As per PEC, if you have your PEC right now, open it to validate this one. No? So dati sa PEC 2019 natin, ang sinasabi lang to size the protection of the fire pump or the disconnect of the fire pump, ang sinasabi doon is lock rotor current lang yung consideration. But in 2017 PEC, additional na, no? Ito, an example, no? So within 2 minutes at 600% of the full load current, the fire pump shall not open. No, hindi siya mag-trip. And of course, in the restart tangent of 24 times, sa full load current ng pump, hindi din siya mag-open. And within 10 minutes at 300 of the full load, hindi din siya mag-open. Okay? So, this is being added on our code in order to secure that the fire pump should always be running, no? Na yung disconnect breaker niya or protection or disconnect niya is always running no matter what, no? Right. So, allow me to move on. Okay, the current kilovolt ampere times power rating horsepower fire pump is divided by square root of 3. Okay, yun yung mga formula, no? For the lock rotor of fire pump. And then, very important, overload protection. Ano bang sabi doon? The power circuit shall not be provided with automatic protection against overload. So, the fire pump system ay hindi kinakailangan ng overload relay or overload protections. Okay, so other motors shall be considered as ordinary motors. Moving on, after na ma-determine natin yung mga branch circuit, sizing, at saka feeder lines, protection, kable ng mga admin loads like elevators, generators, fire pumps, and etc. Calculate din natin ng admin loads, no? Okay, so iba yung calculation ni residential, iba din si commercial, at iba din si admin loads. Then after that, we will sum up everything. And after that, we will have the computation for the voltage drop. And sabi ng ating PEC is 5% voltage drop from the source up to the limitation load. So the source means our transformer. Okay? So from our transformer bus, no? Yung terminal na lugs ng transformer galing doon up to the last farthest load is allowed only for a 5% maximum. Okay, we will also have a sample calculation for short circuit. Right? So for the generator or the standby generator, usually standby lang yung ginagamit sa mga ano natin, no? High-rise building. So perhaps I will not elaborate more. It's because maliit nga yung oras natin. However, ito yung pinaka-general formula in sizing a generator, right? So KVA ng generator is starting of the largest motor load of the entire building plus the KVA running of the remaining loads. Okay, so just take note of this formula. It's because some of our designers are even have a misconception on this, right? So ang iba, pag naka-design na sila na yung transformer size is, for example, tatlong 100 banking transformer, so 300 kVA. Automatic, sinisize din nila yung generator as 300 kVA. No, that is not the case. You should have a better calculation by this formula, no? So starting kVA ng largest motor load mo of the entire building. For example, ng high-rise natin, yung pinakamalaki is usually, by the way, hindi kasama yung ano dito ha, yung fire pump ha. Kasi yung fire pump is not running normally on ano natin. However, if you have the size of your generator, mayroon ka ding lock rotor yung consider mo, at saka i-check mo rin kung kaya ba nung generator, no? At full load. So unfortunately, hindi yan kasali sa ano natin ngayon, no? So moving back again, so the KVA is just of the generator is the starting KVA of the highest motor load of your building plus the running KVA of your remaining loads. Okay? Then the lightning protection system. Yes, the conventional one. Okay, so computing number of air terminals, determining materials based on height as per, okay, I indicate also the peak provisions, no, at 2.9.3.4. However, hindi din saklaw natin itong lightning protection, no. I just indicate the include, no, the peak provision for you to additional reading, right? Due to time constraints, we cannot do this, no. Anyways, allow me to again the conventional is using the air terminal. The enhanced is yung mga dynasphere, no, for example. Then after that, the last procedure, prepare all necessary documents. With all the above plans, single lines, specification, and documents can be prepared, no. Okay. So that was the end of part 1. It is more on design consideration and calculation procedure. Now we go to the calculation proper, right? So sample calculation based in our PEC 2017. So take note on the sample. This is a multi-story mixed-use building, a 34-story residential commercial condominium building. Yes, with a typical residential units from 4th floor to 34th floor. Each floor has a 16 residential units, okay? Each unit has a total connected load of 7,515 volt ampere, 230 volts single phase, line to neutral, which is supplied by a service transformer 1,500 kVA or 1.5 MVA, 23 kV, 400Y, 240 volts, three-phase, four-wire Y, grounded with percent impedance of the transformer 6%. Okay? So calculate the main service. So yun yung assignment natin, no? Calculate the main service entrance of the entire building, the subservice entrance per residential, commercial, and the common loads, then the main service protective device, and of course, voltage drop and short circuit calculation with basic calculation only. Okay? So, as you can see, yung building natin is here in Cebu. It's because 23 kV, right? So, perhaps if you would imagine nyo na lang na 13.2 if dyan yan sa Tacloban, no? So, the power system is tinatawag na four-wire pass ground. So, the neutral is current carrying. So, the single-phase loads are line to neutral, while the three-phase loads are line to line, 400 volts. Then, the single-phase line to neutral is 230 volts. Okay? This is his single line diagram. Okay, so galing dun sa transformer, may dalawang bus duct, right? So, I mean, it is not bus duct, but it can be a cable or a bus duct, right? So, dalawang ano natin is supplying the, yes, the residential, no? And the admin loads is iba din, no? Then the commercial. Okay? So, take note of that. If you could have a screenshot para ano, this one, para madali nyo lang i-track, no? Kasi, unfortunately, guys, some of the, hindi ko na link, no? Yung ibang slides na nasa lower part, I mean sa later part. So, just have a screenshot. Okay, screenshot. 1, 2, 3, go. Okay, thank you. So, ano ba yung gagawin natin? So, first, we will calculate and we will focus on the residential side, no? So, sa residential side, ang sub-service per floor and protection niya, and then moving up to the main service ng residential, then the commercial. So, earlier also, I also said, no, the procedure. Then we will size the fire pump sample for the admin loads, elevator, generators, and transformer. Okay. Now we will start on the residential part. So the subservice, ang sabi doon kanina, 7,515 volt ampere per unit at saka 16 units per floor. Okay. So yun. The 0.39 is a demand factor. I'm very sorry. Yun nga. Some are hindi na link. Tingnan ko nga. Okay. Very good. Na link. So in this case, na link natin, no? Yung 0.39 is derived from, okay, optional calculation demand factors for 3 or more multifamily dwelling units. So 16 units, yan, 39%. So you can do that, okay? You can do that. Okay, but this is the minimum, no? Yung sinasabi ng PEC is minimum. So hindi ka na pwedeng bababa doon. Right? So moving again, okay. The phase, the current, line current per floor, per service, no? Yung calculation natin is only 67.69 amperes, right? Every floor. Then the floor is typical from 4th floor to 40th floor, I think. All right? Then from that, meron na tayong kuryente, kukunin na natin size ng phase conductor. So si phase conductor, yes, na-link ko rin. 67.9, so yung sinasabi ng PEC. By the way, a very good suggestion or recommendation. Okay, sorry. So as you can see, 67.69 use 322 mm squared copper TW 70 amperes. Okay, TW 70 amperes is the ampacity from here. 22, 70, 60 amperes TW. Okay. You might think na yung ginamit mong wire is THW, right? THW, which is 75 degrees C. So yung ampacity niya is 85. Or even you're using a THHN wire, 90 degrees C, his ampacity is 95. So some of our designers are being misled on this, no? So they might size also their breaker to 100 amperes. It's because they're using THHN, malapit lang, 95 at saka 100. Now, I share to you guys, if you're using this table, no, if our cable sizing is 100 amperes and below or 38 mm squared and below, dito po tayo mag-refer only to 60 degrees C as our ampacity, even you are using a THHN type of wire. Okay, even you're using 22 mm THHN, yung treatment mo as its ampacity is only 70. Okay? And again, likewise, if you use THW, which is 85, yung treatment mo din is only 70 amperes ampacity yung max niya. Nandun sa ating Philippine Electrical Code din, Article 1.2 somewhere, yung thermal consideration, no? So it is your assignment, but I say to you that ito yung pinakaano natin. Now, in 100 amperes or 50 amperes and above, dito na tayo sa 75 degrees C. Okay? So, even if, for example, dito tayo sa 100 mm to 20, so ang treatment natin, even if you're using a THHN, supposedly 240 ampacity, ang treatment natin is just 220. Dalawa lang yung reference natin, no? If we are to select. Yung 90 degrees C is an added ano natin sa kable, no? Ang iinit pa, so at least he can handle, no? It's because our manufacture of breakers and other equipments are based on this. 100 ampere breakers and fuse are only designed on 60 degrees C contact. And 100 amperes and above, ito sa 75 degrees C contact. Okay, this is the common. Unless if your breaker has listed as 90 degrees C, you can have this ampacity. But to be safe, and my personal recommendation is just use this two column, 100 amperes and below, 60 degrees C, 100 amperes and above, 75 degrees C. Okay, all right. Okay, I hope you understand. I hope that is an additional knowledge. Okay, sizing of the neutral is from PEX 2.2 and 3 at page 59. I just leave this to you as your further reading, no, guys? Ito yung mga reference natin. So, yung kable natin for the isang floor, for example, sa fourth floor is 22 mm. Yung neutral natin is 22 mm din, no? Kasi sabi doon sa PEC natin, for load less than or equal to 100 amperes, allow tayong mag 70%, no, ampacity ng main conductor. Okay? However, it is a good recommendation, gawin mo ng 100%, no? If you're using the phase current 22, so it might mas maganda na 100%, 22 na rin yung neutral mo. However, if hindi talaga pwede mong ma-attain or nabili na yung wire, recommended, allow din yun sa PEC natin 70% lang. If your amperes na kinikonsider na current is only 200 amperes and below. Okay? So other than that, more than 200, it is 100 amperes. And even nga sa ibang mga designer at saka sa design ko rin, if mostly yung mga harmonics prone na mga loads, ginagawa ko ng 150% yung neutral. Oh, or 200% somehow. Okay, but a good practice is to make it 100%, the same size with the phase current or the line cables or the phase cables. Anyway, so the sizing of the grounding conductor, I will just leave you also to our PEC, no? Nakalagay din table, page number 124. So ang 70 amperes is kailangang EGC, equivalent conductor of 8.0. Okay? Anyways, ibibigay ko naman tong presentation. So naka-attach dito lahat ng table, no? All right. Then size of the conduit, ayun, I will just also leave it to you from table C9, naka-attach din dito. So sa residential per floor, meron tayong 70 amperes main, 22 breaker squared, at saka ang 1 1/4 yung REC cable natin, I mean conduit natin. Yes, right? So after that, we will have the subservice protection, meaning lahat na ng residential from 40th floor to, I mean 4th floor to 40th floor, I think. Right? So, ganun lang din yung procedure. I will just leave it to you guys. Anyway, I will give you the, okay, I just elaborate this one. So, per unit, 7,515, 16 units per floor, and 30 floors. 30 floor is because it is from 4th floor to 44th floor. So, number of floors yun lahat. Then the 0.23 demand factor is again came from the table kanina sinasabi ko. All right. Okay, so 23, 62 and over 23%. All right? So pwede mong gawin 'yon, no, as the minimum. However, it is the common common sense ng designer if he will do that. But kalimitan, even in my design, around 40 or 50% lang yung inaano ko talaga. No? So, sorry. So, yung sa residential na calculation ng current natin is 1,197.54. So, take note on that. So, meaning to say, yung phase bus natin is sufficient to handle that one. So, yung pinaka-nearest is 1,250. Alright? So, ito yung sabi ng PEC. However, a good recommendation also is to allow your bus bar to load only 80% of your demand load, which is the 1,197. Yes. So, at least, no? But anyways, you can also size 1,250 amperes as minimum. So the neutral current again, sabi ko kanina, the 200 yung ano natin, you can have 70 amperes derating, I mean sizing of the neutral for 200 amperes and below. That's why nag-minus siya, no, nung 200. Okay? I just include this one for you as your reference, no? If ever hindi talaga pwedeng ma-meet yung 100%, no? At least for me, recommendation ko talaga is at least 100%. Kung ano yung size ng cable mo, ng line, phase mo, or saka yung line bus duct mo, line 1, line 2, line 3, yung neutral mo is recommended to be 100%. However, I just include this para meron talaga kayong, if you are on the economic aspect, no? Okay? Okay, I just leave it to you guys. That's 20%. Basahin niyo sa PEC natin at page 59. Malayo pa to, ano pa natin. So, by doing that, pwede natin gawing 100 amperes neutral bus. Okay? So, yung main ano natin, bus bar is 1,250. Our neutral is 1,000 neutral bus. However, for me, personally, gawin ko na rin 1,250 yung neutral. Alright? Okay, I hope you got it. Then, the sizing equipment bus, okay, andun na rin sa PEC natin as per PEC. Ito nga, just refer to 124, AGC, 250 ang grounding bus. But some of the grounding bus, some of the bus duct system, yung casing ng bus duct is listed as grounded, as approved grounding na, no? Some of them. So, at least if ano yan, economic. However, kunin nyo talaga yung certification ng BASDAQ supplier na listed as equipment grounding yung casing. Okay? Now, rating ng BASDAQ, yun nga, sinabi ko na kanina, no? So, as minimum, 1 to 50, yung neutral, 1,000, equipment grounding to 50. However, kung ako, saka recommendation ko, 1 to 50 na lang lahat ng bus bar, including the neutral, except the equipment grounding buses to 50. So, the main service protection, 1 to 50. So, yun yung ano natin, minimum din natin, 1,250 amperes, no? 3-pole plus neutral. Okay? However, a good recommendation again is just to limit your demand load 80% of your equipment, no? You can size also this one to 1,500 or 1,600. But for the sake of calculation, ito yung sabi because we are basing on the PEC minimum requirement. All right?
Engineer?
Yes, ma'am.
Last 10 minutes po.
Okay. Ang haba pa. Anyway, sige. I'll just expedite this one. So, voltage drop calculation, ganito din, yo. So, from 4th floor. So, okay, we'll just have an example. Ito yung 4th floor going to the farthest load. All right? Then, ito yung pag-calculate, yung basic lang, ha, ng voltage drop. Okay, so main service 19, sub-service 67. Yung bus duct length natin is 40 meters. Okay, so ayan. So this resistance at 40 meters, then reactance at 40 meters. Okay. Yung 0.00439 ohms resistance yan ng bus duct, no? Galing yan sa supplier, binigay sa atin. Busway system, sila yung nagbigay. No? Okay, so you can calculate your resistance at 40 meters. Yun yung farthest load natin, no? Right? So, given the formula, you'll just okay? So, yung total voltage drop is 4.14 volts from 4th floor going to the farthest load. Galing ng transformer. Okay? So si subservice, anyways, don't worry if na-expedite natin. However, meron kayong kopya, no? As a sort of your reference in the future. Okay? Ganon din yung 0.31 is galing sa PEC natin. Ito yung sa kable. Kanina is sa bus duct yun galing from the transformer going to the 4th floor, which is the location of, the 40th floor. Yung pinakamalayo na floor. No? Yung voltage drop na kinuha natin is the farthest load, no? Yung 40th floor na residence. Okay? So galing doon sa bus duct niya is 40 meters from the transformer. Meron din tayong kable. Ito yung kable, no? 22 mm. Ito yung corresponding resistance and reactance ng 22 mm. Okay? I will just leave it to you for your reading and study, no? Okay, so voltage drop 2 is 0.06964. All in all, i-add natin, karoon siya ng voltage drop, yung 4.2. Voltage drop ng bus duct galing from the transformer, which is 4.1. And voltage drop ng cable going to the farthest load sa unit is 0.06. So all in all, 4.2. So kinuha natin yung percentage voltage drop is only 1.051. Pass yun. Yung requirement natin sa code is 5% maximum. Okay, sample short circuit calculation. Ito yung mga short circuit formulas using per unit method. Right? I will not dwell on this. Okay. So, some short circuit calculation lang. Yung sample natin is for the infinite bus of the transformer. Okay, for example, no, yung yung ano natin sa transformer, yung terminal logs ng transformers sa secondary, which is 400 volts. Okay? So, meron tayong utility, meron tayong transformer, saka meron tayong kable. So, yung equivalent impedance is from utility at saka na transformer. For simplicity, nineglect natin yung resistance ng primary cable para reactance na lang. But in reality, meron yang resistance, no? However, it's very, very small. That could not, in low voltage calculation, hindi siya masyadong malaking effect. So we can neglect, no, the impedance of the primary cable resistance. Okay, so yung 170 MVA is given po ng utility company. Galing dito sa BECO, yun yung short circuit fault duty nung saan po kami ang design magtatap na feeder. Okay? So ito yung formula. So add natin si transformer is 6%, divide 100, J.06 at ito yung MVA base. At ito na yung okay. Ito yung XTH natin, no? Equivalent equivalent impedance or reactance in this case kasi neglect natin si resistance. So ang 1.5 is coming from our choosing values, which is the transformer. And earlier I said the 170 MVA is from the utility. Okay, so after having that, Ohm's law, kukunin natin yung current base, which is yung base natin in the transformer and the base voltage. Meron tayong full load ng transfer 2,165, yung 500 kVA, 1,500. Okay, the available actual short circuit, multiply natin yung ano natin. Ito yung voltage PO, 1.0 PO, yung per unit voltage is always 1. Mayroon itong derivation, however, hindi natin na-include. Pero it is always 1.0. For some calculation, it is almost approximate to 1.0, 0.999998. However, pwede na natin gawing 1.0. And then ito yung per unit equivalent total impedance or reactance on that fault point. Yung na-solve natin kanina. So overall, meron tayo sa transformer alone, meron tayong 31,460.76 amperes, or shall we say 31.46 kA. So yung protection na i-design natin dyan, ilagay natin is can handle that, no? So in this case, minimum if 36 kA na mga breakers for the low voltage, no? But this is the infinite bus. If meron pa tayong service entrance cable, most likely or naturally, bababa pa to, no? Okay? So, and also a note, final sizing of calculating of the protection is considering also the asymmetrical value. Okay? Pero sa low voltage, parang hindi masyadong ano na to. Anyway, separate na yon, no? At in this case, for the simplicity, what I'm trying to emphasize, if you have calculated 31,000, your breaker shall be more than that. Nearest or more than that. Right? Okay? For commercial, calculations are almost the same. So, hindi na lang natin i-tackle yun, no? So, let's go to the fire pump. Sample lang ito. Nasabi na natin kanina. Allow me to expedite my presentation. The fire pump is 50 horsepower, 83 amperes. So pag size nung kable ng fire pump is just 125% of its full load rating, which is 103. So we can use the 3 by 38 mm squared. Looking back to the table kanina, no? Kanina, no? Okay, ayan. Okay. So, yun lang yung sa fire pump. But ito yung emphasize natin, overprotective devices niya. is lock rotor. Right? With the code letter F from the example kanina, code letter F. Okay. We will have the code letter F. Sabi dito, 5.0 to 5.9 lock rotor kilovolt ampere. So kunin natin ng lock rotor current by doing Ohm's law. So 50 horsepower times 5.59 kVA per horsepower. Then yung voltage ng fire pump. So we'll have 403.43 amperes. This is the lock rotor of the fire pump. The full voltage starting. Okay? So dyan i-refer natin yung disconnect. 450 amperes. So as you can see, yung kable natin is only 38 mm while our breaker is 450 amperes. Malaking discrepancy, right? But we make sure because the lock rotor is the reference of sizing the fire pump. It's because kailangan talaga mag-andar ni fire pump no matter what. Hindi talaga mag-trip si breaker or si disconnect. Okay? So, walang overload protection requirement ng fire pump. Okay? So, kahit yung mga additional na requirements, kahit nakasize ka na nung 450 amperes rating ng disconnect, yung additional ng peak 2017 is kasali pa rin yun. Okay? Later on, I will just show also an example of that if mayroon pa tayong oras. Okay? So now, elevator. I will just elaborate more. Pareho lang yung sizing ng elevator ng kable, 125%. Now, our elevator, for example, here is 4 na elevator, no? Yung tig-isang elevator is 51 amperes, 30 horsepower, 3-phase. Tsaka yung controllers niya, auxiliary, yung mga on-off LED lights, comprise na lahat yon, every unit of 10 amperes. So branch circuit pa lang, size natin yung branch circuit, meaning protecting the single elevator. Ano ba yung branch circuit? Kable yon, right? 120. The motor, ang sabi sa motor is 125%. But in the elevator, ang sabi ng PEC is not on 125 na, kung hindi 140%. Okay? To see is to believe, tingnan nyo sa page 349. Pag size up ng branch circuit is 140% ng 51 times 140%. Then yung auxiliary load mo, comprised of 10 amperes, yun yan yung 125%. But si motor ng elevator is 140. Okay? So by that, nagkaroon tayo ng 71.4 plus 12.5. So we have a total of 83. Ito na yung size ng branch circuit natin. 30 mm. Refer to your table. 83 is 30 mm. Okay? So doon tayo sa 60 degree C column, no? As earlier I said. Okay, size of conduit. Protective device, ganun din, 250% ng motor, no? The only difference of a common motor and the elevator motor is the sizing no branch circuit, no? 140%. It's because intermittent yun, no? Hindi 125. But the protection, the breaker is 250%. Okay, so to wrap up, ang ano natin sa isang elevator is 150 amperes, 3-phase, 400 volts, at saka yung cabling na is, ano ba yun kanina? 38. Okay. Okay. That is for the single elevator. Now, for the 4 elevators, ganun din yung proseso. 140% yung feeder circuit. While, because the 140% is the duty cycle continuous. To see is to believe. Tingnan nyo yung PEC ninyo, no? At page 600. Okay, demand factor pala, sorry. May demand factor if you have 4 elevators, yung demand factor is 85%. Don't worry because I'll give this presentation to you as your future reference. Okay, size ng conductor, as yung 4 na elevator, is ang size niya ng conductor is 175 mm, 80 mm conduit, then yung protection is 350 amperes. Right? Okay. Bakit nagkaganito? Okay. Attorney, ano ko na lang, isang ano lang, very important, allow me to extend my ano ng konti. It's because I want to emphasize the BASDAQ, no? Common ano ng BASDAQ natin. Okay. Allow me to a short ano lang. Okay, where is that? Where is that? Where is that? Very important. Okay, ito yung hindi. Oops. 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 Saan ba yun? Single line diagram. Okay. Okay. Okay, saan ba yun, ha? I think this one. This one. Walang ibang single line diagram. Ito ata. Alright. Ito yun. Okay. Ayan. I just want to emphasize this one, no? Yung sabi ko kanina, BASDAQ, no? BASDAQ. Okay. Meron tayong recommendation ng BASDAQ, no? Yung BASDAQ natin is coming from the ground floor all the way to 4th floor. Usually, yung BASDAQ is straight lang, no? Yung phase A, naka-straight. Phase B, naka-straight. Phase C is straight, no? So as you can see, the flow of current is going upward, right? So, ang haba, for example, skyscraper ka na, abot ka ng 100 floor. So what is the effect if the BASDAQ is like that lang, no? Walang ano. So the inductance of unsymmetrical line causes voltage drop even if the voltage is in balanced condition. Because of the inducing voltage, the magnetic field exists in the conductor, which causes the interference in the line. This can be reduced continually exchanging the position of conductor, which can be done by transposition. Okay, by this illustration, kita natin the phase bay current. Of course, mayroong flux yan, no? Mayroong field, magnetic field na ma-produce. So, ang gitna, si phase B would interact on the right, which is the phase C. And likewise, he will also interact with the phase A. What will happen? Hindi na balance yung impedance. That is why, ang mangyari niyan, hindi din maging balance yung voltage mo per phase. Okay? Especially kung ang layo-layo na, no? Kable, no? Or ng BASDAQ. So, there's two things that we can do on this. If your BASDAQ is in triangular manner, equilateral yung ano niya, kasi linear yung common eh. Kung naka-triangle yung tatlo, ay ayan, okay yun. Kahit all the way, riser, naka-triangle, okay yun, no? But in most cases, yung tatlo is naka-vertical, ano lang, no? With each other, di ba? So, yun yung mga ano natin. You might wonder bakit hindi balance yung voltahe. So, another good ano nito is kasi kung i-triangular natin posisyon, no? Maging mahal ang BASDAQ kasi malaki na yung kaha, di ba? So, isang ano natin dito is what we call the transposition of the conductor. So, ito yung gagawin natin, no? So, this one, lagyan natin yung BASDAQ dito, lagyan natin ng braided, no? Flexible braided BASDAQ, yung connection. Transpose natin yung phase A natin dito, nasa gitna na, no? Transposition in order to eliminate that magnetic field, no? So, a good recommendation in this is if you have a 100 feet or 30 meters BASDAQ, every 30 meters, transpose natin. Transpose natin. Right? Okay. I hope you got that, no? I'm sorry. 1,000 feet or 305 meters. So, 60th floor. All right? So, seldom naman talaga dito sa atin. But, however, if mga 50 meters, yan na natin, transpose. Okay, so in summary, BASDAQ system for high-rise building, BASDAQ system, compact design, requires lesser space, most economical when load is above 1,000 amperes, no? 1,000 amperes, mas economical sa bus duct system. Additional feeder is quite attainable by introducing a top-off circuit breaker. Okay, madali lang, no? If meron tayong mga additional loads, no? Kasi top-off lang. And in terms of voltage drop, lesser din yung voltage drop niya. It's because mas mataas yung ano niya, resistance, no, impedance. While the cable system needs larger space, mounting installation, especially riser, but generally economical if 1,000 amperes and below yung ano natin, system. And also very easy to maintain and replace, no? If masisira yon, bali isang kable lang, no? A portion lang pwede mong anuhin. While the bus duct, ang laking ano nun. Tapos yung gagawa, ano pa, specialty pa. But insulation is poor compared to bus duct over the years wear and tear. Okay? Right. So, allow me to share to you word from Bill Cosby. In order to succeed in life, your desire for success should be greater than your fear of failure. We agree that to be the end of this presentation. And thank you for your listening, ladies and gentlemen. Thank you.
Thank you so much, Engineer Raulito C. Baldonado Jr. Of course, allow us to award to you a plaque of recognition. IIEE, Eastern and Central Visayas Region Latest Summer Chapter plaque of recognition is hereby presented to Engineer Raulito C. Baldonado Jr. in grateful acknowledgement of his invaluable service rendered as technical resource speaker during the 22nd Eastern and Central Visayas Regional Conference, given this 20th day of July, year 2023 at Summit Hotel, Tacloban City. So thank you po. Maraming salamat po,
Yes.
Engineer June Baldonado, for sharing your expertise on this.
Yes, thank you very much. Thank you very much. It's my pleasure to be your resource speaker this day. Thank you very much.
Okay, so let's proceed to our next speaker, especially that we're already out of the schedule na po. So
Okay,
our next
Attorney.
topic is a topic on optimal mix of renewable energy for sustainable grid. So to present this, ladies and gentlemen, a round of applause to Engineer Adrian L. Ray. Engineer. Andito na po si Engineer Ray. Ayan.
Hello, ma'am. Good afternoon.
Hello, Engineer. Yes po. So you have 1 hour po, Engineer, to present your topic. 10 minutes po from that 1 hour po, I will have to heads you up po to wrap up so we can answer questions po to give you a time to wrap up your discussion. Thank you. You may proceed now.
Okay, ma'am. Can you see my slide, ma'am?
Yes, you can see it already po.
Okay, ma'am.
Please go
Thank you. So, good afternoon, everyone. My topic for this afternoon is about optimal mix of renewable energy for a sustainable grid. So, alam naman natin na renewable energy is very popular right now. Halos lahat tayo parang gusto natin maglagay ng solar panel sa bubong ng ating bahay just to be eco-friendly to use this technology. But for my presentation this afternoon, I would like to give emphasis on the importance of the optimal mix for this renewable energy. Siguro for some, this is a new topic or siguro bago nyo lang na-encounter yung discussion of optimal mix. Let me give you some basic information about this optimal mix for renewable energy systems. Okay. So let me start my presentation with this Department of Energy Circular number 2017-12-0015. For some, this is alam niyo na ito. So this is the renewable portfolio standard natin, no? So this department circular is promulgating the rules and guidelines governing the establishment of the renewable portfolio standards for on-grid areas. Kapag sinabi nating on-grid areas, these are areas connected to the National Grid Corporation of the Philippines. So sa Philippines, meron tayong main grid, which is line of the LSP. So if you are an electric cooperative, a distribution utility, consumer na connected or getting power with the use of the NGCP, you can be considered as an on-grid customer. Now, we also have another circular, 2018-08-0024. It's the same rules and guidelines, but this is for off-grid areas. So, merong circular for on-grid and for off-grid. So, for the information of everyone, so magkaiba talaga yung ating guidelines for on-grid and off-grid areas. Mamaya, i-discuss naman natin ano yung difference. Now, let me just recap, no? According to the Republic Act 7638 or the Department of Energy Act of 1992, the state, our government, must ensure a continuous, adequate, and economic supply of energy through the integration and intensive exploration, production, management, and development of the country's indigenous energy resources. So, malinaw naman dito na yung ating government, ating state, kailangan niya yung paggamit ng indigenous energy resources, which is the renewable energy. And according to the Public Act number 9136 or IPIRA, so sabi dito, the state, the clear policy of the state to, among others, assure socially and environmentally compatible energy sources and infrastructure, promote the utilization of indigenous and new and renewable energy resources in power generation in order to reduce dependence on imported energy. So simple lang naman yung gusto nating sabihin dito na nasa batas na natin yung paggamit ng renewable energy. So dagdagan pa natin, according to Republic Act number 9513, the Renewable Act of 2008, which is the policy of the state to increase the utilization of renewable energy by institutionalizing the development of national and local capabilities in the use of RE systems and promoting their efficient and cost-effective commercial application by providing fiscal and non-fiscal incentives. So napakarami na nating binanggit na batas and pareho naman yung gusto nilang mangyari, di ba? To develop renewable energy projects, to encourage yung ating paggamit ng renewable energy systems. Now, may problema tayo. Of course, with the use of renewable energy, hindi naman natin sabi na perfect yung system and madali nating may implement ito. So the problem is, with all the laws, with all the Republic Act na binanggit ko kanina, the share of the renewable energy in the national power generation mix was 34% at the time of the passage of the RE Act. So we started at 34%. But the subsequent increase in electricity demand after 2011, so ilang years after the RE Act, and the construction of more fossil fuel plants for base load requirements of the country, decreased the share of RE in the national power generation mix approximately to 24% na lang. So dami ng batas natin encouraging the use of renewable energy. Bakit kaya naging from 34, naging 24% pa yung ating RE? Diba? So sabi nga dito, nag-increase tayo ng demand and nagkaroon tayo ng construction ng additional fossil fuel plants. So yung increase in demand, hindi na-support yung increase ng renewable energy systems natin. So mas madali kasi mag-construct ng mga fossil fuel plants, di ba? So yung nagiging effect nito is bumababa yung share ng renewable energy natin from 34% to 24%. Now we have a possible solution. According to Section 4, Rule number 2, Part 2 of the Implementing Rules and Regulations of the RE Act, provides that the Renewable Portfolio Standard, ito yung binabanggit natin kanina, na from the Department of Energy, the Renewable Portfolio Standard as a policy mechanism shall oblige electric power industry participants such as generation companies, distribution utilities, including electric cooperatives and suppliers of electricity, to source or produce a fraction of their electricity requirements from eligible RE resources. So ito, malinaw naman dito, generation company, distribution utilities, and suppliers, kailangan fraction of their electricity requirement must be sourced from an eligible renewable energy. In that way, masisigurado natin yung compliance natin doon sa pagtaas ng ating renewable energy mix sa grid. So, according to the Department of Energy Circular Number DC 2017-12-0015, this is only applicable for on-grid na. So, please take note that this is only for all on-grid system. The minimum annual RPS requirement, the RE share of electricity coming from RE resources in the energy mix, shall be based on the aspiration target of 35% in the generation mix expressed in megawatt hour by 2030. So, dapat target daw natin by 2030, maka 35% tayo ng generation mix ng RE. Meaning to say, dapat yung ating production, 35% nun is renewable energy. Could be solar, could be wind, hydro, or any other renewable energy resources. So 35%. In addition, the minimum annual increment, so merong increment dito, required under this rule shall be set at 1% to be applied to the net electricity sales of the mandated participant. Meaning to say, dapat merong 1% increase in the renewable energy mix annually. So, ibig sabihin, if for this year, meron kang 5%, the following year, you must have a 6% RE mix. So para kapag nag-i-increase yung demand, nakakasabay pa din yung increase ng RE mix natin. No? So according to these guidelines, so 1% dapat. Now, merong latest nung 2022 lang, prescribing the adjustment annual percentage increment to be imposed on all mandated participants of renewable portfolio standards for on-grid areas. So nagkaroon ng adjustment. So binabanggit naman kanina sa mga circulars na the Department of Energy can adjust, can review and adjust yung percentage na ito. So noong 2022, last year, from 1%, ginawa nilang 2.52% starting this year. Kasi kung we follow only 1%, hindi natin ma-attain yung 35% by 2030. And yung 50% by 2040. So they increase it to 2.52% starting this year. So yun yung kailangang i-comply ng ating mga on-grid. Could be either power plant, distribution utilities, or other suppliers. So ito yun, no? So as you can see, yung KM dyan, that's the increment, annual increment. So 1% siya, 2020, 2021, naging 2 kasi may 1% increase. But 2023, so 5.52 from 3% kasi 2.52% na dapat yung magiging increase. So if you follow this increment, So sabi nga kanina, 2030, the share must be at least 30%. Dito 32.62. And by 2040, 51.48. Okay. So, yun yung target natin sa Philippines. Ito yung tina-target natin. And tayo mga electrical practitioners, in a way, could be directly or indirectly, may involvement tayo dito, may nagiging participation tayo dito. If you are working in a power company, in a distribution utility, you are the planning engineers, so meron tayong nagiging participation dito. Now we discuss the off-grid. So I know for Eastern and Central Visayas, we have on-grid areas. We also have off-grid areas. Especially dito ata sa summer area, we have still areas na wala pang mga kuryente or mga nasa islands. So those are considered as off-grid areas. For off-grid area, the provision is all mandated participants shall contribute to the attainment of an optimal supply mix in their respective off-grid and missionary areas. The difference now is for an on-grid area, if you can still recall, merong nakalagay na percentage. Diba? May percentage kaninang binabanggit. 35% by 2030, 50% by 2040. May annual increment of 1% before, then naging 2.52. But for off-grid area, ang ginamit lang na term is optimal supply mix. Diba? To attain the optimal supply mix in the respective off-grid and missionary area. Okay, so ipapart lang muna natin yun. Okay. So ngayon, what are the eligible RE facilities? Ano ba yung pwede natin i-consider as an RE facility na magpo-comply doon sa mga requirement na yun? So this is for on-grid. For off-grid, it's same. Biomass, waste-to-energy technology, wind energy, solar, run-of-river, hydroelectric power systems, impounding, hydroelectric power systems, ocean, hybrid systems. So these are systems with renewable energy and a combination of conventional, say, diesel power plant, geothermal, and other RE technologies that may be later identified by the Department of Energy. We need to say anything na related to renewable energy can be used to comply with this regulation. Now, let's proceed with the main focus of our discussion. So doon naman dinidiscuss lang natin ano ba yung mga references natin, saan ba tayo nanggagaling, no? Ano ba yung importance ng discussion? It's very important na electrical practitioners, we are also aware ng mga regulations na yon para naman guided tayo dun sa mga gagawin natin, no? Decision making, mga gagawin nating projects, no? If we are part of a planning or part tayo ng isang our company. Okay? So let's proceed with the definition of an optimization. So sabi dito, according to the dictionary, optimization is the action of making the best and most effective use of a situation or resource. Lagi kong sinasabi pagka may presentation ako, before we are thinking na pagka may renewable energy tayo, may solar tayo na project, or meron tayong wind or hydro project, no, sa isang area. So talagang talagang we are very proud kasi may naging contribution tayo pagdating doon sa pag-save ng ating environment. But of course, di ba, kung meron tayong gagawing isang project, kung gusto natin, ma-optimize natin ito. Gusto natin maging best or most effective yung paggamit natin ng resource. So for example, we have project for solar energy. Of course, gusto natin yung pinaka-best yung result na makukuha natin from this solar project. Diba? So, first, iba yung magiging result, depende dun sa magiging implementation or sa magiging planning na gagawin ninyo. So, isa sa mga pinaka-ganda na i-adapt is we optimize this technology. So, paano ba natin ginagawa yon? Here, I would like to share. Ito naman, hindi ako dito sa company na to, but I would like to promote kasi ito yung ginagamit ko eh. Started using this tool 2013 pa lang. So, patagal na. And this is very effective, very useful for my projects. So, I would like to share lang, no? Hindi naman ako nagbebenta nito. You can just go to their website and subscribe dito sa software na to. So, this is a software called Homer, Hybrid Optimization of Multiple Energy Resources. This software identifies the most attractive hybrid system for a specific site location and other techno-economical inputs. So, sabi nga natin kanina, di ba, gusto natin mag-invest yung project natin. And one way of doing it is by using a software. Modern technology na tayo. Sa lahat nga, may software na tayong pwedeng gamitin. So, for optimization, we are using this software para ma-decide talaga natin, ma-identify natin kung ano ba yung pinakamagandang solution for a specific project. So, 1894 pa lang na meron na tong software na to. And just recently, 2019, before the pandemic, na-acquire ito ng UL. So, this is now Homer Energy by UL. So, these are some of the users of this software around the world. So, if you are in a power company or in academe doing research, napakalaking tulong ng software because this is globally recognized tool. You can use for research. You can use for project proposals. If you have a client na gusto magpagawa ng solar plant, you can use this technology, this software para dun sa gagawin mong design. Sabi nga nila, this tool is a Swiss Army knife of microgrid modeling. So it has many different components. So as you can see for the different components, so you can use generator, solar PV, wind turbine, a battery storage, hydro, etc. So napakarami nung pwede mong pagpilian dito. So you can use these components in different combinations. For example, you have a project na mayroong potential for solar and wind, so you can use PV and the wind turbine. If meron pa siyang potential for hydro, you can add hydro on your study. So napakadali. Very simple yung process. Similar with other software available in the market. The inputs are the economics, the load profile. So you need to get a reliable load profile for your project. For example, your project is for a certain area or siguro sa buong Leyte. So you need to get the load profile of Leyte. And then site-specific renewable resources or wind. If you can do measure the wind by using different devices, that is useful. Then system components. For the analysis, simulation, optimization, and sensitivity, the software will simulate thousands of combinations of systems depending on your inputs. Optimization will be choosing the one with the best result. So depends on the parameters that you input and resulted say for example financials, cost of electricity, So those are some of the parameters kasi na tinitignan natin. Sensitivity is when you use different values, for example, different load growth or at different fuel prices, no? So makikita mo yung impact nito doon sa system na pinag-aaralan mo. So for example, you have a backup diesel generator. So for example, the fuel price will double or triple in the next 2 to 3 years. So makikita mo yung impact mo doon sa yung gagawing project. And for the results, so you have economics and engineering data, system sizing, you will have the size of the component na kakailanganin mo for your system. Performance detail, so this is an annual or 1 year performance detail. So makikita mo doon anong month mataas yung, for example, yung solar, anong month naman maganda yung wind. So makikita mo lahat yun. Financials, this is to help you decide kasi may mga, for example, CAPEX, kano ba yung investment na kailangan for the project. OPEX, kano yung operating expenses. So this will help you decide kung ano ba talaga system yung ilalagay mo. And some other reports na kakailanganin. Okay? So ito yung, pagka binuksan mo yung software, ito yung kita mo na interface. You have here a map. You can select the location of your project. So site specific kasi siya. So, depende dun sa location. So makakapag-download tayo ng data for the wind speed and the solar irrigation depending on the location of your project. These are the inputs na just to show you lang, so you can input the load growth, annual load growth. So this is a 10-year period. As you can see, iba-iba yung load growth niya per year. Then you can also have this for the load profile, which as you can see, it's a variable load profile. So pwede mong gawin yun sa software to reflect the realistic demand of a certain area or a certain facility. For example, sa isang community, hindi naman lagi na pare-pareho lang yung nagiging consumption niya. So may mga ibang software kasi na hindi nila nagagawa to. So yung load profile na ginagamit is same for the entire year. In this case, hindi siya ganun kasi you can adjust the demand. This is as you can see here, iba-iba yung nagiging tsura ng load profile for a day. Pwede mong gawin yun sa software. And some other inputs like solar irrigation. And you can input multiple gensets, multiple battery capacity, solar. So it's up to you kung ano yung system na gusto mo. The software will just help you decide kung ano ba yung pinakamaganda na solution for your project. For the output, ito naman, so you will get the sizes of your system, ilang genset ba yung kailangan mo, ilang battery, ilang solar panel yung kailangan mo. So, malalaman mo rin yung different financial data, the net present cost, the capital cost, operation and maintenance, and most importantly, you will know the levelized cost of electricity. This is the cost of the power generation. So ito yung binabayaran mo or gagastusin mo to generate 1 kilowatt hour of electricity using your system. So makikita mo dito sa this software. So malalaman mo ngayon, mako-compare mo sino yung may pinakamurang resulta. And in addition, ito, different parameters is state of charge, the output of the solar PV, okay, and the fuel consumption. So these are the different Homer software, you can have for a standalone system, so standalone microgrid system, Homer Pro. So if your project is in an island, hindi connected sa grid, standalone yung system na gusto mo, so you can use Homer Pro software. If your project is for net metering or connected to the main grid, so gamit ka for net metering or to reduce your bill sa kuryente, so use your Homer Grid. Then the third one is what we call Homer Front. So if your project is a utility scale, say 10 megawatt, 100 megawatt solar farm, so you need to use yung Homer Front. Okay, so may different uses yung bawat software. So it's up to you kung ano yung gagamitin mo, depende dun sa project na gagawin mo. You can use the software for two ways. For high-level analysis, to give you insight. So, minsan, gusto lang muna nating tignan kung viable ba yung project. Before we do site activities, before we spend money for the feasibility study, gusto lang nating tignan kung, teka, okay ba yung project. So, you can use the software to give you insight. And the second one is the detailed feasibility study. So, kung gusto mo na talaga ng site-specific data and other information for the project, gagamitin mo na siya for proposal, for research, for those na nasa academe. So, accuracy. This is for the accuracy. So two ways. My suggestion is, even if you are very confident na feasible yung project, you can start with this high-level analysis muna. Maganda rin yung may reference tayo. Then after that, if the result will still tell you na feasible yung project, that's the only time you do detailed project feasibility study. Yung high-level analysis kasi, you can complete this in, say, 1 or 2 hours of simulation. But for the detailed feasibility study, medyo matagal ito since you will be needing to input site-specific data and some other parameters para talagang maging accurate yung iyong simulation. Okay, so I hope na at least you have the idea. There are many other tools that you can use. But for now, Homer talaga yung pinaka, I can say na for me, very helpful dun sa mga ginagawa sa study. So now I would like to show you some of the results. No, hindi ko mabibigay sa inyo yung details of the study, but just to give you the results, no, so you can appreciate ano ba yung ginagawa natin, bakit tayo nag-o-optimization, bakit kailangan gawin yan, bakit dun sa RPS guideline for off-grid ang nakalagay lang ay optimal mix. Bakit hindi na lang lagyan ng 10% doon or 1% or 2%? Di ba? Bakit optimal yung gusto talaga natin? So this is one good example. This is from a study that we made. Dito, meron tayong blended, no? TCGR. True cost of generation rate at 13.46 pesos per kilowatt hour. So yung power generation, ang rate niya is 13.46. Blended siya kasi this is from different power plants. So it could be a diesel plant, a bunker plant, a renewable energy plant. So combination na yun. So basta 13.46 pesos. Medyo mahal, ano? Now, meron tayo ditong table. We have here different sizes of solar PV, different annual savings, different renewable energy share. Ito naman, meron tayo ditong columns with battery energy storage. So with capex, cost of electricity, internal rate of return, if you are familiar with IRR. This is one indication kung viable ba yung project or hindi, kung acceptable ba dun sa company or hindi. The higher the IRR, the better, di ba? And then the payback period. I know that you're familiar with the payback period. Of course, mas mabilis, mas maganda. Mas marirecover natin ng mabilis yung investment. So for this table, you have different sizes of solar PV, 150 megawatt down to 20 megawatt. Ang importance ng optimization is, dito makikita ninyo at 20 megawatt, ano lang natin, no? So, of course, yung savings natin, pag maliit lang yung planta mo, of course, maliit lang yung savings mo. Kaya 353 million lang siya. RE share, pag maliit yung RE capacity mo, of course, maliit yung RE share mo. 7.95%. But, dito natin tignan sa levelized cost of electricity and project IRR. Dito kasi may mapapansin kayo, dito na lang pala sa IRR. Dito kasi sa IRR, at 20 megawatts, 14% lang. If we increase it to 150 megawatt, the IRR, internal rate of return of the project will be at 16.6%. Mataas, di ba? But at 75 megawatt, the internal rate of return is at 21%. So this is the highest internal rate of return. So, ano bang ibig sabihin ito? Ano bang ibig sabihin ito for the project? Ibig sabihin, kung maglalagay ka ng isang plant, and you have the option between a 75 and 150 megawatt. Di ba? If you work for an investor, if you work for a power company, yung magiging proposal natin, recommendation natin is the 75 megawatt because it has a higher IRR and the payback period is only at 4.54 years compared to 150 megawatt na 5.90 years. So hindi pala lagi na kapag malaki yung capacity ng renewable energy natin, yun na yung pinakamaganda. Of course, the savings, the RE share, mataas. But if you look at the investor side, syempre kailangan din consider natin ito. So, yung 75 megawatt pala yung pinaka maganda. Diba? So, this is one good example ng gamit ng optimization. At this 75 megawatt, yung true cost of generation natin initially is at 13.46. So, magiging mababa naman siya. From 13.46, magiging 11.81 pesos per kilowatt hour na lang. So, makakapag-save pa rin tayo ng malaki. May savings pa rin naman. So, this is another example, almost similar with the first one. So, dito naman, 15 megawatt instead of a 35 megawatt. Kasi yung IRR is 20.7%. Payback period is 4.68. Cost of electricity is from 15.15 magiging 13.90 with the installation of the 15 megawatt solar plant. So ganun kapag ka-optimization, at least you can see kung ano yung impact ng different sizes of renewable energy to your system, to your financials, to your project. Diba? That's why it's very important na we consider the optimal mix. Kasi in the investor point of view, bakit natin i-attain yung 61%, 61.3% if ang result pala nito is longer payback period and a lower IRR for the project. Diba? That's why optimal mix ang nakalagay because we need to identify this optimal capacity na ilalagay natin for the system. Ito lang i-comply natin. So if we comply this, maganda yung magiging result natin. Good for the investor, sustainable yung magiging project natin. Ayaw naman natin na talagay tayo ng malalaking planta and at the end of the day, nalulugi naman pala and then they will ask for price increase or whatsoever. So, ayaw naman natin ng ganun. So, that's one use of the optimization. So, another use is, ito, kanina solar. Now, it's for a wind farm. Ito, for example, there's a proposal, project proposal, na maglagay ng wind farm. From this study, ang gusto sana is 36 units of 2 megawatt. So, 72 megawatt sana yung gusto. But based on the optimization study, no, hindi pala natin kailangan ng 36. The optimal solution is only 33 units. 66 megawatt lang yung kailangan natin. That will give us the lowest LCOE. Dito halos pare-pareho sila kasi naka-2 decimal lang. But still, ito yung 33 units yung pinakamababa at 29.6% RE fraction. Okay. Next one, ito medyo malaki yung gap. The proposed is 34. But in reality, yung pinakamaganda pala is only at 24. Ano ba ibig sabihin nito? So if you're an electrical engineer, you're working with a distribution utility, or maybe provincial government, if you receive a proposal, may nag-propose nga, 34. So ang 34 since 2 megawatt ito, 68. So kung hindi ka marunong mag-optimization, hindi natin mababalidate if the proposal is really beneficial to us or not. So that's one good use ng knowledge natin sa optimization. Because here we can validate na, oops, teka, mukhang malaki ata yung proposal mo. Ito lang 24 units lang yung kailangan namin. So, in that way, mapapaganda natin yung development ng renewable energy doon sa grid. No? Ayaw naman natin na install lang tayo ng install. Hindi naman natin alam ano yung nagiging impact nun. Importante yung sa cost of electricity. Yes, we are targeting higher RE fraction, but we need to balance. Pag tumaas yung RE, may negative effect naman to doon sa grid. So we need to balance. That's why we need to optimize the system. So we can only install what we only need or what will be the best solution for the system. And the next one is a combination of solar PV and battery. So ito, madalas ko na ito ginagamit sa mga presentation ko. But this is a good slide, no, to really show the importance ng optimization. Here you can see different PV sizes from 0 to 3.2 megawatt, battery to from 0 to 1.8 megawatt hour. Sabi dito, at 0 PV, 0 battery, the cost of electricity is 14.54. So ito yung baseline natin, 14.54. Sabihin, pag nag-install ka ng 500 kilowatt na solar, this is not applicable to to other systems. May load profile kasi to. This result is dependent on the load profile and some other inputs, no? So this is just an example. Baka naman i-take niyo to na same with other, no? So example lang ito. So 500 kilowatt solar, that can reduce the cost of electricity to 13.03. So maganda naman. But if you install 800, so dito nakikita natin na kapag nilalakihan natin yung capacity ng solar system natin, lumalaki din yung cost of electricity natin. Kanina 13.03 na naging 13.10 pa. Tumaas pa because you install additional capacity of solar panel. The reason is hindi naman na-utilize kasi ng husto yung additional capacity. Kaya instead na bumaba yung presyo, mas tumaas pa. that is important na malaman natin. That is one of the benefit ng optimization. So pag makita natin itong capacity na to, so maiwasan natin ito na install tayo ng solar. Instead, makakatipid ka naman kasi from 14.54, pag 1.1 megawatt, 13.43, nakatipid ka nga. So masaya pa rin naman si client, no? Pero sayang sana yung mas malaking savings. And if we install battery storage, yan, kanya naman. So, pag naglalagay ng battery storage, yan, nagmamahal yung system, of course, mahal yung battery. Okay? But with the use of this battery storage, of course, yes ma'am, last 5 minutes na
Last
lang.
10 minutes. Last 10 minutes po to wrap up. 5 minutes to wrap up po. Thank you.
Okay. Last slide na din ito ma'am. So nagmamahal yung kuryente, but the importance is if we install battery storage, tumataas yung renewable energy mix natin. So dito 17%, so 21. So if we install 1.1 megawatt, 400 kilowatt hour battery, that will give us the lowest cost of electricity at 12.17 pesos. So from 14.54, naging 12.17 with a renewable energy mix of 31%. That is why hindi talaga applicable yung maglalagay tayo ng target na specific percentage. At different system, different demand, different community, different islands, iba-iba yung characteristic ng demand, and they will have different renewable energy resources. So the renewable energy mix is different. And in that case, it's very applicable talaga yung optimization. Optimal mix yung hahanapin natin. So for this example, 31% yung optimal mix natin at 12.17 pesos per kilowatt hour. So gagawin na lang dito, pagka nagkakaroon ng increase ng demand, annual load increase, you have to maintain yung 31%. So if kailangan magdagdag ng panels or ng battery storage, yun na lang yung gagawin natin to maintain this optimal mix. Kasi ito na yung pinaka lowest cost of electricity na pwede nating makuha. So that's the importance of optimization, and that is one way to get optimal mix para nga maging sustainable yung ating grid. Ayaw naman natin na basta lang mag-install ng renewable energy, wala tayong guide hanggang saan yung pwede nating ilagay. And ayaw naman natin dumating sa point na akala natin nakakasave pala tayo tulad nito, tumalaki yung renewable energy capacity. Pero yung 14.54, pag sobrang laki na, at 2 megawatt installation, hindi ka na nakakatipid, 14.70 pesos per kilowatt hour na. So akala mo nakatipid ka because of RE. Hindi. Kasi pumastos ka for the capex, for the investment, hindi mo naman na-utilize. Ayaw naman natin na yung mga projects natin ng RE. Ganito yung magiging resulta. Imbis na nakatipid, gumastos pa pala tayo. So that's the end of my presentation. So I hope may konting na i-share ako sa inyo about this topic. So thank you for listening. You can contact me sa aking email and sa aking mobile number. Thank you.
Ayan. Thank you so much, Engineer Adrian L. Ray. Palakpakan naman po natin siya. Upon checking our chat box, Engineer, parang wala naman pong question yung mga participants natin. However, some were actually asking for your presentation if you can share it with them daw po for future reference. Opo.
Yes, ma'am. I can share, ma'am. Ipapadala ko po sa inyo.
Okay. Okay. Sa mga nagtatanong kung masasend daw yung mga presentations via email, we'll have to check with the secretariat on that. Opo. So sila po yung double check po with the sending of the presentation ng ating mga resource speaker. Kasi isasend din po muna sa kanila yung mga presentation from our first topic up to hanggang sa katapusan natin. Before you go, Engineer Adrian, of course, we will be awarding, of course, a plaque of recognition, virtually lang muna, for your for your invaluable service rendered as technical resource speaker during this 22nd Eastern and Central Visayas Regional Conference. So, tong plaque na ito po ay binibigay ngayong 20th day of July, year 2023 at Summit Hotel, Tacloban City. Maraming salamat po sa iyong time, Engineer Adrian, for sharing your expertise and of course, your presentation to all of our participants. Maraming salamat po.
Thank you po, ma'am, and thank you to all the participants po. Congratulations po, Eastern Central Visayas region for this regional conference.
Hello, pasensya na. Nagkaroon ng problema with my connection. I was disconnected. Parang may problema po ata ang PLDT ngayon. So, let's proceed. Maraming salamat, Engineer Adrian. Now we proceed first with our sponsored technical presentation. I believe EDMI is already here. Andito na po ba yung representative natin from EDMI? I can see the already. Ready na po ba yung EDMI Philippines Incorporated natin for their sponsored technical presentation? Parang wala pa. Pero they're already online. People from the Secretariat, ano po? Ano yung decision natin? Ayun. Sir, andito na po siya. Hello, sir?
Afternoon.
Yes po, good afternoon. So, okay, dear participants po, for the presentation of our sponsor, para i-present sa atin ang kanilang produkto, we have here EDMI Philippines Incorporated. Sir, you have 30 minutes po to present your products and services to our participants. Thank you. We may proceed. Sir, medyo choppy po yung line ninyo. We cannot hear it properly.
Ayan, good afternoon.
Opo, at saka choppy po yung line ninyo, sir. We cannot hear you properly po.
Ayan, okay na?
Na medyo nawawala-wala pa din po kayo.
Okay, saglit lang ha. Subukan kong ayusin.
Okay po, sige po.
Pero yung slide, nakikita mo?
Yung slide ngayon na-present na po siya. Medyo okay na din po yung signal ninyo. Parang naririnig na po kayo properly. Opo. Sige po, I think you can proceed already po. Opo, you have 30 minutes, sir. I will leave it to you already. Sige po, please proceed.
Yes, good afternoon. This is Sean from EDMI. Actually, yung ating original na presentation, presenter is hindi siya available. So, I will be taking his place for the presentation. So, ang present na ko is yung AMR at saka AMI solutions ng EDMI. So, okay. So, by way of introduction, yung EDMI company is solely producing EDM meters, smart meters and smart devices. So as you can see, our meters are from the 3-phase meters up to the single-phase meters, both for the transmission, commercial and industrial, as well as residential. And the other communications EDMI products, we have the wireless and the wired, and we are in alliance with communication makers for this product. So another product that we have are the software system. We have the multi-drive, the ECView, and for the database, we have the Clarity and Backup Office. So for the software, the function of the software is to collect the data in real time, and data storage and data analysis and others. Okay pa rin mo, Miss?
Okay pa
Naririnig
naman
niyo?
po.
Okay.
Naririnig ka naman po. Yun po.
So, what EDMI offers apart from the meter is we have the AMI and the AMR network, which will be the I will dwell into this subject further. So we have the advanced meter infrastructure. It is an integrated system of the smart meters, communications network, controllers, and data management systems that enables two-way communication between utilities and customers. So AMI has a sub directory of AMR. So normally we have the submetering. So this application is normally for buildings. So we have the billing management, and then the data collection, and we have also for the billing purposes. So this is for the applications. We have the commercials and industrials. Commercials are like the malls, and condominiums, and industrial like the semiconductor industries and others. So for the commercial customers, we have the malls like Robinsons and Ayala and the Walter Mart and Santa Lucia malls. For the industrial customers, we have Honda, Samsung, and the likes. So going further, the AMR projects we have is the implementation is something like this. So these meters are the single-phase meters, and then they are the AMR connection is wired. So the architecture is something like this. So we have the meters here from different electrical rooms, and then going through a serial to Ethernet converter, and then up to the terminal, which is located in the admin office. So this is a LVSG connected to the same server also. So again, that's for the AMR system. And for the AMI system, this is architecture is something like this. This is for residential system as well as for the commercial and industrial. So we have sets of meters, and then each data are collected and then going to a server, and from the server we generate a report, and sometimes we do the disconnect and connect for the meters. So for the EDMI meters, which are good for the AMI, so we have these single phase meters at the top and the three phase meters at the bottom. And then this is for the server where we can have a presentation software to do the actual reports. So it is something like this. So as you can see, we have the serial numbers and the connected meters plus its parameters like the voltage, currents, etc., energy. So this is something for the report that we can see. It's for the same meter but for different time. So for the billing report, we have something like this also. So you have the historical reports and the consumption reports. So I think that concludes our presentation for the AMI.
May question po ba coming from our participants with regards to the product of EDMI Philippines? So far, sir, upon checking po sa ating chat box, wala naman pong question with regards to the products. But let us, of course, the Institute of Integrated Electrical Engineers of the Philippines Incorporated would like to thank, of course, EDMI for sponsoring, of course, in this activity. Maraming salamat po. Also for sharing din po yung mga products ninyo sa ating mga participants. For those who are interested po, pwede niyo pong i-chat sa chat box din po so they can give their contact numbers po. Thank you so much, sir.
Thank you.
Wala na po kayong gustong sabihin sa ating participants? So far, yun na po yun.
Yeah, that's it.
Okay. Thank you so much po. Now let us proceed to our next presentation. Sa ating next na magpe-present ng kanyang topic. So to discuss po on powering the future, unraveling electricity meters, standard service configuration, dual source meters, and AMI smart meters. We're very much privileged to, of course, have our resource speaker ngayong araw na ito po. From a CN Engineer Specialization, Substation Design and Metering from IIEE Cebu Chapter. A round of applause to Engineer John Lex James M. Canoy, PEA. Hello, Engineer.
Hello, good afternoon.
Good afternoon po, sir. Yes po, you have an hour po for your presentation.
Okay.
Para po sa ating mga participant, gaya pa rin po nung mga first na nagsalita. If you have questions, just send it to our chat box. And sir, Engineer, I will be calling your attention po pag 10 minutes na, last 10 minutes po, so you can wrap up properly.
Okay
Thank
lang,
you po.
mayroon akong clock dito para ma-monitor ko din.
Okay. Okay, thank you so much. Maraming salamat po.
So I'll begin. So nakikita ba yung yung slide, yung loading,
Yes, nakikita po yung loading.
yung audio okay lang?
Parang walang audio, sir.
Walang
Yung
audio?
audio po. Yung audio niyo po okay naman po.
Okay, sige. Okay, good afternoon. Start. My topic is all about metering. So my title will be Unraveling Electricity Meters, Standard Service Configuration, Dual Source, and EMI Smart Meter. So I am John Lex James Canoy from Cebu chapter. So for the objective of this seminar, I'll provide comprehensive knowledge and insights on electricity metering systems to enhance the expertise of the participants. So my subtopics will be power, metering parts, ANSI standards, accuracy, multipliers, instrument transformers, electric configuration, meter forms, metering issues and key observations based on my personal experience, setup, demand, dual source, prepaid net metering, and lastly, the EMI smart meter or advanced metering infrastructure. So to start, kilowatt versus kilowatt hour, power and energy. So what is the rate of use in an instant? So it is a measure of power. So 1000 watts is equal to 1 kilowatt. So let's say you have appliance, you have aircon, the rating is 1.12, while rice cooker is 0.35 kilowatt hour. In terms of kilowatt hour, you multiply that one in the hours that in the time that you have used. So power companies charge you by kilowatt hour. So let's say if the rate is 15 pesos per kilowatt hour. So in 12 hours that you're using the aircon, 206 na. While kung nagluluto kayo, it will be 10 pesos. Let's say 10 pesos in 2 hours. So assuming this is straight only, not that. Because if you go with the details on it, it varies. So if you push in high power, so it doesn't matter. So assuming this is straight 0.35 kilowatt. So for the electricity meters measures electric energy consumed. So this is what kilometers look like today. So this is actually the register of a power utility. So these are the billing. So in billing units, this is the kilowatt hour. Charged in terms of kilowatt hour. So there are two basic types of meters. So for the old days, you can see this one, the electromechanical watt-hour meter. So in the word itself, electromechanical induction. So this is actually a motor. So as the power increases, so it will also this rotor will also the speed also increases. So thus this one, the registers also has a higher register. Right now there are electronic meters. So with this one, these are composed of the components for this one are magnets. Right now the components for this one are resistors, capacitors, but there's still a current transformer inside and a power transformer. So this one is much lighter and this one is more heavy. But there's advantage for this one and this one based on my experience. Anyway, let's just focus on the other topic. We'll just go on the deeper later. So for the metering parts, so for the old electromechanical meter, there is a meter register. So there's a meter register. This is the meter register before. And there's a spinning aluminum wheel. So this is the motor. And the counter wheel, so the back view inside the meter registers. Counter wheels. So there's an induction motor assembly. So again, the rotor speed is proportional to the power measured. So these are the voltage wires. So you can see voltage wires compared to the current wires. The current wires or current coils is much larger because the current here passes, while this one is more on the voltage present. So because in power formula, power is equals to voltage times current. So you need these components, the voltage and the current. But the current, this is one, passes your consumption here, while this one is it only needs a small current for the voltage present. So that's why it's a smaller wire. So you can distinguish the two wires here. So current coil. Okay, so this will be the bus bar, larger. So because these are the terminals. So for the electronic meter, the components are, so there's a IC or integrated circuit, there's a transformer and bus bars and the current coil. So what was the difference there is there's no more induction motor in this component. It's much lighter already. So what are the types of terminal in meter? So when you are specifying meter, you can see there's an A. So this means that this is a bottom type. So there are other bottom type. This one is the IEC meter, which are the bottom type. This one. This one is an American standard or ANSI, but in a bottom type. See the terminals here, covered terminals. This one is terminals are here, terminals are here. The other type of meter terminals is the socket type. So the socket type, suffix S, these are common with the private utilities. So like Meralco, Double Light, Design Electric, more on the private utilities. While for the co-ops, mostly they use this one, the bottom type terminal. So if you specify a meter, there's an A, it means that it is it doesn't necessarily an American standard, but it means that it is a bottom type meter. Here, there's a terminal. While this one, there's a socket type. For me, there's an advantage and disadvantage as well for this one. But for the residential one, it is an advantage because it's easier. It's in a standard already terminal. But if you go to the complicated meter, I think for me, this is an advantage, this one. And in terms of pilferage also, this is more compact. So it's difficult to open this one as compared to this one. Another two types of meter, the self-contained meter. So it measures a certain load at a certain, meaning the self-contained is, and the instrument rated meter. So what this means, the self-contained is, you measure directly in the meter itself. So the ratings are class 200. And there are class 100, but here in the Philippines, I haven't seen class 320. What the meaning of this class is this rating 200 amperes. So in this bus bar, you can see here, this is rated as class 200, meaning 200 amps. In the instrument rated metering meters, these are different because if you go beyond already the 200, it cannot go beyond the 200, you don't have to measure it directly already. You will be using instrument transformers such as this one, current, voltage transformer, potential transformer, and another current for the high voltage or medium voltage. So the ratings here are 20, meaning 20 amps. So this terminal here are rated at 20 amps. Although the secondary for example, secondary here are rated at 5 amperes. It means that it can carry, if you go beyond times 4, it can carry up to times 4 for this one, because it's rated as class 20 or 20 amps. So question. Which of the following describes the primary difference between the physical design of an ANSI and IEC electricity meters? A, both meters have the same physical distance. B, ANSI meters are rectangular and designed in terminal block, while IEC are round and designed fit into socket. C, ANSI meters are round and designed with terminal block, while IEC meters are rectangular and designed to fit into a socket. Or D, ANSI meters are round and designed to fit into socket, while IEC are rectangular and designed with terminal block. So to answer this one, this is letter D. So ANSI meters are round and IEC meters are rectangular. So the rectangular, there's no specific dimensions for the IEC. So that's an advantage for IEC. There's no specific dimensions. While for the ANSI, the disadvantage is you're bound to that specific standard. So it becomes an advantage, and sometimes it becomes a disadvantage. So for example, if you're going in the future, if you're adding more features, IEC can easily do that because there's no specific dimensions, while ANSI, they can only go bigger, not on the dimensions of the round socket. So that's the pros and cons. And for the ANSI, it's simpler also because it's the same socket to all. Okay. Metering standards. So there are two metering standards. The ANSI for this one, you can see they're round, and IEC. So rectangular. So American, European, Chinese, okay, and sometimes Philippines. It's mixed in the Philippines already. So as an actual sample, this one. So the residential, so you can see this is the ANSI type for the residential and IEC type for the residential. So this is rated as class 200, while this one, I think, class 100. So this is 100 amps. Sometimes this is 60. So it depends on the utility. For the accuracy, on the captive market based from ERC regulations, it should be rated at 0.5% accuracy, or in mathematical terms, this is 0.5 error. But in metering, this is 0.5 accuracy. This is the captive market, and the contestable, meaning the contestable, the industrial, the bigger customers, 0.2 accuracy class. Also, with the same with the instrument transformer, it should be at 0.5% accuracy, or 0.5 in mathematical tolerance error, plus and minus 0.5%, and 0.2 tolerance plus minus error in metering accuracy class. So this is based from accuracy limits from ERC. For the ERC, what are the requirements for the ERC meter certifications are the following. This test, there are 8 only tests. Then you are already, the meters can be already used as revenue meter. So you can actually buy a meter without ERC seal, but it's not considered as a revenue meter. You can use as a check meter, but if you want it in revenue, meaning there's a billing already, you should have a seal or certified, and so that it can be sealed with ERC. So these are the tests only for the ERC. Okay, so actually you can buy without seal if you are in mother, you have already mother submetering, then you have already a mother meter. So there's an option not to have it sealed. But if the meters are already used as a revenue and billing, so you should have it sealed, because there might be in case of disagreements, you can rely already that the meters are sealed and in quality and accurate already. For the accuracy testing in a meter lab, these are the testing to test if the meters are accurate. So the accuracy class for this one is 0.01. So the meters are rated at class 0.5. So this one, the standard, meaning these are the reference that that your meter, you put that one, are accurate, meaning this like a ruler that it's still the same with the standard here, because there's a standard here that they're referencing that these are the accurate reading. And if you're going for a field testing, you can have also a portable meter test, but based on experience before, actually you don't actually need this one because this one sometimes costs 2 million. But if you really need an immediate then and you don't have a budget, why not use a sealed meter and have it series or parallel? Anyway, it's just the same. You just have it in a reference, but it's not standard to test that one, but it's more or less the same that you can have another check meter to test. Anyway, it's sealed already. But if you really need, like if you're a utility and you really need a more professional way to test, you can have this one. And this one, not only the meter, but you can you also test the current transformer, the instrument transformer on the ratio. Because if you focus too much on the meter, there's another component there. What if the current transformers are not accurate? So this can test in live. So while the meters are working. So how do they pick up for this one? They have a list. Detects the rotation for the old meter. So there's a small block here that it rotates. It detects the rotation, then it registers at the same reading. And there's also a pulsating image. So since you don't have the rotor already, you can have a blink here. So it can detect that one blink is equivalent to this one already. And another one is there's also an infrared here. So most others use the infrared for inputting data here or for programming, but it can also test. So what are multipliers? So in metering, you have to sometimes mostly deal with multipliers, especially if the meters are not self-contained. So let's go back to self-contained meters. Again, the self-contained meters are rated here in the Philippines, mostly rated at class 200 for the private queue, while the co-op usually use class 100. But price-wise, they are the same in price, but no need to use the class 100 already because the price are the same. So the self-contained meters are this one. So it's direct. So your supply here goes to this meter, but it should be limit up to if you declare that your house is below 200 amps, so you will be installed class 200 meter. Sometimes it's not actually 200. Sometimes there's a consideration for the DO. They will use 160 amperes because there's a double 0.8 for the power factor, 0.8 for other factors. Next, this one is the transformer rated meter. So the transformer rated, if it's beyond already 200, so the meters cannot handle already large current. So it is in the meters you don't have to. The meters, the current, your cables here, the supply for the DO doesn't have to go through this meter. They will just use instrument transformer like CT and PT. So the meters are rated class 20, or meaning 20 amps. So say you have a CT with 200 amps. Okay, the transformer ratio is 200 divided by 5 because this one, the 5 is the secondary current and 200 for this one. So your multiplier will be 40. So if you're using a low voltage that is beyond 200 amps. So if you're using medium voltage, this one. So this one is the potential voltage, and this one is the current. So as you can see, it's near voltage. It has here, sometimes it has 1, sometimes it has 2 here. So the difference is it's separated far as compared to the current. And if you're going to the substation, so this one is the current, and this one is the voltage. So one terminal only. So let's simulate. If you have a reading of 10.73 kilowatt hour and you have a CT, the ratio for that one is, the multiplier for that one is 40. So the actual reading is 429. You multiply it by 40. If you have if your CT is rated at 40:5, the multiplier is 80. Same goes 600, then 800. So you get the idea already that where does that multiplier come from. So as you can see, once the multiplier gets high, it means that this customer has a higher current already. So I think some of the, based from my experience, the secondary can up to accommodate sometimes 2,000, but it's very large already. The current the conductors are already huge already. So sometimes it's not feasible already. Some limit, utilities limit to 1,000, but it can go. I have experience. It goes to 2,000. But if you're already in the 2,000 is to 5. Why not use primary metering? It's much simpler already. So for the primary metering, instead of having after the transformer, why not have your metering before the transformer at the primary side? So there's an additional component now. Before there's a current, there's a current transformer. Now it goes to the voltage transformer because it's not possible already to use. Let's say you use 23 kV directly to that metering. So you use already the voltage transformer. So the voltage transformer secondary is 120 volts, and current same from the secondary cities, it's 5, similar. But as you can see, it go from here. Let's go back to the slide. See 1,200. 1,200 is to 5. For the here, it goes back to 100. It lowers down. It lowers down here, but there's an additional here, additional ratio here. So there's another 120. So all in all, the multiplier becomes higher, 2,400. So going back to the secondary metering, the biggest multiplier if you're up to 1,200 is 240. While using the primary metering already, it's 2,400. So there's another component here that was added, 120 times 20. So the total reading would be 25,752 kilowatt hour. So same goes with the primary metering in a substation. So it becomes larger now. So it's smaller here, but here it becomes larger, 350. So some would be 115, some, that's why there's a rated here in the substation, some are 120, but here in this voltage transformer, it is 115 secondary. So the total reading would be this one. Okay, so that would be the component for the multipliers. So let's go to the CT and PT, or overall for this one, instrument transformer. Question: why are self-contained impractical for measuring energy in high voltage and high currents, leading to the use of instrument transformer? So it lacks adequate insulation and current capacity. It is costly to build and maintain. C, it poses significant risk to technicians due to high voltage exposure. Or D, so what would be the answer? Letter A, it lacks adequate insulation. So for, let's say, the current, if you use the 33 kV voltage, so it beyond already the insulation rating and the current capacity. So for the component details, potential transformer, to reduce the purpose of this one is to reduce voltage to a lower level. So if you're what are the components or what are things to look at when determining the PT specification. So you have the ratio, you have the polarity, accuracy. So like I said before, the accuracy should be 0.3. Burden rating. Okay. While for the current transformer, to reduce the current, the purpose is to reduce the current and being measured to a lower voltage and to keep high voltage out of the meter socket. So this is safety. So what are the things to look at? Ratio, rating factor. So rating factor of 3. So meaning this can accommodate 3 times its capacity. And I think you could actually put a rating RF of 4 because the meters are class 20. So the terminals are rated at 5. So times 4 of rating factor. So it could go to 20. So it can go as high as 4. Type, polarity, accuracy, burden, and shorting bars. So this is important. So before so never open a secondary CT while the load is passing through a secondary to a CT primary. So I added some slides here because this was asked on the previous my presentation. So why CT secondary is always keep shorted? So CT at normal operation, so imagine CT that has a primary winding consisting of one turn, this is the bus bar, I mean the primary current. Well, the secondary is comprising of 160 turns. And the CT is connected to an ammeter with a 0.2 ohms resistance. The meter is designed to display a full-scale reflection of 800 amps. So considering this is an 800 amps to register this one. So let's calculate. So secondary current times primary current, considering the secondary and primary turns. So the secondary is 5 amperes. This one. If you are having the 800 amps. Thus the secondary is shorted with ammeter, the voltage across. So 5 current times resistance, 5 times 0.2 is 1 volts. So let's say this is the normal operation. Let's say we open that one, open circuit. So to understand that one, suppose the ammeter is disconnected, open circuited. Thus the transformer acts as a step-up transformer now. So this is not the CT already. Those transformers, it acts as a step-up transformer. So this will highly increase the magnetizing flux because there is no opposing current in the secondary winding to prevent this. Thus, a very high voltage induced in the secondary wiring. Suppose the current is, the current transformer CT is used on a 3-phase with a 480 volts. This one, the same current, 480 volts. So let's say the formula using 480 times the turns. So as you can see, 67.8 kilovolts. This one, so it would damage your insulation already. So be careful, not on the opening of while the CTs are live. So what are the other factors to consider? The turns ratio, the materials, the primary current level, the primary voltage, the one that I mentioned, 480 volts, and the frequency also. So a simulation, this one, so depending on the ratio, it can go high in terms of kV already. Okay, so why secondary is always keep shorted? In summary, a very high voltage is generated at the terminal, and this can lead to, since a high voltage and the CT is rated at 600 volts, and now it has a kV already, which can ultimately cause the CT to stop working properly. If someone touches the secondary terminals, they could receive a dangerous, potentially deadly electric shock. If the CT is overloaded and reaches point of a saturation, it can be overheated. This can cause, if this is an oil, inside the CT to build up pressure, leading to a dangerous explosion. So again, it is essential to have it correctly connected, not left open or short-circuited. So next topic, service configuration. Question. This is the common one. That's why I made this presentation, because of this one I seen the previous presentation. So what is the main advantage of a single phase 3-wire system over a single phase 2-wire system, electrical power system? So this one, single phase 3-wire system, these are common with private, and single phase 2-wire system common in co-op. So what's the difference and what's the advantage? Higher voltage, greater power capacity, increased efficiency, or additional service load flexibility. So what are the disadvantages if you are line to neutral and line to line? So what are the advantages? It's actually letter D, additional service load flexibility. Why? So let's go. Later I will answer that one in detail. So the distribution systems are composed on this. So 6, I have single phase 2-wire, single phase 3-wire, network 3-wire, 3-phase 3-wire delta, 3-phase 4-wire delta. Very complicated here. And simple one, 3-phase 4-wire Y. So co-op, private, and sometimes condo, and sometimes common. Anyway, let's go. So single phase 2-wire, common residential in many parts of the world. So line to neutral, so single phase, co-op. Single phase 3-wire, common residential in North America. So that's why this one is not in North America, because sometimes these are linked to IEC standard, or meaning why the meters are IEC, because it's usually in form 1S or line to neutral. This one, that's why mostly the private is more on the American standard, because this one, single phase 3-wire in form 2S. So this is the advantage. Let's say this is 240, you can get only 240. While for the private utility, you can actually get 120 here, 120 here, and 240. It's more flexible already. 2 voltages, that's the advantage for the single phase 3-wire. But they haven't utilized actually this one. So that's the advantage. Additional, it's more flexible in the single phase 3-wire. And you have the network 3-wire. So it's actually not common in our in classes. The network 3-wire is from the Y, and you get here only this 2-phase in metering, but this is operating in 4YY, but you just get a 2-phase. If this is rated as 240, in metering this is different. If you get 240 here, but you don't have to use a single phase meter already, you use a network meter here because this has an angle already. But in terms of the customer, these are the same, 240 volts. But in metering world, it is different. We'll just discuss it later. So 3-phase 4-wire, and this one, so ungrounded, grounded here, and open but grounded here. So all 3-phase. This is a 3-phase, but just a 3-wire. Another one is 3-phase 4-wire delta. So there's a center tap, and it can be over if there's no more phase. This can be similar. It's still for a 3-phase but open, but it has still 4-wire, and it still has 4-wire. 3-phase 4-wire. So my favorite, it's simple. So these are the larger customer condo. So this one, my favorite. It's simple to have it metered and simple to analyze. Go to the details. So if you are in the metering or in the customer side, and sometimes you have to specify meter, what you can see this one, 1S, 2S, 16S. So it's actually this one, self-contained. If there's an S, transformer rated, but still in S, socket A bottom type, meaning transformer may beyond already 200 amps. So for the ANSI meter forms, these are the standards. The common private form 1S, co-op form 1S, form 2S. If beyond 200, so these are. So I jot down not the complicated ones and not used. These are only mostly used in the Philippines. This one I highlighted. So ANSI meter forms. If you're in the co-op, here you can see the internal wiring of the meter. So 2 wires here, single wire. So no metering here part. So this one is the current and voltage. This one, if beyond already, this is similar to this one, but beyond already the 200 amps, 3S, 4S. So you get the idea already. This one. So as it goes, it complicates already when it's 3-phase already. For the socket, if you're using ANSI, this one. Okay, so there's 7 terminals, 6 terminal, 10 terminal, and this one is important, the terminal blocks, especially for the opening or maintaining this one, and you accidentally open a city. That's what my previous topic. So you need this one. So this one will be the shortening bars. And if you get also the voltage, you cannot get voltage here unless you can voltage here because this one is closed when there's a meter already. So that's why you need terminal blocks to get this one. So that's the disadvantage for the socket already. You cannot get already when servicing, you cannot get the voltage and the current. That's why you have an additional terminal blocks here. Okay. You open this one, there's a bypass for the current just in case. So for the metering, it's common in the Blondel's theorem. So what Blondel's theorem is all about is total power measured with one less meter than the meter wire. So if the Blondel meter says that if you're 2-wire, if you have 2-wire, so it's only 1 stator. 3-wire, 2 stator. So -1, 4-wire, 3 stator, you need 3 stator. So that's the Blondel. but it doesn't actually apply for the form 2S. But commonly this is the so if you have 2 wires, so 1 stator, 3 wires, 2 stator, 1 minus 1. So let's go to the service configuration. Detailed service configuration, single phase 2 wire. So this is the transformer, and this is the hot and the neutral. So this is the metering. There's no metering here. Okay. So the only thing to look for this one is you do not have to interchange this one, because if you interchange this one, it can have bypass some of the current in measuring this one, because this one has a ground. So maybe some current will bypass. So that's the only thing to look at for the Form 1S in co-op. Okay. Form 3S is actually similar to 1S, but in beyond 200 amperes. So if beyond 200 amperes, you cannot, you need already a CT. So this one. Again, one, and you need a CT. Okay, and voltage for the smaller wires. So for the sample, this one and this one, self-contained and transformer rated. So this one is the similar sample. So for the pacer, it's easy for one Form 1S. So voltage, time, current. Okay. Next, for the usually for installation for the private use. So for the private use, this one is optional. They can have it provided or not. Anyway, the metering here is directly here, and it doesn't rely on this one. There's no metering here. So that's why it doesn't matter if you're having this one, but if you get this one, if you get 120 voltage here, it doesn't matter because it's already here. So it's a Form 2S already metering. So you can actually get a 120 this one. So that's the only advantage for this one. There's a dual voltage for the 2S or the 3-wire system. Okay. So the only thing for this one is not the wires that are interchanged, but if you make the meter in reverse. But right now the meters are sophisticated already. There's a additional, I mean, if you reverse that one, it can still add up. So it's programmed already because it's an electronic meter. It's programmed to add up. So it doesn't matter already now. Form 4S, so beyond, it's actually 2S, but beyond 200 amperes. Okay, similar. So samples, this one. Next is the phasor diagram. So here, the current here, voltage. And if you're going to the actual, what the meterings inside is actually 1 CT, but it just loops around. So that's it. So it's actually similar to 1S, but in 1S, the current here is only 1 CT for 1 current in 1S. This one is 2S. So to make it cheaper, they put in a single, supposed to be, has to be 2 current coils here, but they put it here. Just loop it here. Because if you similar to this one, it will cancel out. If the wirings are similar to this one, it will cancel out. That's why to add up this one, that one. See? Okay, next. Network 3-wire. So network 3-wire is actually, it looks similar to Form 2S because 3-wire. But in metering's perspective, it's actually just from a 3-phase. And this one is angle. That's the difference now. You don't use 2S here. Normally, if you can see this one, it's not in metering, it's not 2S because there's an angle already. So to give you the phasor, it looks like this already. So if you put a 2S meter, it can handle angles already. It doesn't matter for us, the customers, because the customer only wants the 240 volts here. For the metering, it's different. So to be safe, just use a 3-phase or something. But the appropriate metering in this one is Form 2S. Okay, so this is the phasor diagram. 3-wire. So 3-wire is just a 3-wire, but delta. So in 3-wire delta, in Blondin's theorem, you have 3 wires. So you need only 2 stators, so 2 CTs and 2 potential. Metering here. That's the Blundel's theorem in work. Okay. It's complicated here, so that's it. Just to give you a preview. So let's say this one, this is the phasor for the 3-wire delta. So that's why I don't like much more on delta. It's very complicated. But if you're used to it, it's easy already. But at first look, it's complicated actually. So 3-phase 4-wire delta, here this one. So the advantage with this one is there's a lot of voltage already. So you can see 240, 120, and there's a power leg 208. So what's the power leg? Okay, we'll just discuss later. So if your metering is already beyond 200 amps, this one, the CTs are out, metering are out. Okay, that's it. Okay, here the power leg. So if you check the power leg here, this one is 240, this one is 120. So you just use this one. VCN is 208. So you just 240 squared minus 120 squared is 200. This one is the 208 volts. So there's a lot of voltage already. 240, 240, 240, 120, and 208. This one is called the power leg. Okay, 3-phase forward. So for me, it's easier to follow this one. And it's applicable also to a lot of bigger customers. So that's the advantage for this one. So a lot of bigger, and it's simply already for metering. So this one is the Y, but below 200 amps. So you can have a self-contained. This is in form 16S. So since there are 4 wires in Blundel's theorem, you only 3 stator here. Okay, that's it. Okay, if beyond 200 amps, you need CTs. Okay, and if beyond also bigger or bigger conductor already, it's not feasible to use a CT already. Here you got the primary metering. So all the primary, the current, see, the current is in series. This one, voltage. Okay, so this is the secondary, and this is the primary metering. So to give you a sample, this one. So this is the current. You can see the current. It's easy to spot the current because the terminals are close, and the voltage, there's the 2 terminals are far. Another sample. So this one, current and voltage. So voltage, see, sometimes this is 1, but the current is the terminals are close because it's in series. So for the phasor, so it's simpler. Okay, the usual EE theories. Okay, similar, even if it's primary metering, secondary metering. So based on my observation, if this is your system, it should be color coding, because if you have this to have a proper indication, because if you in metering, if magka-ano sila, wala, there's a possible bypass. This one is often misapplied to the form 12S, or there's a meaning, the one that is a network metering. So this is not a network metering. This is a plain flat metering, but in a 3-wire, not for this one. So sometimes these are interchanged. This one, if there's a neutral disconnected, so for metering, this is because the neutral here is not actually used by the customer. So if in the metering world, the neutral is very important. That's the return path. So no neutral, and the customer doesn't bother because they don't use the neutral. But for the metering, it's important for the metering. So there's no metering. So that's why, based on my personal experience, this one is to look for in case of this one. This one also is easy to filter because of the neutral. Sometimes they don't use, the customers doesn't rely the neutral. This one, for me, the recommended is this one, because customer uses this one, line to ground. So if they will disconnect that one, so simple and why are simple. So for me, this is for me the recommended setup. Next, let's say for the actual classification, if this is the self-contained, so all in all, if you have three-phase, if you have single-phase, 30 kilowatt-hour only. Three-phase, you can go as high to 100 kilowatts. So this will be the metering setup. This is from Design Electric. And if it's beyond already, beyond 30, let's say 50, you can have the secondary metering setup already. Okay. Well, here, 400 kilowatt, so meaning 3167. So this is already 3 bank of 167 kVA. So this is already a primary metering setup. Okay. Demand. So what is, there's two parts of energy measurement, not only kilowatt hour meter, but there's also a kilowatt meter. So we only familiar with this one because this is mostly in the residential, but in industrial, there's a kilowatt meter actually. So what is a kilowatt meter? How does it operate? So it's like an odometer. So this is the old meter for the kilowatt here. So when it's registered, it doesn't go down. It doesn't go back to zero. You only have the meter reader will have to reset it manually here. That's why there's a seal. So you have to read this one. So every time it reaches to the highest point, it reaches there, but it doesn't go back to zero unless it physically reset this one. So why do we need that one? Why do we charge kilowatt, not only kilowatt hour? So let's say you have a load profile in 1 month here. This is the energy use. And there's a demand, the spike here. Highest 15-minute. So not on opening your motor, but it is an average of 15 kilowatt peak. So what is the primary purpose of the measuring demand in electric utilities? To calculate energy consumption, forecast weather patterns, manage load and allocate resources, or D, to determine electricity rates. So why? So the answer would be C, to manage load. So why manage load? So if you are having demand, you register a high demand in your, you always need high demand. So this will look like there's a lot of substation in your area to accommodate you. So the reason would be load management, specific pricing. So these are the specific reasons why demand is measured. So it doesn't actually get to the answer yet, but just have it this one. So load management, infrastructure, pricing, demand, grid. So the answer would be this one, cost of energy, just to give you that instant demand. Cost of equipment, you need higher. So to explain further, we have an analogy here. To compare, both cars travel at a distance of 60 kilometers. So same 60 kilometers, but it only travels 1 hour. It travels 1 hour, so it's not that fast. While if you demand, if you use 240 kilometers per hour, so you covered only 15 minutes. But see, if it's actually similar to a transformer. So that's why if you need that demand, higher demand, you have a bigger transformer, bigger substation. So why not manage this one? In a way, the energy is the same. You flat it, that one. Energy the same. Energy 2,000 kilowatt, but the utilization is different. See, 2,000 at 1 hour. This one 500 at 4 hours. So that's why demand. There's a demand measurement in order to encourage customer to this one flat. Okay, so don't worry because this one is the interval is average at 15 minutes, not at a instantaneous that you switch on motor. It will automatically register. It just needs the 15-minute average. Okay, so what does this do with your billing? So let's say because this is already in load factor, if you cannot flat out this one is the perfect load factor. If you cannot flat that load profile, a flat load profile is a load factor of 1. So for example, this is the actual billing, and the load factor he has, or that the customer is 27.81. So what does that affect to the billing? So the billing, based from your dimming, there's an additional 22 to 26% of from the kilowatt bill that you have. So additional this one, if your load factor is this one. If your load factor is one, you seldom use, but you get higher peak, so 132. So it's expensive to have in your kilowatt rather than kilowatt hour. So that's why some customers will utilize 24 hours. Their customer, I mean, their factory is 24 hours because it doesn't necessarily have to have peak. Just let it flat out to save from the kilowatt demand. So that's the kilowatt for the bigger customer. So this one, what is the primary source of dual source meters in condominium with backup generator? To regulate voltage by the utility, to monitor. I'll just go directly this one. So the answer with this one is to accurate measured energy delivered by backup generator. Actually, this is not this is beyond the standard already. Because this is a request from one of the utilities here. Because there's a requirement from the condo to what if there's a generator? How do you build that one? So let's say this one. So there's a meter already. There's a meter that is specific for condo that can read generator and DU. So this is called dual source meter. This one. Okay. So there's a potential here if there's if this one. Yes.
Engineer,
10 minutes.
last 5 minutes po.
Okay.
Thank you.
Yeah.
5 minutes
dual
na.
source.
Opo.
Okay. So prepaid meter. So to encourage customer to have it paid in advance. So this is the prepaid meter. And there are two types, the STS and the smart, online and offline. So I'll not go into the details, but there's two types of prepaid meters here in the Philippines. Net metering, the usual for the RE. So in actual setup, this one, there's a bidirectional and unidirectional. Okay, smart prepaid, smart metering. This one is different. Different remote. This is different from remote metering because remote metering is if you define smart metering, there's two features that you have to see. In ERC, there's a two-way communication plus disconnect. So not only a two-way communication, if it's a two-way communication or a communication only, it's categorized as a conventional meter with remote reading features. But if it's a smart meter, it should have disconnect already. So these are two. And the DOE definition, communication and disconnect. So if you can see the ERC regulations, there are conventional meter, elevated meter, and the smart meter. So to give you a preview, so these are the conventional meter. This can actually read remotely, but it's still categorized as a conventional, elevated, and smart. So Philippines vision by smart grid by 2040. That's why it's important already to discuss the smart metering here. It's in this one. So as of now, 2022, there are these meters that are approved with their meter communications options. So this is the remote reading features, the radio, and the different types of communication, the LoRa, cellular, and local network. Okay. And types of communication comparison, cellular and LoRa. And that's all. Thank you.
Thank you so much, Engineer John Lex James M. Canoy. A round of applause, please. Thank you so much for discussing such a wonderful topic. Engineer, marami po yung nag-request ng slides niyo po. If you can send it to them daw po. Because your discussion was very essential. Of course, before you leave, Engineer, hindi ko na lang po yun ang video ko po kasi para nagloloko po ngayon si PLDT. Medyo napuputol-putol po yung linya. We would like to award you this plaque of recognition. Of course, Institute of Integrated Electrical Engineers of the Philippines Incorporated, Eastern and Central Visayas Region, would like to award this plaque of appreciation to Engineer John Lex James M. Canoy in grateful acknowledgement of his invaluable service rendered as technical resource speaker during the 22nd Eastern and Central Visayas Regional Conference, given this 20th day of July, the year 2023 at Summit Hotel, Tacloban City. Thank you so much po, for your assistance, engineer. And so
Thank you.
now we are down to our last two topics. Dalawa na lang po ang ating topics. So let's move forward to the topic on electrical system design for healthcare facilities. Andito na po ang ating speaker. Ladies and gentlemen, a round of applause to Engineer Benji R. Simeni. Hello, Engineer.
Yes, ma'am. Is my audio very clear?
Yes, your audio is clear, sir.
Okay.
Ayan, you can already see the screen share din po.
Na-share naman na okay na.
Okay pa, apo.
Klaro?
Klaro
Okay.
po.
So, what is this? Okay, can I start?
Yes, engineer. Engineer,
Yes, good afternoon,
mamaya
everybody.
po, engineer, mamaya po, I will just be interrupting you if 10 minutes na po yung 10 minutes before the time so that you can wrap up within 5 minutes.
No
Thank you
problem,
po.
ma'am. I'll try to finish as fast as I can.
Thank you
I
so
think
much.
I'm very early for the tomorrow session. Anyway, good afternoon, everybody, and I appreciate a lot for this opportunity to share with you my experience about electrical systems designing about in healthcare facilities. I am engineer Benji Nito Arsimini. You can call me Benj or Benji. I am a professional electrical engineer, and I was working about 26 years in the field of electrical systems and healthcare facilities abroad, aside from my other practices. So I will not be talking more about computations. However, I'll be talking about surgeons, about nurses, and patients. Okay, so my topic is about electrical systems and healthcare facilities. As you know, we had, and still, at the moment, we are still on pandemic times, although it's a bit minimal. So the significance of this subject matter came into play because of the many people that were sick. No, in fact, no choices. You can be an engineer, you can be a doctor itself, you can be etc. And you will need hospitalization. And in the hospital, the electrical systems plays a vital role that we as practitioners, we should be aware. So the discussion will just focus on few things: introduction, objectives, definition of terms, shall make it faster, applicable standards, risk categories, healthcare electrical requirements, electrical power and patient areas, coordination and protection, generators and switchgears, very important in healthcare facilities. And just continue. So I'll just omit this one. This was my introduction. So what to expect at the end of this lecture presentation? The participants will be able to know the following: the kind of electrical systems in healthcare facilities, the basic protection to limit hazard currents, the need of coordination and protection, the requirements of standby power plants in healthcare facilities. So here are the few definitions, which I'll just skip. Alternate power source, critical branch. You can read this one with the Philippine Electrical Code 2017 edition, and also with the National Electrical Code 2020 edition. So it's all there. So I hope you'll find with interest to scan this one in your code. Oops, what happened to this? What happened? Hello? Hello?
Yes, sir.
Klaro pa, ma'am? Klaro pa?
Opo, nakikita naman po.
Hindi mag-transfer ng ano ko. Slides to.
Definition of terms pa rin po yung naka-show
yes,
sa
ma'am.
ano.
Okay. Okay.
Ayun,
Okay.
it's moving na po.
Moving na. So, in the electrical systems in healthcare facility are governed by standards. There are regulations formulated by international bodies. First and foremost, we have the National Electrical Code, which deals primarily with safety. The latest one is 2020 edition. You also have healthcare facilities with the NFPA 99. Also in NFPA 101, just talking about life safety, and NFPA 110, emergency and standby power systems. And the IEEE is also talking about electrical systems in healthcare facilities, and our Philippine Electrical Code 2017. And of course, the governing body for accreditation, we have the Joint Commission International from the US and Canada. They are the one who is evaluating, giving the accreditations of these, shall we say, first class or primary hospitals per se. So when you design a healthcare facility, you must be knowledgeable with all of these standards that I have just mentioned. Okay. So in the healthcare facility, the kind of environment is defined by categories. We have risk category 1. What is risk category 1? As shown is that the failure of such equipment or systems is likely to cause major injury or death to patients or caregivers. Category 2, minor injury to patients or caregivers. Category 3, patient discomfort. And category 4 is no impact on patient care. So my discussion will focus on the category 1, which is the worst case scenario. So healthcare facility loads are divided into 2. You have the non-essential. Yes, this the lightings, general lab equipment, service equipment, patient care areas. The less critical, we call it non-essential electrical systems. And the other group of loads, we have the essential electrical systems, or EES, vary according to the risk, the patients and staff that occupy that space. So here is an example of a type 1 EES as per NFPA 99. It's a complete healthcare facility where I was engaged many years of my practice in Saudi Arabia. It is a complete life support facilities such as cardiac ICU, surgical ICU, BICU, and neonatal ICU. This is a healthcare facility of the Ministry of Defense in Saudi Arabia. So the essential electrical systems is also subdivided into 2 branches. We have the critical branch, the life safety branch, and the equipment branch. Now, what are these branches? So for the critical areas, critical branch, you have the isolated power systems, task illumination, and selective receptacles in the following areas: pediatric, medication preparation, pharmacy, acute care nursing areas, psychiatric, water treatment rooms, nurse station, and so forth. Specialized patient care task illumination as needed, nurse call systems, blood, bone tissue banks, telephone equipments for communications, task illuminations, selected receptacles, power circuits for the following general care beds, angiographic lab, cath lab, coronary ICU, hemodialysis, emergency treatment rooms, etc. And additional circuits and single-phase traction motors as needed for effective operations. That is what we call the critical group of loads. Now, for the life safety branch, which is the exclusive branch, you cannot connect any other loads to this branch except the one listed. So illumination, means of egress. So in emergency, you need lighting, you need illumination. Exit signs, alarms and alerting systems, emergency communication systems, task illumination, battery chargers for battery powered lightings, selected receptacles of the generator, which is very important, elevator lighting control, communications and signal systems, generator set locations such as task illumination, battery chargers, battery powered lightings, and so forth. Generator accessories, essential for generator operation. In emergency, you need to run the generator. So there should be no mixed up. It should be in the life safety branch. And automatic doors used for the passage of personnel and patients and other people. So the other group subdivision belongs to the equipment branch. The equipment branch is subdivided into another 3 groups. We have the non-delayed auto transfer, we have the delayed auto transfer, manual transfer, we have the delayed transfer as listed. For the non-delayed auto transfer, instant, once the power failure comes in a matter of 10 seconds, these groups of loads also must be connected to the power supply. So we have the all generator accessories, such as transfer fuel pumps, very important. Otherwise, your generator will be running, but in a few minutes, it will shut off. electrically operated blowers essential for generator operation for air inlet should be open, and also the outlet, so that your generator will perfectly operate to protect the critical and critical loads of the healthcare facility. We have equipment for delayed automatic, so it can be delayed, such as heating equipment of operating rooms, labor delivery, recovery intensive unit, cardiac care unit, nursery infection isolation rooms, emergency treatment spaces. This is also very important, especially during the pandemic, where you have positive and negative pressures. So without switching on immediately these pressurized rooms, then contamination will worsen. That's why many people died during the pandemic. Kaya mga ibang hospital, walang mga isolation areas. Hyperbaric, talking about pressure, hyperbaric facility, automatic doors and autoclave equipments for sterilization. And this one, the least important, you can delay this transfer. You have the central suction systems, it's pressurized also. Some pumps, compressed air. Naturally, there is a pressure tank, so it can be delayed. Smoke control and stairs pressurization systems. Kitchen hood exhaust for dietary. Ventilating systems, supply and return. For inspections controls such as isolation rooms with positive and negative pressure requirements, also laboratory, exhaust hoods, medicine, ethylene oxide, and anesthesia evacuation. So as a designer, you must familiarize with these different types of loads and according to the priorities. So here's a basic example of a healthcare facility arrangement. You have your normal power source, say Meralco, Baco, whatever. Then you have your generator source and just one, because this is a small facility, auto transfer system. And the limit of this one is 150 kVA. And downstream, you will find that the equipment system, critical branch, and life safety branch, the very important branches of the hospital. As the facility becomes larger, you will find multiple auto transfer systems. Now, you might ask me why 150 kVA is the limit of the ETS. Well, that is related to the type of load that you will throw to the generator system, the impacting loads. So it should be gradual and calculated. So talking about OR, which of course nobody wants to be in this area. So the power requirements of the OR, as you can see, if God forbids anybody will be there, I'm sure during the pandemic, a lot of people were here. So you should know that inside the OR, the requirement as per National Electrical Code and Philippine Electrical Code and IEEE, the OR should have a minimum of 36 hospital-grade receptacles with at least 12 receptacles, but not more than 24 shall be connected to the normal branch or to the critical branch. So if you're still conscious in the operating table, you can still look around, look at the surroundings. If you have a lot of receptacles inside, this is for you the safety of the persons that will be operated, because if power cuts off, naturally you need backup power. If something is wrong with the outlets, you need another outlets to rely on to support your life. So here is the ICU. The ICU, as you look at this person, is very sick, probably during the COVID times. So the minimum receptacle is about 14 receptacles in two sources. You have one branch from the critical and one branch from the normal system, so that at any given time, when power is lost, generator kicks in, there is a possibility, less possibility that all the outlets will be without power. But nowadays, ICUs and ORs are supported also by UPS. But UPS used, too much usage of UPS will generate harmonics. So it will also affect the neutral of the distribution system. It will affect the generators and many, many more things which will be discussed during we reach the topic about generator. So in a normal room, such as this one, will only require 8 hospital-grade receptacles. Now, grounding and bonding. These two are the essential safety elements inside a healthcare facility. as a practitioner, we should know the difference between grounding and bonding. Grounding is to stabilize the voltage, especially if you have a lightning storm. Because if you have a three-phase system, the neutral at the center of this triangle, or the center of this delta, once the lightning will strike, the neutral, if not grounded, will move to the extent that phase voltages will vary and will damage the equipments. Bonding is a different thing. Bonding is providing a return path of the fault current back to the source, to the transformer. So take note of grounding and bonding. They are very essential in the healthcare facility, and of course in any other commercial or whatever facilities. We should familiarize this one. So when we talk about healthcare facility, we should know also why there is a term separately derived system and not separately derived system in relation to the emergency systems. Now, if the system in the healthcare facility is using a 4-pole ETS wherein the neutral is switched between the normal to the generator and vice versa, we call it a separately derived system. However, if the system uses only 3-pole auto transfer switch, wherein the neutral is directly bonded, we call it not a separately derived system. The consequence of this one, by mistake, a lot in the practice, and especially in the healthcare facility, there is a 3-pole ETS, but the neutral of the generator is bonded to the system without passing to a switch. Opening, then that is a violation, because this will create a multiple current path, and if you have a ground fault protection at the source, this will keep on tripping to the extent that it will take time to troubleshoot and it will take time to restore power. So take note of the difference between separately derived system and not a separately derived system in relation to generator and ETS installation. This is the view of the patient room. Let's say a ward where there are 2 beds. Okay, I was talking about grounding. So grounding bus is an essential thing in each patient bed. In this location, you need a grounding bus so that when the biomedical equipments such as portable X-rays or other procedure equipments brought in by the doctor, by the nurses, by the RT therapists like that, they have to ground. They have to connect their equipment to the ground bus. The ground bus looks like this: grounding point, ground jack. We call it grounding jack. In each bedside, there should be a grounding jack as a standard any hospital. And if you look at the view of these receptacles, there are either 8 or CU 14. So it should be divided, one group to the other source, the other group to the other source also, to prevent total paralyzation in case of a power failure. So what are the rules that we have to observe in the healthcare facility? Number 1, separation from other circuits. The life safety branch and critical branch of the emergency system shall be kept entirely independent of all other wiring and equipment. If there is fire, at least hindi maubos lahat. Where general care locations are served from 2 separate transfer switches on the emergency systems, the general care circuits from the 2 separate systems shall be kept independent of each other. Where critical care locations are served from 2 separate transfer switches on the emergency systems, the critical care circuits for the 2 separate systems shall be kept independent of each other. Again, all wiring shall follow the requirements of Chapter 1 to 4 of Philippine Electrical Code 2017, and you will also find in National Electrical Code the same recommendations. All branch circuits serving patient care areas shall be kept provided with an effective ground fault current path. Ano yung ground fault current path? Yun yung mga ginaground natin, metal raceways. So these are what we call the ground fault current path. So the receptacle is grounded to the metal box and connected to the ground. The EMT are grounded, IMTs are grounded and going to the grounding connection and also the grounding bus bar. So whenever there are leakage currents in these things, the leakage current will always go back to the ground and going back to the source to prevent harm to the patients and to the personnel while they are doing the medical procedure. So, major contributors to hospital electrical accidents are faulty equipments and wirings. Electrical accidents fall into three categories: fires, burns, and shocks. So, these are now about talking about the hazards. So, electrical shock is produced by current, not voltage. And we know the human body acts as a large resistor to current flow. The average adult exhibits a resistance between 100,000 and 1 million ohms measured hand to hand. The lowest level of current that perceptible to a person start about 100 microamperes. Arm muscle contraction and pain may develop 1 to 5 milliamps and is assured at 10 milliamps. Uncontrolled contraction, not let go, can start at 6 milliamperes and higher. Above 30 amps, the chances of fatality from variety of causes, including ventricular fibrillation, increases. Why I'm talking this one? Because of this example. In a healthcare facility, the risk of silent electrocution is very high. And I've been talking about this many times since I was in Saudi Arabia with the person there, the administrators and authority, about proper designing and maintenance, especially the biomedical equipments. Example of this one, this person, he could be or she could be a very ill person. He cannot move, he cannot talk, he cannot even shout if there is pain on his body, probably half unconscious. So what if this is a cath lab system? What if there is a defective outlet in the equipment that is used? So current, leakage current will flow to the body, to the heart of this person, and he could die silently on that table. And this is a big responsibility. We are responsible for this as electrical engineers. So do we, the biomedical engineers. So that's why I've been emphasizing about calibration, about testing, leakage current test on the biomedical equipments, and of course in our socket outlets as electrical practitioner. So these are the tolerable ratings of leakage current of different equipments in the hospital. The highest is the OR table. So nobody wants to sit to lay down on the OR table because it has a highest leakage current, about 100 microamps. It's dangerous. This is a 450 heart lung machine. So it's also dangerous. This is during the heart bypass. This is used because your blood is bypassed to the mechanical machine and it is supplying oxygen to your brain. So the maximum safe value, portable equipment, 300, and the rest 150. So it's good if this can be controlled. But as I've said, preventive maintenance matters most, and every preventive maintenance of medical equipment should be certified. There's a sticker that you should put and sign that you did the preventive maintenance at calibration, and this is safe to use and certified by the department head. So what are the mitigating measures to minimize leakage current? Number one, and very important, is grounding system. It's the primary safeguard for bypassing the leakage and fault currents to prevent shock from these sources. Metal conduit lowers the effective grounding impedance by providing a parallel path. The use of isolated power supply, the use of ground fault circuit interrupter, GFCI, conductive flooring. In the OR, the flooring of the OR itself, underneath, there are very thin copper tapes installed. These copper tapes forms like grid in a substation. That is to dissipate the charges, no, the spurious, what we call leakage current, safely to ground. So with locations, who will decide? So in the healthcare facility, there are areas, we call it hazardous locations, we call it wet locations, and this is determined by the administration itself. The administration composed of surgeons, consultants, like that. So we as engineers, we will wait for their, especially if this is a new facility. So let's say in their decision, they will decide that one area, they call it wet location, but in case of power failure, no problem, they can wait to restore the power. So the requirement to protect that area is only GFCI, this one. However, if the area cannot wait for about 2 to 3 minutes to restore power, then the requirement is isolated power supply. The rest of the areas in the healthcare facility, we call it, we only need grounded power, no extra protection required. So this is what you will see in a wet location. Here is a GFCI. This is the GFCI, and it will trip when the leakage current reaches 6 milliamps. This one is an isolated power where it will trigger an alarm. It will not trip. It will trigger an alarm to notify the persons inside the particular place doing medical procedures that there is an ongoing leakage current, and they should hurry up and probably take precautionary measures. So it will alarm above 5 milliamps. Other people think that this isolated power will trip the breaker. No. So here is an OR setting. This is an OR. This is the patient bed. So the marked light green are the movement zones of the team. When you see an OR, you have a surgeon, you have a consultants, you have nurses, you have anesthesia, dealing with anesthesia, etc. So inside the OR, as I've said, you need 36 socket outlets, and this is isolated power. So whenever this isolated panel here will trigger an alarm, meaning the leakage current exceeded 5 milliamps, at this illustration is 2.5, that is safe. However, if it goes more than 5, the alarm is heard all over to warn the staff that there's a leakage thing, and they have to inform the biomedical and the electrical engineering department to check. But you cannot just get in. And of course, themselves, they have to hurry up to finish their job, because maybe they can still safely go there for 30 or 1 hour before this leakage thing will get more serious. So when you design an isolated system, it's a different thing with our distribution system in residential and commercial or other buildings, no? Because the wires are color-coded differently. So for isolated power system, conductor 1 is orange, conductor 2 is brown, and conductor 3 is yellow. So specific. So once the purpose of this one is not to interchange. Whenever there's somebody without knowledge about isolated system, you open the ceiling, he wants to connect something, by ignorance, he can connect. But a knowledgeable person about this one will never touch, because number 1, this is inside an EMT or the rigid steel, REC. And wires starting with letter T, like THW, THHN, TW are not qualified to be used in the isolated system because of the very low dielectric insulation capability. So the leakage current will be high. So the wires that will qualify inside an isolation installation are those started with letter X, those with cross-link polyethylene, XLPE. Yan ang mga ginagamit dito. So next is, this is a GFCI shown, used in the pediatric ICU. So GFCI, less critical. There is some problem or there's some water spillage, it will just trip the circuit. So the principle of GFCI is very simple. So current goes in, must go out. So if you have a 1 ampere current goes in passing to this CT, the 1 ampere should go back. Otherwise, if it is less, then it goes to the ground. This one will trip the circuit. Now, coordination. So coordination, when we talk of coordination, this is very important, especially during commissioning of the facility, brand new. Because there are a lot of cases wherein this fault that happened here will affect other breakers in the system to the extent na nag-black out pala because of one simple line to ground fault. That is a very bad type of protection without coordination. So a perfect coordination, or they call it discrimination. So when there is a problem in this bus, only this OCPD protective device will open to isolate this fault. The rest is healthy. That is the requirement in a healthcare facility. Stringent requirements. So again, our fault calculation, three-phase fault calculation, single line fault calculation, line to line, etc. will matter as a practitioner. So this is another case wherein a single line diagram is showing the bus bar of a healthcare facility, we have two normal sources and the emergency system, a standby plant. And they are linked by this single ATS. So normally, if the source is coming from the normal and there is a problem with this panel, this breaker should only isolate this part. It should not affect the upstream OCPDs. Okay. Now, if this ATS is focused, is a switch on to the generator is running. If there's a problem on this one, then this thing probably, because of the rule, will trigger an alarm or will trip, not affecting the upstream devices. Okay, so it is a function of the speed of the breakers to isolate. You need your time current curve when you specify a breaker, because you need to do coordination study, discrimination study, your short circuit against in relation to the time that this breaker will isolate. So everything will matter. It's just a healthcare facility, but short circuit calculation is a must. Here is an example of discrimination. So here, the same thing, you have two normal sources and a generator. So this fault calculation, a simulation of the fault calculation, at this junction, this bus, the 20 amps breaker, if there is a voltage fault, the short circuit carries about 2,770 amps. Upstream, for 400 amps, it was determined at about 18,241. And if you put some fault here, it was determined at 27,877 amperes. And upstream the bus is about 29,780. That's normal, because as you go farther, because of the reactances of the cables, the short circuit at the farthest downstream will be a little bit lower. Now, if you specify a breaker, you do a discrimination study. Of course, you need to discriminate by 0.1 second. This breaker should not overlap. So meaning to say, if there is a fault on this one, this 2,770 fault current breaker should open in 0.03 seconds. If the fault is somewhere here at 18,241, the breaker should open at 0.07. So if you subtract that one, there is always a discrimination. This breaker upstream will not trip if there is a problem in the downstream breaker. Also with the upper upstream breakers will not trip if the problem is downstream. So that is what we call a perfect discrimination. So again, my fellow practitioners, fault calculation is very important. So this time, it's about the requirement for ground fault. Whenever you will be in the healthcare facility, ground fault is mandatory. Ground fault protection for the incomer and also the downstream first level and second level. So do with the equipments. So you can find this explanation in the National Electrical Code in detail. So what if you have a system, I'll just go to the drawing, like this, wherein somebody will tell you, I need a ground fault protection here. I need a ground fault protection there. There is a restriction. For normal loads, no problem. You can install a ground fault protection, first level, second level, to the third level. No problem. You can open that one. But in the emergency system side, wherein you have your essential electrical systems, EES, you only need to install an alarm. Okay? GF is not allowed. Ground fault is not allowed. Otherwise, the patients will die. Pag mayroong ground fault, namatay na yan. The same thing with these branches. GF not allowed between generators and transfer switches. And the generator also is not allowed to shut down, but only to alarm first if there is a problem. So that is a requirement of NEC and IEC also, should say. So you cannot just apply ground fault protection to a healthcare facility. There are restrictions and special regulations. Okay, a ground fault will looks like this, a ground fault relay, wherein you have an insulation fault. Of course, the ground current goes to the ground connection. It will be sensed by this relay and it will trip the breaker. Generators play an important role in the healthcare facility. Without a generator, I don't know what will be your backup source. Otherwise, you need 3 feeders coming from the utility, one with special function to support. But the usual thing, the usual arrangement, wherever you will go, you will have a standby generator. So this is standby generator. You have the breakers, main breaker, and you have your ABR, which is to maintain the voltage, and you have your exciter in this side of the winding at the rear, and you have your governor, wherein you will maintain your frequency. So when you buy a generator, or when you specify a generator in a healthcare facility, there are things also that you have to observe. The facility has what we call MRI. There is also a scan department. There are a lot of scanning equipments in the laboratory. The type of voltage, the type of response from the voltage and the frequency will matter most on the result of this data imaging equipments like the MRI or the CT scan. Here, if the load is suddenly applied, let's say by mistake, you applied more than 150 kVA of load in one ETS. But nowadays, there are bigger ETSs that can really support that one, and the generators are okay. They have a big, faster response. So when you put a load on this particular time, the tendency of the frequency is to go down, drop. The speed drops, and the governor will tend to restore the frequency to the extent that it will go to its nominal value. Going to the normal source, when the load is removed from the emergency going to the normal source, the frequency will tend to go up. It will tend to overspeed. The governor will also react to restore to normal speed. Same with the AVR. When you put an impacting load at this junction, the voltage will, at this junction, put the load, the voltage will tend to go down, the AVR will restore. And if you remove the load suddenly, the voltage will go up, but the AVR will also tend to restore. This is very important because when you specify, when you check the generators that you will purchase, when you go to the factory for the factory acceptance test, you should demand a load bank testing. Load bank testing, and you should vary the loads so that you will know that the generator you choose meets your specification, the certified specification. There are generators, very nice paint, good name like that, but when you load almost 80%, marinig mo na yung problema. Wala na, the voltage is already a problem, or the frequency is already hunting. So here is a further explanation on that one. So a generator will support very critical loads. Number one, as I've said, MRI, X-ray, and CT scan. Failure of the generator response in the voltage and frequency will affect the image quality of the scan. Also, regenerative loads, elevators. As the elevators goes down, it becomes a source of power, and it will be absorbed by the engine. So you need to oversize a bit. Otherwise, your genset will overheat. Makina mo hindi kakayanin, palalo na pag maraming elevators. And BFD, these are the harmonic generators, will affect your winding and the cables going to the loads. And also, the motors, high inertia, will also affect during starting, but the lightings nowadays are less prevalent, especially with the LED technologies. So, to sum up the simple arrangement in healthcare facility, you have this generator, this one. I remember the one speaker from Cummins, so that is what I said to him. I've been a user of Cummins. I ordered a lot about this one. And you have your ATS, and you have your low voltage switchboard, and you have your utility incomer. Very simple arrangement. But you will find also that in healthcare facility, it's not only low voltage. There are healthcare facilities employing 13.8 medium voltage, as in this. So this is one of the plants where I was engaged, I was involved during the design and commissioning. So we use 13.8 switch gears. This one, we have SF6, and we have also vacuum circuit breakers. These are fed to the rings, including healthcare facilities. As in this one, SF6 and the inside of the PCF6 compartment. You'll find the CTs and the high tension cables and the grounding links. Also with the vacuum circuit breakers and as a requirement and medium voltage applications. So that ends my presentation, and I hope and I'm really happy that I was part of this endeavor with your IIEE summer chapter. Thank you so much.
Thank you so much to our resource speaker, Engineer Benj Simeni on electrical system design for healthcare facilities. A round of applause, please. Yan, ang daming mga clapping hands na naglalabasan ngayon sa ating screen.
Thank you sa inyo lahat.
Opo, sir, so far wala pong question.
Good. Thank you.
Upon checking with our chat group or chat box. However, they're asking for your presentation daw po.
Of course, ma'am. I will share this one. Okay.
Okay po. Sige po. And of course, sir, we will not let you go. We will not let this afternoon and magagabi na eh. This afternoon pass, of course, without giving you or awarding you this plaque of recognition. Institute of Integrated Electrical Engineers of the Philippines Incorporated, Eastern and Central Visayas Region latest summer chapter. Plaque of recognition is hereby presented to Engineer Benji R. Simeni, in grateful acknowledgement of his invaluable service rendered as technical resource speaker during the 22nd Eastern and Central Visayas Regional Conference, given this 20th day of July year 2023 at Summit Hotel, Tacloban City. Sir, maraming salamat.
Thank you, good ma'am. I hope I will receive this plaque on time, in due time.
Yes po. I think
this is the second actually, ma'am. This is the second because in Cebu, the regional conference, I have not received until now. So just to remind those officers last year. Thank you.
The chapter president for latest summer messaged me a while ago that all of the plaque of recognition, especially since this is a virtual, will be forwarded tomorrow at the Summit Hotel during the conference, because tomorrow we still have set of activities. Okay. Pero sabihan po natin talaga sila that you should be receiving that plaque of recognition. Makakarating po sa ating mga organizers.
Thank you.
Thank you so much. And of course, we are now down to our last topic for the day. Parang kanina pa tayong 9 hanggang ngayon. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8 topics. So okay pa naman po ba kayo? Parang medyo lumiit na po yung participants natin kanina from 150, medyo 123 na po tayo. Perhaps because of the intermittent network connection and Wi-Fi connection ng ibang mga members natin. Kung kaya't hindi ko na po papatagalin, we will be proceeding with our last topic for the day. So this will be on LV circuit breaker short circuit current evaluation and sizing using the IEC standards. Ladies and gentlemen, para po sa ating pinakahuli, last but definitely not the least resource speaker for the day, let us all welcome with a big round of applause, Engineer Russell C. Paragoso. Hello, Engineer.
Hello, good afternoon. Sorry, I will be not using my camera. Ano siya?
We understand po. We understand, Engineer, kasi kanina po din yung ibang mga resource speaker actually parating nalalag out. Maybe perhaps because of the internet connection. We understand that one po.
Yes po. Wait lang po.
Engineer, we will be given an hour for your presentation, and I will be interfering 10 minutes before the time just to heads you up that you still have 5 minutes to wrap up the case. Para kung mayroon pa pong mga question, po tayo to answer the same. Thank you po. You may now proceed.
Yes po. Hello, good afternoon once again. So we will be discussing about the low voltage circuit breaker short circuit current evaluation, and we will be using the IEC standards. So Okay, so our objectives, no, kasi mostly we if nakikita niyo maraming bumibili ng mga breaker, and most na available is yung mga rated na I mean IEC rated. So here in this seminar we will be familiar sa ratings na that is available on the nameplate, I mean nameplate or on the tagging of the breaker. At least we know if we are applying it correctly. No, so it is about the low voltage installations, and we always I mean I assume na the installation that is being considered here is radial and non-mesh, no? So almost naman yung mga low voltage natin is radial in configuration. So okay. So first is we have to understand, no, intindihin natin yung IEC 16909, which is the IEC short circuit. We know na when we are in college, no, so we were taught fault calculations, no, and if you're going to relate it, hindi siya direct na ma-apply natin, no, although yun ang ginagamit natin paminsan-minsan, and others yun talaga yung ginagamit. So actually it is called a classical fault calculation. Then we have the IEC, and we also have the ANSI na calculation. And also meron pang isa na parang yung common ba, yung sa Russia, yung ghost na na standard. So ito sa IEC, to have an overview, so it is actually a standard, no, divided into 5 parts, no. So -0, -1, -2, 3, and 4. So the -0 actually already provides the parang overview of the short circuit calculation, and it is quite different on the usual short circuit calculation that we usually do, no. So and if you go to the part 4, so it has also the certain examples, no. So and you will notice in the examples of the IEC 6909 standard, they are not using per unit calculation. They are using the direct direct amperes na result sa calculation. Although we will have an example later on, I will be using a per unit na calculation so that we could apply, no. So it is still applicable. So okay. So the IEC 909 is actually applicable to low voltage, the high voltage three-phase systems, and those with frequency 50 or 60 hertz. No, so yung parang zest lang no ng IEC 909 is that first parang i-calculate mo yung tinatawag na I double prime sum K, or the initial symmetrical short circuit current. Now with that value, parang i-derive mo yung ibang other values niya, like once ma-derive mo, pwede mo makuha yung peak current, which is used for the bus bracing ng mga bus bar, at saka yung making current ng mga breaker. Then you could also get the interrupting current, no. So then in this side you could get the steady state, and then you could also get the thermal equivalent, no, yung ginagamit na current withstand. So yun ang process. So this diagram will guide you no, to kung paano siya at least makalculate. So these are the definitions, no? So I double prime K, initial symmetrical short circuit current. Yung IEC standard, parang yung short circuit niya, it designate K, no? K yung ginamit. Iba yung parang parang coding nila ba. So we have the peak current, so the maximum possible instantaneous value. Then we have the symmetrical short circuit breaking current. No, so it is the from the name itself, you know, it is the breaking current. Then also you could get the asymmetrical with that. Now then we have IK, which is the steady state short circuit current. Then the IEC has also a term na equivalent voltage source. No, so if you remember, whenever we calculate short circuit currents, no, so we usually do 1 over impedance, no, 1 over Z, or 1 over the Thevenin equivalent. Now in IEC standard, they have this equivalent voltage source, no? So there's a voltage factor C that is being multiplied with the voltage, no? So this is to parang ano lang siya ba, parang worst case scenario, parang gano'n na kung ano yung voltage niya na gagamitin, parang pre-fault voltage niya. So actually there are, if you are doing studies using software, actually you could see it now in the options sa mga software na there is also an option na you could do a load flow, then kung ano yung voltage na nakalculate niya with the location kung saan mo gusto mag-fault, do a fault calculation. So yun ang gagamitin niya. Then yung sa IC, pwede mo siyang gawin na ganun, but it will be multiplied by a voltage factor. So the IEC also, it has a para siyang distinguish na yung current, yung nag-contribute sa fault, as far from generator as well as near to generator. So how does it determine? So by using this particular equation, if the initial symmetrical fault current is less than twice the rating, the full load current of the generator, so you would consider na it is far from generator. Then opposite niya is near to generator. So that will affect, it will have an effect sa coming calculations. So it is important na we have to determine sa current contribution. Then we have also this definition, minimum time delay. So it is the shortest time between the beginning of the short circuit and the contact separation of the first pole. Then we have the thermal equivalent. Now the terms here in IEC, hindi natin siya direct na nakikita sa mga breaker. Rather, they have a different, different parang mga letters ba na ginamit. But later on, we will know na they are just related. So the calculation assumptions of the IEC is based on this simplifications. Letter A, the type of short circuit doesn't change within the duration of the fault. So meaning if you have a 3-phase fault, it is always 3-phase, so all throughout. hanggang mag-trip yung breaker. So ganun siya yung ano niya, yung assumption niya. Then no network change during the fault duration. So network change meaning may, let's say, may ibang source na nag-separate. So ganun. So walang ganun. So kung ano yung circuit diagram na kinakalculate mo, yun pa rin hanggang matapos mo yung calculation. Then the transformers are referred to the nominal, no, or the main position. Then arc resistance is not considered. Then we have the shunt admittances of non-rotating loads shall be neglected. So mga capacitance, no, sa loads. Then line capacitances shall be neglected, no, in positive and negative sequence. Then line capacitances in zero sequence shall be taken into account, but mayroon siyang guide na if the earth factor is higher than 1.4, so then magnetizing admittances of transformers are neglected and all in positive and negative sequence. So that's the usually naman pag nag-calculate tayo, ang mga assumptions dito is we ginagamit na natin, no, so mostly sa mga calculation. So the method of calculation is that actually it has three, no, ang pag nag-calculate ka using the IEC, it has methods, you know. So if you look at the standard, so doon sa examples na part, you would see na it has different approaches, no, sa fault calculation, di ba? Yung sa atin, usual nating ginagawa is yung number 1, na we have an equivalent voltage source, then tapos yung fault location or yung fault point. So that's why we always reduce the drawing to Thevenin equivalent, tapos then we calculate. But there are other methods, you know, like number 2, so superposition method. So especially if you're going to consider the load current, no, tapos ng short circuit. So if you're going to add the load current in conjunction pa doon sa short circuit current, then number 3, it is also the transient calculation, no? So ito mas mabigat yung transient calculation. Then we will just focus on method number 1. So here in every in every short circuit calculation, or not really short circuit, no, pati other types of power system analysis, it is important na we have to know the model, no, of the electrical component na being considered. So here, so the IEC will tell us kung paano yon i-model. So to start, it has a sample model of a typical system. Then if you're going to calculate the fault current, so everything here in the diagram will be converted, no, to the impedances. So here, so ito yung equivalent nila. So mayroon siyang, they have also a different coding, no? So this will be the equivalent niya. Then here is the equivalent source, no? So at the fault location. Then with that, kung alam mo na yung voltage niya dito, then you just have to divide the the impedances, then you could calculate the short circuit current, no, the initial symmetrical short circuit current. So this is the table for the voltage factor, no, so that you would get the equivalent na voltage source. So for low voltage, we have 100 to 1000 volts. So we have the short circuit, maximum short circuit or maximum short circuit current, and as well as minimum. So at least no, si IEC, it's very clear no na you could do maximum and minimum short circuit calculation. No, you could vary the value of C to get the maximum or minimum. But meron siyang table to guide us. So like this one, so it has let's say 1.5 or 1.05 or 0.95 for either maximum or minimum. No, so yan lang yung for high voltage. So meron din siyang mga values. So so yun ang magiging guide mo for the voltage factor, no. For the ANSI, I think it is just 1.0, no, na value yung gagamitin. So here we will be focusing on the short circuit impedances, no, of electrical equipment, yung equivalent nila or yung modeling. So here we will be focusing on the six common network components, no, the network feeder or the utility, the two-winding transformer, overhead lines and cables, then the synchronous generator and motors, asynchronous motors, and the power station units with full-size converter or inverters, no. So there are other equipment stated on sa IEC 16909, and actually IEC ko lang nakita na mayroon siyang discussion or clause na dinidiscuss niya or binibigyan niya ng interest yung mga inverter, no. So minsan pag nag-calculate tayo what is the current contribution of the inverter, so ganun. So usually when we do the calculation, minomodel natin siya na impedance with a voltage source with impedance, pero sa IEC hindi pala siya ganun sa pagka-model. So for the network feeder or the utility, so we could model it if we have the values, no. So yung value na kailangan natin is the three-phase fault with X over R and the single line to ground fault, no, with X over R. So with that we can derive the values of the sequence impedances, no. So from three-phase we could derive the positive and the negative sequence, and for the single line to ground fault, since meron ka ng positive at negative, you could derive the zero sequence fault. So the coding na binigay ni IEC, it is using as the Q. So Q, it would mean the grid, no, or the network feeder. Then you should also notice na pag solve mo yung impedance sa source, hindi siya direct na gagamitin sa calculation. It has to be multiplied with the value of C. So kita mo sa equation may C. So kaya final na impedance sa utility or source impedance, so would be ZQ1 equals C times the source impedance. So mayroon siyang C. So ganon yung ano niya, equivalent niya. For the transformers, so usually naman ang given is percent Z, no? So given. So yung percent Z, so ano lang siya, mostly ginagamit sa directly noise, so usual natin na calculation. But if you have the transformer load loss, you could calculate the R and X, no? Pwede mong ma-derive yung R and X. Sometimes if not given, there are standards, no, na X over R is you could obtain the value of X over R, no? Meron na siyang graph, then you could parang i-interpolate mo, then you could derive on that. Then after makuha mo yung impedance, you are to multiply it with a correction factor, no, na KT ang tawag niya. Now, what's the formula for KT? So actually it is this one, no? So 0.95 times C max divided by 1 plus 0.6 times XT. So ganun siya din. If you don't know the impedance, no, for a given transformer, mayroon ring suggestion si IEC to use this formula, no? So short circuit voltage, so at rated current, it's just the same as the impedance. So with that, pag nakuha mo siya, then you could equate the impedances to it is the same, no, sa lahat ng sequence network. So only that the configuration lang yung mag-change, no, sa transformer. But the value is that's the same. Then for generators and motor, so the same, no? Given is the XD double prime or the subtransient reactance, then sometimes hindi mo alam yung RG. So actually the IEC has also a guide, no, kung paano siya ma-derive, no. Later on in our example, ang ginamit ko siya. So or if given na doon sa datasheet, mas mabuti. Then we will just multiply the whole impedance, no, with a correction factor kg, no. So kg, so this is the equation of kg. So if you notice na every impedance na involved dito sa IEC, it has to be multiplied, no, of some sort of correction or a voltage correction factor. Then for the negative sequence, so ganito siya, multiplied pa rin with kg, and if the negative sequence reactance is not given, you could use this equation, no, the subtransient direct axis na impedance with the quadrature impedance, so divided by 2, so you could use that formula. So but the idea is still the same, no, na if you already have the impedance of the generator, positive, negative, and 0, you just have to multiply it with a correction factor kg. So for the motors, no, for asynchronous motors, so I think it is just similar to IEEE, no, na if you are given the locked rotor, then if you're going to divide it with the FLA of the motor, so it would be times the FLA, then you would divide it by 1, so it is the per unit impedance of the motor, no. So actually it is just the same, no. But the IEC has also a guide kung paano mo siya i-separate to X and R. So I think in most cases, no, the IEC is trying to not utilize na X only, but ano talaga yung X and R, no, yung calculation niya. So ito yon, if you cannot obtain, no, the R, so you would use this guide, no, sa IEC. So depending on the size of the motor. So if your motor is less than 1 megawatt for high voltage motor, so you could use this relationship, no, for low voltage. So this one. Then for inverters, no, so inverters are different, no. They are parang unusual ba. So they are not modeled as voltage source, no, but rather they are current source, no, in the positive sequence system. So when you calculate, actually it makes our calculation somewhat difficult, no, if we do it manually. So nakay voltage, then you have the voltage, then you also have the current source, no. So when you calculate, so you will do the other network theorems that we learned, no, in college into calculate. So there's also a note here na if their contributions doesn't exceed 5% of the initial short circuit current, so it may be neglected. So for me na if I do calculations with inverters, so I usually ask specs, no, of the inverter, and sometimes the inverter has mayroon silang manufacturer notice na yung inverter nila is ganito siya mo-contribute ng current. So like I think SMA na inverter, mayroon siyang note na manufacturer note na they could convert or they could contribute na ganito na fault current then with this time. So ganun siya. So the importance of short circuit currents, no, so for maximum currents, no, for dynamic, no, for I think mga bracing, mga ganun, IP is needed, no, for switching on the device. So IP, so making current, so IP, we need to know the peak current. And for switching off or the breaking of current, no, so we also need the IB. Then for components na to be tawag dito yung ma-expose ba sa fault, you need the thermal, no, the thermal equivalent. So ganun siya na ano. However, if we look at the breakers, ganito yung makikita natin usually, no. If you have a breaker tapos tiningnan mo yung ano niya, yung parang nameplate, diba, or sometimes kasi sticker, no, sa low voltage or printed siya, then ito yung makikita natin usually, no, although hindi minsan hindi lahat ng values makikita mo, but you would see na yung iba mayroong ICM, yung iba wala, but ICS and ICU, yun yung mostly natin makikita. Then we have also ICW. So yun ang usual na parameter na makikita natin. In terms of the device, no, capability. So ICM, it will relate to the making current, no. So ICM, so current making. Then for the ICS, it is relative to the braking. Then the ICW, it's related to the thermal. So sa short circuit calculation, so ito rin yung mga terms, no? So yung ICM para, it's related to the peak, no? It's equal to the peak current. Then ICS or ICU, so related siya doon sa IB symmetrical or the symmetrical braking current. Then we have the ICW doon sa thermal. So ito kasi na mga variable dito, ito yung nasa IEC na 60909 na standard. Then ito naman yung makikita natin sa breaker. So that's how we relate them, no? It is important na alam natin kung paano sila i-relate. So in relation lang to ANSI, kasi sometimes some of us are more inclined to do ANSI calculations, not to, just to compare lang. So sorry, for ANSI, so ito siya, no? First cycle current, sa IEC it is the initial let's short circuit current, no? So close matching duty, so that's the peak. Then interrupting duty, so braking current. The time delayed 30 cycle current, that's the steady state or the IK. Then compact parting time, so that's the minimum time delay. So at least when you have these terms, no, you could relate, no. It doesn't mean na these are equal, no, kasi they have different methods of calculation, but at least you could relate, no, sa meaning nila. So for the breakers, no, let's familiarize the parameters sa breaker. So for the ICM, so it is the rated short circuit making capacity. So sometimes when you look at it sa breaker, hindi yan siya available, no. So it is the value assigned to that circuit breaker by the manufacturer for the rated operation voltage at rated frequency and a rated specified power factor, no. So to make it short lang, this is minsan not found, no, in the breaker, but you could see it in the data sheet minsan. But if you don't know the value, you could always look at the IEC, no, 16909 table 2, then you could derive the value of ICM. So for example, this is the breaker, no, compact NSX 400F, no. So the breaker has the value of the ICU and the ICS, no. So ito yung mga value nila. Then remember na it is at different voltage, no. So for example, at 440 volts, no, so you could get the making, no, or the ICM. It is just equal to N times CU, no, ICU. So N would be based from the table, no, depending kung ano yung value ni ICU. So si ICU 30, so if you look at the range, so it is within this bracket, no, 20 from 20 to 50. So the multiplier is 2.1, so you could use 2.1 times 30, so 63. So yung yung 30 kiloampere na ICU sa breaker na ito, it's meron pala siyang 63 kiloampere na sa ICM niya na value. So with that, alam mo na yung value ng ICM niya, so which is used for the evaluation. So we have the ICU, so it means the ultimate short circuit braking capacity. So actually it is the maximum symmetrical short circuit current, no? The breaker can interrupt, no, sa ano, but when it interrupts, no, so hindi mo na siya pwedeng gamitin basta nag-fault, I mean nag-trip siya sa ICU na value. So you just have to parang nag-open siya, but you have to check it kung nag-open ba talaga siya pure. So ganun siya. So you cannot parang hindi mo na siya magamit ulit. So kaya tinawag siya na ultimate, no, kasi parang pang-last na siya. So then we have the ICS, no. So service, no, service short circuit braking capacity. So dito naman sa service ano sa ICS is that when the breaker trips, no, so it can be closed again. So kung nag-trip siya sa value ng ICS, so it can be closed again. So actually you could 3 times, no, it can ano, it can, you could use it, no, interrupt 3 times and be returned to service, no. So ganun siya. Now however, yung breaker is ano siya, since dalawa, you could specify kasi na anong value ni ICS in relation to ICU. So kung dito if you could if ma-notice nyo, it is ano, no, equal. So this it would mean na ICU is equal to 100% of the ICS, no. So yung ibang percentage kasi it would mean I think may difference yan sa cost, no. So but when you compare the braking current doon sa calculation mo, actually you have the option. You could compare it with ICU or ICS, but you have to note that if ICS mo gagamitin, so you have still 3 times, no, to use it again. Then if ICU, pag lumampas siya doon, I mean nag-trip siya doon, then you could not use it again. So you have to replace it. So ganoon siya. Then we have breakers also na meron siyang utilization category, no. So A and B. So I think later on ma-discuss ito. So we have a certain example, no. So the breaker is rated as follows, no. So yung ICU, ICS niya is 50 kA slash 38 at 400 volts. Then the short circuit is rated, the short circuit calculated current, no, is 42 at 480. So remember na they have different voltages, but if ganito lang yung available, so for mapamandalian na comparison is that if you compare it with the ICS, so it will fail, no. So it will fail, meaning na so it will fail. But if you compare it with the ICU, so it is still okay. So actually magmatter siya, no, kung saan mo i-compare. So is the breaker okay or not? So for the ICU, no comparison, it is okay. So for the utilization, so we have category A and B. So category A breakers are not specifically designed for discrimination applications or for coordination purposes, no? So this breaker, the reason why these are not for discrimination, it's because these breakers cannot withstand, no? Wala siyang parang withstand value ba. So that's why if you look at the data sheet, parang wala siyang value. And if you do thermal equivalent na calculation, it will always fail. And it is also the reason na pag tiningnan mo yung curve nila sa mga category A breakers, they always have this instantaneous curve na nakaset na ba na minsan hindi mo siya ma-change, or kung pwede mo ma-change, so limited ka lang sa value. So it is prone to miscoordination, but it is designed that way, no, para pag may fault, ma-interrupt siya kaagad. So ganun siya. Then for category B, so designed for discrimination. That's why it has a component or a parameter na ICW sa nameplate niya. So kasi it has to wait, no? It has to wait before siya mag-trip. No, so it has to withstand that value of current, no, para hindi siya masira. So ganun siya. So for the IB symmetrical, so yung breaker kasi natin, for example, given yung value ng ICS or ICU, like this one, 50, so we could obtain the IB asymmetrical. So what's the purpose, no? So actually, it is part kasi siya sa comparison sa evaluation. So you have to get the IB asymmetrical. Yung mga breaker natin, let's say, tulad ito na 50, so we need to get yung IB asymmetrical niya na kaya niya. So this is the table kung paano siya makuha. So here, we have 50, for example, this is the ICU, so IB symmetrical niya is 50, then meron siyang minimum time, then pag nakuha mo yung IB asymmetrical, so ito lang yung value niya, 0.003. There are times kasi na when you do compare, pwede siyang pumasa sa IB symmetrical, but yung IB asymmetrical, hindi siya papasa. So mayroong times kasi na ganun. So that's why dapat silang dalawa, symmetrical and asymmetrical, papasa siya. So this is the guide para makuha mo siya. So for the ICW, so no, it is the short time withstand current, no, so assigned to the breaker. So it is expressed in Ka, and it has a corresponding time. So it could be 0.05, 0.1, 0.25, 0.5, 1, or 3 seconds. No, so like this in the example, we have ICW, so 19.2 Ka at 1 second. Then we notice na category B siya. So this breaker is designed for coordination. Sorry. So ganun siya, no? Then actually just for ano lang ba, sake lang, no, calculation, meron kang yung short breaker na malilit like 50 amps, for example. Actually, pwede mo makuha yung equivalent niya na ICW, no, based on this table. So if you have 50, then you would 50 times IN, 12 times 50 or 5 Ka, kung sino ang mas malaki sa kanya, so yun yung gagamitin mo na ICW. So pwede mo siyang ganun, no, if hindi siya available, like this one, let's say greater than 2,530 Ka, So it is possible na ibang value. So you have to use the actual value of the ICW. So another example, we have this Terasaki breaker, no? So here we could see na ICU is equal to ICS. So if we are going to examine the 220 to 440 volt, then that would be ICU equals ICS, so 100K at 220 volt to 440. Then if we're going to obtain the ICU, so that would be 2.2 based on the table, no? Then times 100, so 220 PA. Then ICW, so it's given like this one, no, na yung given niya, it is 100 KA. So yun ang gamitin natin, no, na value. Then we could also identify na once merong ICW sa nameplate, category B talaga siya. So yun, no, sa natin, sa breaker. So to give an comparison, no, with the ANSI, so if we're going to check sa ANSI, I think ito lang yung value na makikita natin, no, interrupting capacity lang talaga. But I think sa analysis sa ANSI, you have also to still to compare the other values, no, making especially sa high voltage. So ginagawa yan. So we have an example, no, of a sample system. Then we're going to evaluate the breaker, no. So for calculation purposes, so I just made the breakers dito na the same rating, no, silang tatlo. Then place it in this location. So we would have a grid, no, contribution. We have also the generator, and we have also the motor, no. So paano siya first is that paano siya calculate sa IEC. So this is the way IEC calculates, no, it has to, for example, I'm going to calculate D, no, the fault at this bus, no. So we have to check kasi na pag may fault dito, so yung current kasi sa grid hanggang dito lang, but yung contribution mo from the generator and motor papasok siya sa CB1, no. So pag fault naman nandito, so contribution ng grid ng motor pag ganun siya. So kung titingnan mo, mayroon siyang variation sa values, no, but ultimately pag fault ka sa D, summation ng tatlo. But if you also try to think, no, pag yung fault nasa loob ng breaker CB1, CB2 or CB3, it will just be equal to D, no. So summation ng lahat, no. So ganun siya. And if you're familiar with mga kanang software, no, electrical, power system softwares, no. So they have the option, no, na pag nag-evaluate ka ng breaker, ano ba? So it is the total fault current or yung current lang talaga na dadaan sa kanya na maximum. So tulad nito, if you're going to, let's say, evaluate CB1, anong fault current gagamitin mo? Is it yung A na dadaan sa kanya pag nag-fault si D, or yung current ni C at saka plus ni IB, plus ni B na which is papunta dito pa ganun. So mayroon siyang ganun na option. But we know now worst case scenario is the summation sa tatlo, which is also possible na mag-exist if mag-fault yung breaker, I mean internally, no? Pag nag-fault sa loob ng breaker. So okay, so we will try to calculate, no? So sa IEC, it is treated per per contributing branch, no? So ganun siya for the utility, I mean to the grid, so ganito siya. So first is to establish the base, no? So let's say base 100, MBA base 100, then KB base, then our I base. Then yung given sa network is ang three-phase niya na fault is 20 kA with X over R12. So we need to convert this one to impedance. So ganito lang yung formula niya. I base divided by the fault level, then arc tangent of X over R. So then you would obtain the impedance, then multiply the correction factor. So since the voltage is 13.8, so if we look it back sa table, dito 13.8, so 1 kV to 230 kV, that's 1.1. So kaya 1.1 yung ginamit doon, so 1.1. Then multiply it with the impedance, so the resulting impedance na would be this one. Then for the transformer, so since given naman yung impedance at X over R, so you already have the impedance, no, of the transformer. Then you just calculate the correction factor KT, no, so multiply it with the impedance, then convert it to the base impedance, no, kasi we're using per unit. Then we would obtain this value. Then with that, meron ka ng impedance, then you could actually calculate the fault, no? Kung may fault ka dito sa bus, then you could calculate. So ganito lang yung calculation na instead of 1 over the impedances, it is C divided by the sum of the impedances. So you would obtain this initial symmetrical current. So nilagyan lang siya ng T to mean it is coming from the transformer, then multiply it with the base, then we could obtain the actual value, which is this one. Then pag solve mo yung initial symmetrical current, short circuit current, then we could obtain the peak, the breaking, as well as the IDC, no? So here, to calculate the peak current, so meron siyang formula. So 1.02 plus 0.98, so e to the negative 3 over X over R. Then substitute everything. So the X over R is the X over R looking back, no, sa branch. So looking back sa branch. So that's it. The value there is ZQ plus ZT. So yung kinuha. So then nakuha natin yung value ito. Then the peak current is the factor times the square root of 3, then times the initial symmetrical current. Then we would obtain this value. Then for the breaking current, so actually it is just the steady state, no? I mean the breaking current, since wala naman siyang it's not like the generator, so ganito lang siya. So yung value niya diretso lang, equal to the initial symmetrical. Then for the DC component, so that makuha natin yung asymmetrical, So actually meron lang siyang formula. So just substitute to the formula, then we could obtain this one. Then for the asymmetrical, so it would be the AC plus the DC. No, so then use only the magnitude, then you could obtain this value. For the steady state, so equal lang siya sa initial kasi wala naman siyang yung grid naman natin or contribution ng transformer, hindi naman siya magva-vary with respect to time. So ito yung makukuha natin na value. So
Engineer?
hello?
Hello, engineer. Yes po, last
Sige po.
yes po. Last 5
Sige.
minutes. Thank you po. Thank you po.
Sige po. So here, in this example, nakuha natin yung current, then we just compare it with a certain software. So yung initial natin is initial peak at saka yung ibang currents, it is just equal to the manual calculation. So ganun lang siya. Then the same thing with the other branches na kinuha natin. So follow lang dito sa calculation at saka may mga values kung paano makuha yung ibang value na hindi available like this one. Then you could also obtain the currents, Then ultimately makuha natin yung 4 na value. So yung generator lang is meron lang siyang, you have to use the curve, kasi yung steady state current niya, yung factor na i-multiplied niya is based on the graph, So tulad nito mayroong graph na cross natin. So but you can refer to the presentation, i-ano naman natin ito i-provide. So here it is still checked with the software, kinumpare siya if tama ba yung manual. So pareho naman. Then for the motor contribution, so the same thing. Then kinumpare silang tatlo yung value. So kung paano sila i-add. So ganito sila. Then after natin makuha yung ABC, or we would use D para maximum sila, then ito na siya. So i-compare natin sa device. So for example, ito yung natin sa breaker. So yan yung magiging equivalent niya. Then we have to compare the calculated. So ganun. So ito naka-red dahil fail siya lahat. So you have to follow this one kung magsa-size ka. So ganun siya. Then actually we were not still calculating the ICW. For the ICW, ito yung formula. So madugo siya. So ganito. So it is just the initial symmetrical times the square root of m plus n. So ito yung formula ng m, then yung n is ito. So we have still an example, or kung hindi ka gagamit sa formula, mayroong graph. Then we have the example for the generator. So kinakalculate natin. So ito yung m, ito yung n based on the graph. Then if we going to calculate, so ito siya. So we have to medyo maraming number. So ito yung value niya, then ito yung nakuha natin. Then kinumpare natin siya sa software. Actually, so ito yung calculated natin 0.1021. Sa software is 10.225. So may konting difference. So meron tayong estimate dito in case hindi mo kaya mag-calculate nito. So you have just to make sure the ICW is greater than the initial symmetrical current and the steady state. So final thoughts, ito yun. So here, sa atin lang is that we know yung breaker mayroong mga label. So at least we know the labels, kung paano siya i-interpret and how to compare the study. So yung short circuit calculation natin has to be the IEC 60909 para valid yung comparison natin. So I think yun lang siguro. Thank you for listening. Hope may natutunan kayo. So thank you.
Thank you so much, Engineer Russell C. Paragoso. A round of applause. Ayan, nagliliparan po ang mga clapping hands. Thank you so much, sir. Bagamat po nagkaroon ng delay, thank you so much for staying and for sharing your time. Are there any questions? Let's check on our chat box. So far, wala naman pong question, Engineer. Humihingi lang po sila ng copy ng slides.
Yes
Kasi
po, after the...
napaka-essential po. And maraming nagpapasalamat po dito sa ating group chat. And of course, to formally thank you din po, we will also be awarding you this plaque of recognition. Citation reads, Institute of Integrated Electrical Engineers of the Philippines Incorporated, Eastern and Central Visayas Region latest summer chapter plaque of recognition is hereby presented to Engineer Russell C. Paragoso in grateful acknowledgement of his invaluable service rendered as technical resource speaker during the 22nd Eastern and Central Visayas Regional Conference. Given this 20th day of July, year 2023 at Summit Hotel, Tacloban City. Thank you so much, sir. Maraming salamat po. And ayun na nga po, tomorrow, of course, that will be the official opening day. Ayan, that is the official opening day po of our 22nd Eastern and Central Visayas Regional Conference. So we will be seeing each other at Summit Hotel. And the registration will start at 6:30 in the morning to 8:30 in the morning. And the opening of exhibits will start at 8 o'clock. And preliminaries, the program will officially start at 8:30 to 10 a.m. So sa mga participants po natin who will be traveling pa po from the different parts of Eastern and Central Visayas, papunta dito, or yung iba na andito na po, we will see you tomorrow po at the Summit Hotel. So again, registration starts at 6:30 and the program will officially start at 8:30 in the morning. So maraming salamat po sa ating 112. So we still have 112 who stayed until the last topic for tonight. Thank you so much for staying and we will see you again tomorrow. From the Secretariat, meron pa po ba tayong ibang announcement? Wala na po ba? Wait lang ha. No more, ma'am. Okay, so I think we'll have to call it an evening. Opo, kasi of course we will have to to freshen up para relax tayo for tomorrow's activity. May nagtatanong dito, I believe it was already answered, kung meron po bang attendance, links sa attendance. Sinagot na po ito kanina ng ating staff, ng ating secretariat. Wait lang ha, basahin ko po sa baba kasi nasa baba na po siya. So wala, to all the participants daw, walang attendance. Everyone is checked through Zoom kasi anyway it's recorded naman po. So recorded po yung Zoom meeting natin from kaninang 8 o'clock. Henceforth wala pong link for the attendance. But I believe baka siguro may ibigay na form for the pagbigay siguro ng or pag-summarize or for your feedbacks on the na-conduct natin na forum or ng ating virtual forum for this afternoon. So ayan po, wala na po. So then we shall call it a night. Thank you so much for everyone. This has been your host. I am Attorney Barbacho and Magalona Badok Reposar. And for those who will be attending tomorrow, I will see you tomorrow and on Saturday para po sa ating 2-day regional conference. Sige po, good night and you may all log out now and leave the chat room para po makapag-rest na din po kayo. Thank you so much again to all of our resource speaker from the first resource speaker from Engineer Magdaleno Baclay Jr., Engineer Virgilio Lozares, Engineer Junril Novicio, Engineer Raulito C. Baldonado Jr., Engineer Adrian L. Ray, Engineer John Lex James Canoy, Engineer Russell Paragoso, and of course, Engineer Benji R. Simeni. Of course, pasalamatan din po natin ang ating mga sponsored technical presenters. We have, of course, Cumin Sales and Service Philippines Incorporated at ang ADMI Philippines Incorporated. Maraming salamat po, and we will be logging off. See you all tomorrow. Good night!
For more than 4 decades, IIEE has always been committed to its core values of integrity, innovation, empowerment, and excellence. Founded on September 15, 1975, the Institute of Integrated Electrical Engineers of the Philippines, Incorporated, IIEE, is registered with the Securities and Exchange Commission, SEC, as a non-stock, non-profit technical professional organization accredited by the Professional Regulation Commission, or PRC. IIEE started with 500 members and now has grown to a more than 60,000 membership base, with local and foreign chapters in active service across the whole world. Through the years, IIEE continuously commits to upgrade the professional credentials of its members through the Continuing Professional Development, or CPD programs, enhance their social standing through the promotion of high ideals of integrity and ethics, facilitate advancement of technology transfer through carefully conceived educational and training programs, and provide opportunity for regular interaction among electrical practitioners. Inspiring future electrical practitioner leaders, IIEE organizes activities such as conferences, conventions, and exhibits showcasing the latest technologies, trends, products, and services relevant to the industry, motivating the members to be globally competitive and be able to adequately adapt to the changes, needs, and developments that constantly occur in the electrical profession. IIEE activities are planned to be a venue of endless possibilities, new ideas, and valuable market trend insights on energy-efficient products and services. IIEE is working together towards one certain goal: to continue to move globally forward so that the Institute will be an esteemed organization with the mission to excel and the vision to lead.